temperate cyclone and tropical cyclone. And after understanding the tropical cyclone, we'll also understand the tropical cyclone in India with the different phases. And so before starting with the temperate cyclone, it is very much necessary that temperate cyclone formation completely depends upon your, I said that front formation. So the first we'll start with, I said that front, and I said that before starting this front, you should be aware of some pictures. So this front formation is taking place in the region of, I said that this is subtropical high pressure belt and this is polar high pressure. So the westerlies, warm westerlies, and here we have a cold polar easterlies. So this is the zone of, I said that, this is the zone of transitional zone along the, I said that 50 to 60. तो आप लोग जो भी हैं लिख के जाएंगे whatever you think. And 50 degree to 60 degree north. In the similar manner, in the southern hemisphere we have, I said that, there is an westerlies are there and there is an, I said, polar easterlies, cold polar. And this is the reason we have been, we will be able to get, I said, यहाँ पर हमें क्या मिलेगा, temperate cyclone. And in this reason. This is the reason, but before starting this one, so before starting of the temperate cyclone formation, there will be some kind of front formation will be there. And there will be types of fronts, like I said that a stationary front will form. And then a stationary front and thereafter there is a formation of, I said that, cold front and warm front, and thereafter it is occlusion front. And there will be two types of occlusion front. It is warm occlusion front, another I said that cold occlusion front. Okay. And warm occlusion front and cold. And you know that there is some picturization for this, for the everyone. Picturization, I said that some way you can present it, like I said, cold air is more pinching to the body, yes. So therefore, आप याद रख सकते हैं कि that cold front is represented through triangle. So the triangle is a representation of what? A triangle, the corner parts, it will pinch more in your body. So you can, and warm air is less pinching. Then you can remember, like I said, that semicircular structure is represented by warm front. And you know that the cold air, it is coming from here. Cold, this is in a cold polar easterlies. And when the cold polar easterlies is coming, so what it will make? It is going to just ऐसे याद रख सकते हैं. This is cold triangle. And from here, warm easterlies, warm front kind of it. Means both are making a stationary front. So this structure is represented as an what? Stationary front. समझ में आ गया? Why and how? And both are what is in a waiting? Stationary हैं. Both are what? At a place like I said that stationary front को हम लोग कैसे represent करेंगे? The cold air is coming from this side, so it is and from here it is, I said, which one I said? Wow. So this is a stationary front, and for occlusion front, so पहले हम लोग समझेंगे कि front कैसे बन रहा है. You know that, and you have to remember this line so many times. I said that warm westerlies are coming under the effect of Coriolis force, understood, and they are coming from southwest to northeast, and then cold polar easterlies is coming from northeast to the what I said that southwest. So I said that at 50 to 60 degree latitude, warm westerlies and cold polar easterlies of contrasting nature of air masses meet. Yes, they are what is the nature? Contrasting, and they have a discontinuities in the form of temperature. They have a different temperature. One is more cold, another is warm. Discontinuities in the pressure. One has a comparatively warm air has a less pressure, and the cold air has a more pressure. And then discontinuities in the humidity in the form of, I said that cold air it can have hold less moisture, and the warm air can more. Understood? So I said that because of two contrasting nature of air masses, कोई दो चीज मिल नहीं सकती हैं. The two things can never mix together. Yes or no? So I said that at 50 to 60 degree in the mid latitude, at the 50 to 60 degree in the mid latitude, the warm westerlies and cold polar easterlies, two contrasting nature of air masses converges. In 50 to 60 degree latitude or in the mid latitude, I said warm westerlies and cold polar easterlies, two contrasting nature of air masses converged, but due to discontinuities in temperature, pressure and humidity, they do not readily intermix. And they stay for a time in a three-type transitional zone. They stay for a time, and that creates a formation of front. So it can be on of what I said that thousands of kilometers or hundreds of kilometers wide, where they start, and the length-wise thousands of kilometers, and then height-wise I said that 6, 7, 8, 9, 10, 11 kilometers like this. Okay? What is the height of warm air mass? 6 to 8 kilometers, and cold air mass around 4 to 5. Okay? What is the height of warm air mass? 6 to 4, and the height of cold air mass 4 to 5. Again I said that. ये line याद रख लेंगे. I said ये सब इसीलिए खोला हुआ है क्योंकि इसी क्लास में मुझे खोलना पड़ता है अपना curves and all, क्योंकि इसमें बहुत सारे पिक्चर यदि एक once the picture is clear, temperate cyclone is also clear. I said that just suppose that this is in a 50 to 60 degree latitude, this is 50, this is 60 degree latitude, and warm westerlies are coming like this. And here cold polar easterlies are deflecting towards right. Cold polar easterlies and warm westerlies are coming like this. And both converges at 50 to 60 degree latitude. And they are not, due to contrasting nature of air masses, they are not ready to what is intermix. And they stop for a while, and that creates a front. Understood? So ये कैसा हो गया? Front कैसा है? It's in a length, it has in a width, it has in a height. So can I say that the front is in a three-dimensional transitional zone? Yes, can I say it's in a three-dimensional transitional zone? Yes? ध्यान से दोबारा सुनेंगे definition में. Front is in a three-dimensional transitional zone where warm westerlies and cold polar easterlies near mean latitude or 50 to 60 degree latitude, they converges, but they do not readily intermix due to discontinuities in temperature, pressure and humidity. And such transitional zone is known as front. Such transitional zone is known as, I said that, front. You can write down this definition. It's in a three-dimensional transitional zone. It's a three-dimensional transitional zone in mid-latitude, three-dimensional transitional zone in mid latitude where two contrasting nature of air masses, warm westerlies from subtropical high pressure belt, and cold polar easterlies from polar high pressure belt converges, but they do not readily intermix due to discontinuities in their temperature, pressure and humidity. Such developed condition considered as front is considered as front, and it is starting with stationary front formation. Clear? Now, this is clear to you? So, where they are meeting, in which region this warm air mass and then cold air mass are meeting? 50 to 60 degree in the mid latitude. अच्छे से ध्यान से समझेंगे ये जो picture है. I said that suppose the region, what is the height of warm air mass first? 6 to 8 kilometer. And what is the height of cold air mass? 4 to 5 kilometer. 6 बोल दो आपकी मर्जी है, कोई फिक्स नहीं होता है. I said 4 to 5 kilometer height. Understood it? ध्यान से देखते जाना. यदि ये पिक्चर क्लियर हो गया तो फिर क्लियर है. What is the meaning of cold air mass on the ground? It is an high pressure. And what is the warm air mass on the ground? It means low pressure. And the wind moves from high pressure to the low pressure. I said that, and if you can be able to see, like I said that you can see, like I said, from the polar high pressure, there is a from the polar high pressure, who is coming? Yes, tell me. Cold polar easterlies. And from the subtropical high pressure, who is coming? Warm westerlies. Yeah. And this is in a cold polar easterlies, and this is in a warm easterlies. And they are meeting in the region of, I said that, 50 to 60 degree latitude of subpolar low pressure. Understood? And when they meet at 50 to 60 degree latitude, and they say that, who are you? आप कौन हो? आप कौन हो? क्योंकि दोनों आपस में completely different है. And you know that कि different can never marry together. तो ये आपस में marriage नहीं कर सकते. Marriage नहीं कर सकते हैं तो इसका मतलब reason behind क्यों है? तो यहाँ पे इंडिया और पाकिस्तान बन गया. This side is Pakistan, warm बन रहा है. India थोड़ा ठंडा बन रहा है. This side is cold. So I said that हमने क्या देखा? So here it is coming and then stopped. Stopped for a while. And stop for a while in the sense it can stop for a day, it can stop for a 2 days, it can stop for a 3 days. And that it is known as, I said that, stationary form. Then first what it forms? Stationary form. Understood? I said that, ये line पूरा याद हो जाए. I said, from the subtropical high pressure belt warm westerlies, and then from the polar high pressure cold polar easterlies. The two contrasting nature of air masses are converging near 50 to 60 degree latitude, converging near 50 to 60 degree latitude with the discontinuities in the temperature discontinuities with the temperature, pressure and humidity. Understood? Therefore, they do not readily intermix, and then they create a front, stationary front, and they start asking who are you, means दोनों अभी जब तक आपस में बात न कर लें who are you and it is not clear, they will take a decision how to move further. They came to know that he said that the cold polar easterly said that I am on a very cold temperature, very low temperature, less humidity, and then I said that high pressure comparatively. Then others said that I am warm westerly said that I am having a high moisture, high humidity, I am having more temperature than you, and I am having what I said that decide what we will do. Then what happened? They are said that we are completely contrasting, we can't do anything, so let's follow the Coriolis force. And then they started, and this is a Great Wall of China kind of, what is an air mass? There is this side is cold and there is an, I said that warm. And then what happened? From this side, then what happened? They said that further more Coriolis forces started. जब ज़्यादा दिन तक नहीं हुआ, so what happened? There is a kind of low pressure, extra air started rising up. Yes or no? And then from here the air started, warm air level started rising up, and then when the warm air started rising up, so comparatively air become less in this region. Air become comparatively less. So the wind speed started becoming more. जब air become less, then this side से इस side में air आना start कर देगा. From this side the air will start coming, and they will find Coriolis force. And then warm westerlies started dilating away from the axis of dilation. And they started more deflecting under the Coriolis force, because there is some kind of a chain of low pressure. And then I said that cold polar easterlies, they started also dilating away from the axis of dilation. Dilation means outward movement. They started moving outward. And when they started moving outward, suddenly they have created less air in the center. When the air started moving away from the axis of dilation, so this is considered as what? I said that this is an axis of dilation, they started moving away. Getting my point? And when they started moving away, then you can be able to see that the warm westerly is coming from here, and cold polar easterly is coming from here, deflecting towards right, and here it is. Now the cold polar easterly is after certain period formation of stationary front, little less pressure created in the center in the transition zone. They started more Coriolis force, then more deflection, making it to dilate away, and warm westerly started also. Instead coming like this, more started dilating away. So the warm westerly started dilating away towards, I said that east. The warm westerly started dilating away towards, I said that when they are coming like this, and they said that, and from here you can be able to see cold polar easterlies. Then they are saying that actually they are never come like a straight. They used to always deflect, and here it is also, I said that deflecting, and after waiting in the stationary for some time, then this warm westerly started deflecting, little less pressure created, uske baad yahan par warm air started rising up, comparatively less pressure created, and then warm westerlies further under the Coriolis force, they started moving along the dilation axis in the east, and then cold polar easterlies started moving in the along the dilation axis, outward flow, and because of this, very less air come into the center of this two contrasting nature of air mass, and that is the creation of low pressure for the temperate cyclone. That is the creation of low pressure along the center of these two air masses. The first they have created an air mass. I said that again say. So this is the यहाँ से अब क्या होगा? There is a stationary front will become active. After that, the stationary front will become. What is the meaning of low pressure? If I say that this is in a low pressure, you know that ये कौन सा है? It is a cold air mass and it is a warm air mass. It has some pressure and it has also some pressure. And this pressure is much lower than this air and this pressure is also much lower than this air. So इसका मतलब कि thereafter what will happen? Everyone will try to come toward this center. And this is an active one. This is an what? Active one. So when the warm air mass, and it is happening in thousands of kilometers, 4, 5, 6,000 kilometers. It is not a small area. It is 4,000, 5,000 long and 4, 6,000. What is it now? Wide. It's a very large area. This phenomena is taking place. And then warm easterly, which is going toward this, and then cold polar easterlies, which is going toward this, and because of that, there is a creation of what? Low pressure. And then now cold says, ये क्या हो गया? It is an attraction point of. It is a point of attraction for the cold air to come towards this. And when the warm easterlies were going toward this again, he said that it is an attraction point for me. And then now warm easterlies wants to come toward this. And then cold polar easterlies wants to come toward this. Both wants to come. अब ऐसा तो नहीं है कि हम आप साइकिल है, साइकिल को घुमा दिया, चलो यहाँ घुस जाओ. It's in a truck को देखते हो, when they are turning, they take a long turn. Yes or no? To turn. Similarly, when they have to come over here, they have to take in a turn. And when they started taking in a turn, he is moving in a cold polar easterly is moving in the west. And then I said that warm westerly is moving in the east toward the Siberia that you have seen. They are moving like this. I said then they started moving toward the low pressure center, and then during the movement they started invading into the region of warm air mass. Understood? He wants to come to the low pressure. Now I am coming on to the point. For the cold polar easterlies, the cold air mass who is there, इसके लिए दो point, they are the two factors which is making them to attract. And then the first factor which is attracting it is in a first low pressure. Another it is in itself. I said that कौन है ये? Warm air mass. Yes or no? Ground पे who is there? Warm air mass, that is a low pressure. This is in a warm sector and this is in a low pressure. The warm sector on the ground, it is in a low pressure. And यहाँ पे on the ground, there is in a cold air. So high pressure and low pressure, and another it is in a low pressure. The two factors started attracting it. So the cold polar easterlies, they started, suppose it is attracting with the 10 unit of force. And it is attracting with the 5 unit of force. It means now the cold polar easterlies, what is the height of cold polar easterlies? 4 to 5 kilometers. And they invaded into the region of, to come towards the low pressure, they invaded into the region of warm sector or warm air mass, and then warm air mass. Get up? With the unit of 15 unit. Yes? The two factors. Which are the two factors? One side, आप लोग का जगह कौन सा है? आप लोग किस तरफ से? Warm air mass है. तो ground पे आपका कैसा pressure है? Less. And this is in a cold polar easterlies. Ground, what is the pressure? High. And there is an also, what is in a low. So the two factors making them to attract, one the low pressure developed at the center, and another I said that south side, in the southern side, what is the low pressure on the ground. Under such two, the cold air mass started invading into the region of warm air mass. Who is invading? Cold or warm? Who is invading? And it is a cold front formation. And where is the cold front formation is taking place? It is happening in the southwest region of front. Where it is taking place? Southwest region of front. Again I said that cold polar easterlies which is moving westward, and then warm westerly which is moving eastward along the dilation axis. Due to this there is a low pressure created, and cold polar easterlies started invading into the under two factors toward the center, and they invaded into the region of warm air mass in the south. And warm air mass raised up 4 to 5 to high, raised up and become a cumulonimbus cloud. Which cloud it become? Which cloud become? और वैसे भी आपको पता है कि वार्म एयर मास का क्या कैरेक्टर होता है. व्हाट इज द कैरेक्टर ऑफ द वार्म एयर मास? लाइटर. यस और नॉट? एंड देन व्हेन इट इन्वेडेड, चढ़ने के लिए तो यहां पे भी वार्म एयर ही चढ़ेगा, बट यहां पर हु इज मोर फोर्सफुल? Who is more forceful? Cold air mass. And therefore he invaded, and then warm air mass started rising, and cold front, and at the cold front, which rainfall started taking place? Cumulonimbus cloud. Which rainfall started taking place? Which cloud? So cold air mass invaded into the region of it, and then there is a 4 to 5 kilometer height, and then warm air mass started rising up. It became a cumulonimbus cloud, and that is making it what? Tell me fast. Yes, heavy. Yes, downpours. Yes or not? Heavy rainfall started taking place. Getting my point? And then now see here. It is in a unit. What is the force? 15 unit. Now again I said that this is in a warm air mass. The warm easterly is moving toward this, and there is a cold air mass का ये पीछे का tail है. This is the tail of the cold air mass. And now the warm air mass wants to come to this center, and there is a suppose अब ये warm air mass का कुछ pressure है और cold air mass का है, तो suppose it is attracting it with the 8 unit. How much? How much? क्योंकि ये cold था और ये low pressure था, तो cold का pressure थोड़ा सा high होगा, and it has a pressure of, I said that, suppose any difference, though it is a 10 unit, लेकिन यहां पर जो मूव कर रहा है वार्म एयर मास, थोड़ा सा इसकी प्रेशर कम होगी, तो इट इज एन अट्रैक्टिंग विद द 8 यूनिट. सपोज इट स्टार्टेड कमिंग विद द 8 यूनिट. यस, लेकिन ग्राउंड पे कौन है? हु इज ऑन द ग्राउंड? कोल्ड एयर. एंड हु इज द ग्राउंड ऑन दिस साइड? वार्म एयर. तो नीचे में कौन मूव करेगा? हु विल मूव? कोल्ड एयर. हु विल मूव इन द ग्राउंड? एंड व्हाट इज द इंटेंसिटी? 5 यूनिट. व्हाट इज द इंटेंसिटी? Yes, tell me. किस इंटेंसिटी से? यहां पे बताया था ना कि द कोल्ड एयर मास, इट इज ऑन द ग्राउंड, कोल्ड एयर मास, एंड ऑन द ग्राउंड हु इज देयर? Warm air mass on the ground. So pressure is low and is high. So on the ground it is attracting with the 5 unit, and this cold air mass is attracting toward this with the 10 unit. So it is making with the total force 15 unit. Yes or no? समझ में आ गया? And then another I said, suppose ये भी warm air mass making in with the force of what? 10 यूनिट सपोज करो. सेंटर की तरफ कितने फोर्स से आ रहा है? 10 यूनिट. बट ऑन द ग्राउंड हु इज गोइंग? कोल्ड एयर मास टुवर्ड द वार्म सेक्टर. यस और नो? विद द 5 यूनिट ऑफ फोर्स. सो फाइनली इट इज रिड्यूसिंग द, फाइनली इट इज इन 10 यूनिट और इट इज इन 5 यूनिट. इसका मतलब वार्म फ्रंट की स्पीड रिड्यूस हो गई. यू आर मूविंग द 10 यूनिट, बट इन द ग्राउंड हु इज रिड्यूसिंग योर स्पीड? Cold air mass which is moving down the ground. So finally your speed is what? 5 unit. Understood? Again I said that. ये picture clear हो गया तो temperate cyclone is also the same thing. I said, listen me carefully. So from the subtropical high pressure belt to the what is mid latitude region, warm westerlies is moving. And from the polar high pressure, what is cold polar easterlies are moving, and they converges near what is in a mid latitude or 50 to 60 degree latitude, and both the air masses which are converging, they do not mix because they have a discontinuity in their temperature, pressure and humidity. They do not readily intermix, and they create a formation of front, transitional zone, and that is known as stationary front. After that, some of the air masses started moving upward and created some low pressure. So on the eastern side, cold polar easterlies started what? Deflecting more towards dilation of axis. And then I said that cold polar easterlies toward the dilation of axis, and warm westerlies toward the eastern side. I said that dilation of axis. One is in a westward, and therefore creation of more low pressure at the center. And after this stationary front, then on the eastern side, cold polar easterlies they started. यहाँ पे 2 factors नहीं बोलना है, यहाँ पे ये मत लिखिएगा 2 factors. मैं समझा रहा हूँ कि what are the 2 factors. I said that the cold polar easterlies with the more force invaded into the region of warm sector or warm air mass, and warm air mass under such high force they started moving upward and form a cumulonimbus cloud with the what is torrential and heavy rainfall. And on the other side, when the warm air mass, I said that wants to come to the center from the eastern side, and then in that section they started invading into the region of cold air mass. Warm air mass started invading into the region of, but with the very reduced force, but with very, and then warm air is lighter than cold air, then with very reduced force they started riding over cold air mass. Yes, understood? Cold air mass. और किसी के ऊपर फोर्सफुल चढ़ाया जाए, कौन सा क्लाउड बनता है? If you are making them to move forcefully, stratus cloud. Yes. If I said that when you started moving over something, I said that, and then cold air mass, लेकिन ground पे कौन move कर रहा है? Who is moving towards the south? Cold air mass, and upper side warm air mass is rising up in the ground, nimbostratus, above altostratus, above I said cirrostratus. Which are the cloud it will form? Which are the cloud it will form? Nimbostratus, altostratus, cirrostratus. ऊपर में जैसे जैसे जाएंगे the cloud it will start increasing. And you know that stratus cloud, which cloud become heavy rainfall? Having vertical development or horizontal development? So stratus cloud will give a drizzle or rainfall. Drizzle, because a highly developed vertical development will cause a rainfall, and horizontal development with less water, they will cause drizzle. Then what will happen? Nimbostratus, और उससे थोड़ा ऊपर height है. Yes, tell me. Altostratus, याद है ना? 2 to 6 kilometer, and above 6 kilometer it is what? So what are the cloud it will start forming? Nimbostratus, altostratus, cirrostratus, and above it is which cloud? Cirrus. And cirrus is a part of it. Understood it? Again, आपने यदि उसमें भी देखा होगा, जैसे ही ऊपर में आ जाएंगे, if I'll go above, I have shown you cirrostratus. ऊपर में एयर गया, तो इसका मतलब क्या बन जाएगा? High pressure. And high pressure started diverging, तो ऊपर में तो cirrus बनेगा. Yes or no? Any air which is going up, कोई भी लाइफ में ऊपर चला जाए और स्प्रेड होने लग जाएगा, क्योंकि more air pressure created. याद है ना? There is a 500, and the air has gone up, it become more air. And they started diverging, and as it started diverging, spreading means cirrostratus. It will come into play. So anywhere you will be able to see in the upper atmosphere, which cloud it will be there? Again I said that. Who is fast? Cold front is fast or warm front is fast? Yes, tell me. Cold front is fast. And if I am talking about, so here who is moving? Its speed is suppose 15 unit, cold front, and the ground is covered by whom? Ground is covered by whom? And then cold air mass and then warm air mass is rising up, cold air mass, warm air mass rising up, cold air mass move करते जा रहा है, and the warm air mass is rising up. So it is in a cold front, speed is what? 15 unit. And here warm air mass, it is rising up above to come towards this center. But on the ground, who is covering with the very slowly? Yes or not? The speed is comparatively less. And then warm front is moving slowly. But who is covering on the ground? Cold air mass. Slowly and slowly, ध्यान से देखें. Cold air mass. Cold air mass of cold front, cold air mass of warm front, both are coming onto the ground. Here it is in which cloud? Cumulonimbus cloud. Here it is in what? Nimbostratus, altostratus, cirrostratus. Here it is in is happening. And then slowly and slowly and slowly and slowly, what will happen? They will cover the ground. The ground was covered by whom? Cold air mass. And what does it mean? Cover means occlusion. Occlusion in the what is the meaning is what? Covering. The ground is covered by cold and upper portion was covered by whom? Warm. Understood it? And then that is I said that warm air sector is completely covered. Warm air sector is completely covered by cold air sector. And you can see, like again I said that nimbostratus, warm front. What is happening? First there will be nimbostratus cloud. There will be altostratus, cirrostratus and cirrus. And cirrus cloud is always, and cirrostratus cloud, all these are always indication of cyclone to come. Indication of cyclone to come. Getting my point? समझ में आ गया? Cold front, yes, cold front, warm front. Again, this is the last time I am making to understand it, and this triangle structure is representing what? Cold front, and circle structure is representing warm. It means if you see that over the period, आपको क्या दिखेगा? I said that this region will be now cold front has started moving, and यहाँ पे क्या बन गया? Just tell me, cold front. And in this section, there is a formation of, yes, tell me, warm front, because from the ground, who is covering? Cold air mass. And who is rising here is nimbostratus. Warm air mass is nimbostratus, altostratus and cirrostratus. And here it is what? Cumulonimbus cloud. Cold front and warm front. Understood? Is it okay? Yes? समझ में आ गया आपका? Occlusion front is the final front. First, which is the front? Stationary front. तो कैसे डिफाइन करेंगे stationary front को? और stationary front का definition भी आपको ऐसा ही होगा. And the same thing has been said by I said that V. Jerkanis and J. Jerkanis, the father and the son together, they have given this temperate cyclone formation stage. They have said itself, like I said that I said that warm westerlies and cold polar easterlies. Which one I said that? Warm westerlies and cold polar easterlies are converging near 50 to 60 degree latitude or in the mid latitude, but due to contrasting nature of air masses, they do not readily intermix and the creation of formation of front. Yes, sir? Discontinuous temperature and pressure, therefore they are not able to meet. And this is known as a stationary front. After certain period of interval, then the cold polar easterlies started dilating towards east. Cold polar easterlies started what? Dilating towards east, and warm easterlies started, west, and then warm easterlies started dilating towards east. Due to dilation along the dilation axis in the center, less pressure created, and that is a formation of low pressure of the temperate cyclone. ऊपर चढ़ रहा है, हाँ, क्योंकि वार्म एयर दोनों के केस में लाइटर ही है, और लाइटर एयर मास चाहे कोल्ड एयर मास व्हेन दे विल कम, चाहे वार्म एयर मास इज अटैकिंग टुवर्ड्स द कोल्ड एयर मास, व्हेन दे विल अटैक दे विल हैव टू राइज. क्या? कौन सा फ्रंट? Yes, यही तो मैं नीचे से दिखा रहा हूँ. There it is a slowly and slowly movement because the speed is reduced by riding over the air masses. I said that if it is moving with the 10 unit and it is moving with the 10 unit, but the speed is reduced by whom? Warm air mass is riding coming towards the center. Here its speed is 15 unit. Here its speed is what? 5 unit. यहाँ पे दोनों एक दूसरे को सपोर्ट कर रहे हैं, but here there are two forces are what? Opposing. Clear? So अभी दोबारा समझा रहे हैं इसीलिए, क्योंकि ये पिक्चर जितना क्लियर होगा that much it will be better for you. I said that so they meet at the center and there is an they started moving away from the dilation axis, and then cold polar easterlies toward the west and then warm westerlies toward the east. And due to this, a low pressure has been created at the center, and due to the low pressure creation at the center, the cold polar easterlies, they started coming toward this center within a very high vigorous force, and they invaded into the region of warm westerlies and then warm air mass in the south, and that is in a formation of what I said that what is in a formation of cold front. And on the warm westerlies, they started also wants to come to the creation of this low pressure center, and they form they invaded, but the intensity has been comparatively much lower than the cold front, and then invaded into the region of I said that low pressure center at the center toward the cold air mass, and during the invasion they started riding over the cold air mass. They started riding over the इसकी फोर्स को किसने रिड्यूस कर दिया? नहीं तो यदि फोर्स इसका ज्यादा होता तो they have to ride like I said that ये ऐसे उठता. If the force is more, then it has to go up like this, but if the force is less, then it will never be go like this. So therefore they started rising slowly and forming nimbostratus cloud, cirrostratus cloud, and nimbostratus, altostratus and cirrostratus cloud. And वही तो मैं समझा रहा हूँ, यदि वो एक्सिस ऑफ डायलेशन नहीं, पहला तो लो प्रेशर तो ऑलरेडी है, हेडली सेल के अनुसार से फर्स्ट लो प्रेशर दे ऑलरेडी है, हेडली सेल व्हाट दे हैव सेड दैट, ये सारी चीजें इसीलिए पहले किया गया है कि इफ इट इज एन हाई प्रेशर मींस सराउंडिंग रीजन इज low pressure and it is a descending at subtropical high pressure, this region is low pressure. What is the meaning of high pressure? Surrounding region is low pressure. याद है ना, आपको स्ट्रक्चर इस फर्स्ट क्लास में बिना समझाए हुए 3 हेडली सेल्स आपको दोनों स्ट्रक्चर बनाया था, क्योंकि मैंने बोला था इफ देयर इज अ हाई प्रेशर सराउंडिंग रीजन मस्ट बी हाई प्रेशर, कहने का मतलब व्हाट इज द मीनिंग ऑफ इट, सराउंडिंग रीजन इज लो प्रेशर, देयरफॉर इसको हम लोग हाई प्रेशर बोल रहे हैं ना, इफ द विंड इज मोर देयरफॉर आई एम सेइंग हाई प्रेशर, the surrounding region is must be. So therefore there is a warm westerlies is moving and there is a cold polar easterlies. Warm westerlies, cold polar easterlies, they are meeting and but they do not readily intermix. अब यहाँ पर they started finding out कि क्या हो रहा है, वहां पे तो मैंने आपको डायरेक्टली बोल दिया कि ऐसे उड़ गया और घूम रहा है, लेकिन यहाँ पर फ्रंट समझाऊंगा तब पता चलेगा how do the warm air masses rising up. In both the cases warm air mass is rising up. So I said that, और ये लो प्रेशर साइक्लोन का लो प्रेशर है, और ऐसे जो उठ रहा है उसके वजह से सबपोलर लो प्रेशर, अंडरस्टूड इट, एंड व्हेन दे स्टार्टेड क्रिएटिंग, सो लिसन मी केयरफुली, and then when the cold air mass started invading into the region of what is in a warm air mass, and the warm air mass started what is in a highly moving up and it is forming in a cumulonimbus cloud, and in the ground the fast coverage of cold air mass, and then fast coverage, fast movement means it will uplift more and more warm air mass and cumulonimbus cloud, and here it is completely with the slow speed, therefore if the slow speed is not able to make the thrust to the warm air mass, slow speed is not able to make a thrust to the warm air mass, therefore the warm air mass is slowly and slowly towards the center invading and then coming with the speed very slowly, and then it is making nimbostratus, altostratus and cirrostratus and cirrus cloud and causing drizzle for long days. And then ground is covered by cold front, and then slowly and slowly cold air mass, and then slowly and slowly warm front, cold air mass, both the ground has been covered. And when both the ground has been covered, it is known as, when the cold front meet with when the cold air mass of cold front and then cold air mass of the warm front get together, it is known as occlusion. And occlusion means covering. And the ground has been covered by cold air mass of both and warm air mass raised up. And we can be able to see, like I said, that stationary front, you can be able to see. This is, I said that, cold Polar Easterlies, and here it is, I said, warm Westerlies, and this is stationary front, and why they have formed, due to what I said, that discontinuities in temperature, pressure and humidity. Due to discontinuities in temperature, pressure and humidity, we are able to get, what I said, that two contrasting nature of air mass stopped along mid latitude and this transition zone is known as stationary front. Stopped मतलब ही होता है कि nothing is happening, no atmospheric phenomena is happening. No atmospheric phenomena is happening. And neither cloud formation, nothing. But after that, what happened? warm westerlies slowly rising over cold polar easterlies. Slowly rising over cold polar easterlies. Rising over cold polar easterlies. Due to discontinuous temperature, pressure and humidity, two contrasting nature of air masses stopped along the mid latitude, and this transitional zone is as a stationary front, and no atmospheric phenomena is happening in this zone, and warm easterly is slowly rising over the cold polar easterlies. So it is in a stationary front. Second stage it is coming off. Second point that we will see, like and this is an axis of dilation, and then warm and then comparatively low pressure created. यहाँ पे थोड़ा सा हर जगह low pressure created, and they started what is now, because they आप ये जान कर रखिए contrasting nature of your masses can never ever meet, उनको अपना रास्ता लेना ही पड़ेगा. And after that they started developing in some amount of air. थोड़ी देर के लिए क्यों रुके? Why do they have stopped for a while? So that the sum of the air has gone up and then created enough pressure to what is move, and creating more pressure getting, and then the warm westerlies started dilating towards east, and cold polar easterlies started dilating towards west. And due to dilation, the good amount of what? Air reduced from the center, and that is known as, I said, that low pressure. After stationary front formation, what happened? Cold polar easterlies started dilating. Dilating is outward movement. Started dilating towards west, and warm westerlies started dilating towards east along the axis of dilation. Along the axis of dilation. Therefore, what happened? Therefore, at the center of axis of dilation, at the center of axis of dilation, air pressure reduced and created low pressure of cyclone, low pressure of temperate cyclone. This is the second stage which has been taken place after the formation of what is the stationary front. After the stationary front formation, cold polar easterlies started dilating towards west, and the warm westerlies started dilating towards east along the axis of dilation, and therefore the center of axis of dilation, air pressure reduced due to the reduced air and created low pressure of the temperate cyclone. Next one, because of this, after this low pressure center on the so the cold air mass, and this is, you know, that the cold air mass invading into the region of warm air mass with a very high force, and they have created what? Next one is the creation of front, and here it is also warm air mass rising up, but the ground is covered by cold air mass, and there is a formation of, I said, warm front. And if the this way we can be able to see that if it is in a low pressure, it means surrounding region has high pressure. Surrounding region has high pressure. और दोनों का ये जो आइसोबार बन रहा है, ये जो आइसोबार है लो प्रेशर है, the line joining the same. इधर के आइसोबार, suppose it is an I said that 990 MB, 995 MB. तो इसका 990 is this, इसका 990 थोड़ा सा वार्म एयर का अलग रहेगा. So there is an isobar has been created. Understood? Low pressure, and this is a cold air sector. This is, I said, cold air mass, and this is a warm air mass. And I said due to creation of low pressure, isobar developed around the center in cold sector as well as warm sector. Isobar has been created. If it is in a low pressure, it must be surrounded by high pressure. If it is in a low pressure, it must be surrounded by, yes, what is the meaning of low pressure? Surrounding region is high pressure. Thereafter, now the next point is on the west side. West side mein kya hua? On the west side. On the west side, the cold air mass on the west side of this front, cold air mass, that is a cold polar easterlies, you can say also cold air mass invading heavily towards the warm air mass. And creation of cold front, and creation of what I said that cold front. Okay. On the west side, creation of cold front, and cold front formation you can be able to see, like I said, that this is cold air mass is invading. Yes, then a cold air mass which is invading, and here the warm air mass is there. After that, this figure you can draw, and then warm air mass has risen up like cumulonimbus cloud with a heavy rainfall. And if you can see what will be the slope of it, cold air mass. So what is happening in the cold front? Cold front formation, what is the thing is there? There is a heavy and torrential rainfall. Okay, heavy and torrential rainfall by cumulonimbus cloud, C, by cumulonimbus cloud. Clear? इसका स्लोप कैसा होगा? What is the height of cold air mass? Tell me. 4 to 5 kilometer. What is? Suppose I am taking this in a 5 kilometer, and suppose I said that its length is, ये total area 500 है, तो 500, तो what is the slope? 1 upon tan theta equals to क्या होता है? Perpendicular upon base या y upon x. So 5 upon 500 means 1 upon 100. What is the angle? 1 upon 100. Or if it is, I said that 2000 kilometer area, तो ये 2000 होगा, तो 5 upon 2000 divided, I'll say that 1 upon 400. So its slope is what I said that it's a slope can be, I said that varies, लेकिन I said that ये यहाँ पर आप क्या देख रहे हो, कोल्ड एयर मास ने क्या किया है, अपने आप ही इतना फोर्स दिया है कि वार्म एयर मास उतना फटाफट चढ़ने लग रहा है, इट स्टार्टेड राइजिंग अप. तो इसका जो है स्लोप जो है लेस देन 1 अपॉन 100. व्हाट इज द स्लोप ऑफ दिस? लेस देन. तो स्लोप ऑफ इट, इसका जो स्लोप होगा कोल्ड फ्रंट का, इट इज एन, आई सेड दैट, आई सेड 1 लेस देन या 1 upon 40 to 1 upon 100. Because it is making the things and faster है, it is covering the faster, it does not allow the air to be in the larger area. Yes or not? So its a slope will be, I said that, faster, less than 1 upon 100, or better to say 1 upon 42, it's a slope. Okay? So this is about the cold front, and this rainfall used to take place. इसकी स्पीड बहुत ज्यादा है, तो सपोज इन दिस रीजन यहाँ पे इसने what he causing what is a torrential rainfall, and after that it will move. तो इस रीजन पे कितने देर के लिए रहेगा? 2-3 hours maximum. It will keep on moving. So the particular region will get a torrential rainfall for how many times? What is the duration? Maximum what is it? 1 to 3 hours. So torrential rainfall region will have what? 1 to 3 hours. जैसे कभी कभी आप मैच देखते हैं in London and all, if the torrential rainfall takes place 1 or 2-3 hours, and then उसके बाद match started and then no rainfall, that you have seen, it is in a cold front is passing from the London. Which front is passing? और उसके बाद क्रिकेट मैच फिर दोबारा चलता रहेगा, क्योंकि कोल्ड फ्रंट तुरंत निकल जाता है. इट इज नॉट कॉजिंग व्हाट फॉर मेनी डेज. वार्म फ्रंट कॉजेज फॉर 6-7 डेज. इसका मतलब पूरा टेस्ट मैच बर्बाद. So I said that, understood, this is cold front, its speed is fast, and then I said that coverage of warm sector in the south by cold front is very fast and reducing warm sector. And then what is it? Reducing and compressing. वो क्या करते जा रहा है? Warm sector started what? Compressing, reducing. This is about, I said that, this side, on the western side of a temperate cyclone, on the western side of a temperate cyclone, there will be always, और यहाँ पर यदि आप picture बनाएंगे, then you can make in a picture like I said that, it will deflect towards, आपको ही पता है, wind is to deflect towards high pressure to low pressure. यहाँ पे आप दिखाएंगे this way, तो यहाँ पे red color से मैं दिखा दूँ, it is deflecting towards right. Cyclone is what? Deflecting towards right. So low pressure to high pressure. So it is which kind of deflection I said? Anti-clockwise. So cyclone formation is, यहाँ पे ध्यान रखेंगे, it is in which kind? Anti-clockwise. Cyclone formation is in which form? Anti-clockwise. Next one we are going towards eastern side. On the east side, On the east side, we have seen that the warm air mass started invading into the cold air mass with slow force. With slow force, because it has been obstructed by the below. So I said that on the east side, I said that first point, warm air mass starting invading into the cold air mass region with comparative slow force. Comparative slow force. Okay. Therefore, speed of warm front is something better to with slow force, and such invasion, such transition zone of invasion is known as warm front. The speed of warm front is very slow. Very slow. So invade here and its speed is very slow, that we have discussed here. And there will be, I said that which kind of structure it will form. This is a cold air mass. And cold air mass, and here it is, I said, warm air mass. And then warm air mass rising up. First he made nimbostratus cloud. As it will move altostratus, then there is a higher height, 6 km more, cirrostratus, and then other cirrus cloud. And they are causing rainfall. And their slope is very less because it is happening in a, क्योंकि कोई भी area, what is in a warm air mass is forcefully rising. Therefore, I said that it started what is spreading in a very large area, and the large area means I can say that if it is in a 5 km, the large area can be what is in it till 2000 km also. So its slope is from the 1 upon 100 to 1 upon 400. So I said that next point, I said यहाँ पे क्या होगा? Rainfall by especially rainfall in the form of drizzle for 4 to 7 days in the form of, I said, nimbostratus cloud and cirrostratus cloud, altostratus, cirrostratus and cirrus cloud. Okay. Next, it is covering the ground of warm sector. Warm front is covering the ground of warm sector in the south slowly. In the south, this direction is what I said that? South. Okay. Which direction I said that? South. So जब कभी लंदन में कहीं भी मैच हो रहा है and then drizzle is happening, it means which front is there? Warm front. Understood? And it will keep on happening, and then for longer period of days. So this is in about what I said that warm front. And next one, I said that in the next few days, what happened after that? In the next few days, in the south, moving cold front and then moving warm front started what? Reducing the warm sector and shrinking the warm sector, and then cold air mass of cold front and cold air mass of warm front has covered the ground. The point where it covered, it is considered as an occlusion. Understood? So when it has covered, it is known as occlusion. So I said that this is then a front formation, and then after that, this stage, what will happen? आप देखेंगे कि ये और दिस स्टेज इज नोन है, जो आफ्टर दैट इट इज नोन एज, ये जो फर्स्ट स्टेज देखा इसको बोलते हैं फ्रंटल वेव स्टेज. इट इज नोन एज फ्रंटल वेव स्टेज. दिस इज नोन एज व्हाट? मेरे साथ कुछ बोलेंगे. स्टेशनरी फ्रंट, फ्रंटल वेव, ओपन वेव. What are the three I said? Frontal wave, open wave. Thereafter I said that initial occlusion, advanced occlusion and death of cyclone. I said that. Yes, tell me. हमने क्या बोला? First three is stationary front, frontal wave, open wave. And the last three is, I said that initial occlusion, advanced occlusion and death of cyclone. Understood it? I said that again. हमने क्या क्या बोला? तो पहला अभी जो स्टेज आपने देखा था उसके ऊपर आप लिख सकते हैं फ्रंटल वेव स्टेज. दैट इज व्हाट? स्टेशनरी फ्रंट के बाद क्या बनता है? यस टेल मी, व्हाट इज फॉर्मिंग? फ्रंटल वेव. मिस आपको पूरे इन होल यूरोप एंड ऑल दिस रीजन में आपको कैसा फ्रंट दिखेगा? दिस काइंड ऑफ, I said that this kind of, so this is in a cold front and it is in a warm front. क्योंकि पहले कैसे थे? They are in the form of stationary front. They are in the form of, but they started forming frontal wave. So it is in a wave has been created. Frontal wave stage. Second stage is which stage? Frontal wave. And then cold front पे कैसा rainfall होगा? Yes, tell me, heavy or drizzle? Heavy rainfall. And it keeps on happening to see, like I said that. And then ये cold front पहले यहाँ पे था. The cold front further moved like this, and then warm front has further moved, and this way I said and this is, I said that cold front, and this is, I said that warm front. This way you can be able to see, I said warm sector is further shrinking and cold sector is opening. Cold sector is what? Which sector is shrinking and which sector is opening? Warm sector is what? Shrinking, and cold sector is what? Spreading, is getting larger and larger. So after the frontal wave stage, which stage will come? Open wave. Yes? Slowly what happens? Slowly, due to movement of cold front and warm front, started reducing and shrinking. Warm sector in the south and cold sector or opening wider. It is known as open wave stage. What it is known as? Open wave stage. Okay. So that started, which one I said that? Slowly, due to movement of cold front and warm front. Yes, movement of cold front, warm front. What happened? warm sector, यहाँ पे लिखेंगे started reducing and shrinking warm sector, started reducing and shrinking warm sector in the south, and cold sector opening wider, and it is known as open wave states. The cold area started more opening, and if the cold area open होगा तो the cyclone cannot form. Yes or not? There is a what? Opening states, open wave states. Understood? What is the first stage? Stationary front. Second one I said that frontal wave, front will form, and front started moving faster. Then what happened? Cold sector has been warm sector reduced and cold sector opened. It is known as an open wave states. Shall I remove this? And then कहाँ पे सबसे ज़्यादा rainfall हो रहा है? Just tell me which region is getting more rainfall? Cold front. और ये rainfall continued है. This is ये पहले यहाँ पे था. It keeps on moving. And here it is in a what? Nimbostratus, altostratus, cirrostratus. This kind of rainfall keeps on happening. Shall I remove? After the opening wave stage, what happened? After opening wave stage, occlusion take place. And you can be able to see, like I said that. You can be able to see this is an I said. ये structure किसके लिए determine करता है? Warm front. And this one is, I said that, cold front. So the cold front it is coming, and then warm front is coming, and it is in a cold air mass of cold front, it is in a cold air mass of warm front. And when they get together, it is known as what? Yes? Occlusion front or occluded front. Listen me carefully. आपको कौन सा? It is in a cold front, cold air mass. And who is there? Warm front, cold air mass. दोनों में से कौन cold होगा? Generally आप उसी को बोलोगे cold front का cold air mass क्या होगा? ज़्यादा होगा. That is known as a cold occlusion. That is known as a. So ध्यान से देखेंगे. So the first initial occlusion will take place. They are going to together. यहाँ पे कौन सा rainfall? Nimbostratus, altostratus, cirrostratus, drizzle. And when they get together, heavy rainfall in its occlusion. Yes, cumulonimbus and all, heavy rainfall. And who is colder? Cold air mass of cold front. And that is known as a cold occluded front. It is known as which? I have said the two types of occluded front. Cold occlusion and warm occlusion. Cold occlusion and warm. And if it is in a warm or it is cold, then it is known as warm occlusion front. तो देखेंगे. Let us see. ये दिख गया cold occlusion front में who will be colder? In the cold occlusion front में who will be colder? Yes. Cold air mass of what? Cold front is warmer than the. तो difference क्या होगा? एक one it is I said that 6 degrees Celsius, and other will be what is it? 2 degrees Celsius. तो 2 degrees Celsius it is in a colder. दोनों cold है, but who is colder? Cold air mass of cold front. But another you can be able to see. यहाँ पर आप क्या देख रहे हैं? Cold air mass is cold, and यहाँ पे cold air mass of cold front, and here it is in a cold air mass of warm front. So cool air का मतलब temperature is little more than this. So it is in a cold front. But आप देखोगे. So if I say that occlusion take place, and occlusion में two types of occlusion: cold occlusion and then warm occlusion. Cold occlusion means I said that first, if I say this is cold front, and here we have what? Oh. This is this is cool air, and it is I said that cold air. So it is a colder, and then the warm front and cold. So here it is coming warm front, and here it is cold front. Both are coming towards each other. And after that, if it is in a cold air mass of cold front is more colder, then it will be heavy. और ये नीचे जाएगा और ये ऊपर जाएगा. Yes or not? Because it is in a comparatively warmer. So this cold air of warm front will move up. And after that, it is an initial occlusion, and then the next figure will be like I said that. अब ये ऊपर आ गया. This started what? Slowly rising up. And this is in a cool air, and this is I said that cold air. It is in a cold front and it is in a warm front. Both are moving towards each other. And this section is known as first position, and then I said this is in a what? Cold occlusion. That is cold occlusion. And in the case of warm occlusion, I'll make the figure over here. That is a initial occlusion. This is cold air mass, and this is cool air, and this is I said that cold air. And here it is I said that warm front, here it is I said that cold front. Both are moving, but this is cold, and here it is cold front, cold air mass is comparatively warmer. So what will happen when after the occlusion will take place? This cool air, and this is cold air. Then this is comparatively warmer, then it started riding over the warm front. When the cold front started riding over the warm front, and this is and it is known as warm occlusion. So simple सा है इसमें. So the equation can be written like I said that cold air mass of cold front is warmer than cold air mass of warm front. Simple. And that is known as a warm occlusion. And here it is. Cold air mass of cold front is colder than cold air mass of cold front is colder than cold air mass of warm front. It can be at any time, and both will give the rainfall. Both will, but there is a दोनों चलते रहते हैं. कभी cold occlusion होते रहता है. Occlusion will take place, but the two types of occlusion can take place: warm occlusion और cold occlusion. और depends upon कि वो किस region से cross कर रहा है. यदि warm front Siberian region से cross कर रहा है तो वहां का coldness ले लेगा वो ज्यादा, तो automatically वो कैसा बन जाएगा? More cold. In both the cases, you will be able to see. आपने पहले क्या देखा था? First we have seen cold occlusion. Now here you can see what? Warm front air is what is in a colder, and cold front air is comparatively warmer. Then the cold front started rising over here. It is in a warm front, warm occlusion front, and here it is what? Cold occlusion. The cold air mass of cold front is colder than the cold air mass of warm front. Okay? So this is a very simple difference. It is clear? Cold occlusion and warm occlusion. And यहाँ पर आप देख सकते हैं दोबारा in this kind of picture it is going to what? Occlusion is going on. And then when this is in a kind of what? Initial occlusion. The cold front and warm front both are going to meet. और इस प्रकार का cyclone बनते रहता है. Tempered cyclone ये बनते रहता है. Is it okay? So, which are the two types of occlusion has been taken place? Yes, tell me. Cold occlusion and warm occlusion. And both will give what? Torrential rainfall. These two occlusion will keep on giving. Occlusion is giving torrential rainfall continuously. Now tell me, according to you, where I am talking about two regions, 1, 2, 3, which region will get occlude first? In this one, 1, 2, 3, which region will occlude first? First region. Thereafter, because first when the two, here it is cold air mass, cold front, and here it is a warm front. The first, where the occlusion will take place? Ground will be covered by cold air mass first initially here. There, slowly and slowly and slowly it will be covered complete. Yes or not? So the first occlusion, which are the stages? Which stage is this? Open wave stage. And after the open wave stage, what happened? Occlusion. And that occlusion is known as initial occlusion. Yes. So in this region, first occlusion will take place. And we can be able to see, like I said, that. And first occlusion has been taken place. And this is the answer. I said, and this is known as initial occlusion. This is now initial occlusion has been, so it is in a triangle. तो पहले cold air के ऊपर कौन चढ़ गया? Warm air. Cold air के ऊपर कौन चढ़ गया? Warm air. Yes or no? Occlusion is represented through this cold air, and above cold air who is there? Warm air. Above cold air who is there? Warm air. So the occlusion is represented through this kind of, what I said, that indicative diagram. Okay, so this is the initial occlusion. लेकिन ध्यान से सोचेंगे, if you see that who is there, low pressure. ध्यान से देखिएगा, it is covering, और मैं यहाँ दिखा नहीं सकता, I can't close my hand like this. When it has occluded, तो यहाँ का that is a low pressure that has been covered. In this region, the cold air mass of cold front and cold air mass of warm front get together, but low pressure has moved up. Low pressure ऊपर आ गया. यहाँ पे अब rainfall finished, but the low pressure has calm down. So low pressure you can be able to see like that. यहाँ पे low pressure create हुआ, and then and what happened? Dilation, and then you can be able to see, like I said, that initial occlusion has been taken place, but this low pressure जो यहाँ दिखा रहा है, it is not on the ground. Ground is what covered by cold, but ever low pressure has moved upward. और इस low pressure की वजह से again the air will keep on coming and circulating. जो कि आप यहाँ देख रहे हैं, this way, it is in a warm air, this is in a warm front, here it is in a cold front, and initial occlusion has been taken place, but even then in the upper atmosphere above the, what is an initial occlusion, there is a what? Low pressure still exists. So I said that after opening of this stage, initial occlusion took place. So, क्या लिखेंगे यहाँ पे लिखेंगे? Write down. Figure is this side is, I said, that warm front, and this side I said that cold front, and this initial occlusion has been covered. यहाँ पर हो चुका है, and you can make a figure, like I said, that still, और यहाँ पे अभी isobars है, and the winds are, what is ना, deflecting towards right along this low pressure. After the open wave stage, initial occlusion took place at the center low pressure at the center of low pressure, with heavy and torrential rainfall, with heavy and torrential rainfall. Initial occlusion means ground is covered with the cold air mass, but the low pressure, ground is covered with cold air mass, but low pressure has been shifted upward. And still wind is coming toward this low pressure in anti-clockwise fashion. As these winds are also moving in anti-clockwise fashion, during frontal open wave stays. The wind is also moving during the what? Frontal as well as in the open wave in anti-clockwise fashion, जो picture मैंने पहले दिखाया था. Understood it? So the wind is still circulating and then low pressure has been moved upward. Understood? Now, the cold air mass from the cold sector and then warm air mass, the shrink warm sector still wants to come towards low pressure center. Understood? Write down. Change the next point. I said that advanced occlusion. Next one I said so आपने जो देखा ये कैसा है? It is in a kind of what? Initial occlusion. This is in a kind of what? Initial occlusion. But final advanced occlusion में क्या होगा? It will be like this. It will be like, it has been completed and the warm sector has highly reduced, highly shrink. बहुत थोड़ा सा बच जाएगा. So the whole, the reason what I said that cold occlusion, so occlusion or warm occlusion has been taken place. Like I said that there is an initial occlusion, and after the initial occlusion you can be able to see only small sector has been left. It is known as advanced occlusion, and still the low pressure is over there in the above. Yes. So write down advanced occlusion. ध्यान रखिएगा लो प्रेशर हमेशा यहीं पर रहेगा. ओके, यहाँ पर after the initial occlusion, cold air mass from the cold front and warm air mass along the warm front started vigorously moving toward the low pressure center with heavy and torrential rainfall, along the cold front and drizzle along the warm front. a situation arrived where warm sector is about to finish through occlusion. It is known as advanced occlusion, and still heavy and torrential rainfall continue. Correct? So this is still continue. यहाँ पे rainfall is still continued. इसका मतलब cyclone has not been, and then wind is circulating around. Now as it will finish, so this structure covered. The whole ground is covered by whom? Cold air mass. And this is known as the what? Death of cyclone. Understood? Death of cyclone. And the situation, इसका मतलब है कि this is in a finished. This structure is finished. Again, this is in a cold region. This is again I said that polar high pressure, and this is when I said that subtropical high pressure. और ये again पहले जैसा हो गया, and again it is happening in the large area, and again warm westerlies and cold polar easterlies are coming, and they are ready for the stationary front. So it is a continuous phenomena throughout the year. It is a continuous phenomena throughout the year. Is it clear? And it is happening thousands of kilometers. I have said it is happening in the. So write down second last, death of cyclone. Death of sixth stage. Death of, क्योंकि मैंने दोनों ही चीज को एक साथ कंबाइन कर दिया, फ्रंट और इन दोनों को एक साथ मैंने कंबाइन कर दिया. डेथ ऑफ साइक्लोन और साइक्लोलिसिस और फ्रंटोलिसिस, तीन चीज कह सकते हैं आप. डेथ ऑफ साइक्लोन और यस साइक्लोलिसिस और फ्रंटोलिसिस. मीन्स फ्रंट इज ऑल्सो फिनिशिंग, साइक्लोन इज ऑल्सो फिनिशिंग. So cyclolysis, or you can say what? Frontolysis. Getting it? Clear? So write down. After the advanced occlusion, in the southern shrinked southern warm sector, occlusion in the shrinked southern warm sector completed and the whole ground is covered with cold air mass and rotating effect of wind also finished. Also, rotating effect of wind also finished with finishing of front formation. Therefore, this stage is known as frontolysis or cyclolysis. Frontolysis or cyclolysis. ठीक है? या तो फ्रंट खत्म हो गया यहाँ पर, साथ साथ में क्या हो गया? The temperate cyclone formation has been also finished. Okay? So you can be able to see, like I said, that this is the way it has been continued. और ये पहला स्टेज क्या है इस टेयर में? Stationary front stage. And the second stage is frontal wave stage. And who has given this? V. Jerkanis and J. Jerkanis. जनरली लोग ये सोचते हैं कि टेम्परेट साइक्लोन डजंट हैव आइसोबार्स. रिमेंबर दैट इट हैज आइसोबार्स. सो V Jerkanis and J Jerkanis, the father and son, has given the concept of temperate cyclone, and this is known as polar front theory. That is known as, क्योंकि उन्होंने क्या फ्रंट को ही बोल दिया, फ्रंट इज कॉजिंग, इज द कॉज ऑफ व्हाट? Formation of temperate cyclone. He has given that front is the cause of temperate cyclone. So therefore this theory of temperate cyclone, and he has given the 6 stages. First it is, I said that stationary front. और इसका मतलब यहीं से cyclone start होता है. Therefore it is also known as cyclogenesis or frontogenesis. These are the names. Cyclogenesis you can say, or frontogenesis. Birth of cyclone and birth of front, it is known as what? Frontogenesis or cyclogenesis. The stationary front formation is a cyclogenesis or frontogenesis. Second stage is, I said that, frontal wave. जो मैंने बताया था कि they started invading into the regions. Thereafter the formation of frontal wave. Third stage, I said that open wave. आपको बताया था, I said that warm air started reducing and then cold sector started what? Opening. And thereafter I said initial occlusion, and it can be of two types, cold occlusion and warm occlusion, and then there is an advanced occlusion. And then we can be able to say, like, क्या कह सकते हैं? Depth of cyclone, or we can be able to see like it is in a frontolysis or cyclolysis. और इसी में सारे फ्रंट भी बन जाते हैं, वार्म फ्रंट, कोल्ड फ्रंट, वार्म फ्रंट, ऑक्लूजन फ्रंट. This is the itself, it is able to give us an idea about it. Now, I said that these are the 6 stages of, I said that, आपने क्या देखा? Cyclone formation. And then temperate cyclone formation कहाँ पे हो रहा है? यहाँ पर. Where the cold polar easterlies and then warm air mass. और ये दिख रहा है आपको? And just इसके ऊपर क्या बन रहा है? Yes, polar front jet stream. Which one is forming? Polar front jet stream. So the next one that you have to understand, that the formation of polar front jet stream. इसका मतलब all are going together. First we have to understand it. I said पहला हम लोग just having a revision what we have said. I said what is the definition of front? It is in a 3-dimensional transitional zone having the two contrasting nature of air masses with the discontinuities of temperature, pressure and humidity. Understood? And now we have started with the front along with the cyclone also. First stage is stationary front stage. And I said that warm easterlies from the subtropical air pressure, subtropical high pressure, and then cold polar easterlies from the polar high pressure. These two different contrasting nature of air masses converges near mid latitude, or I said 50 to 60 degree latitude. But due to discontinuities in their temperature and pressure and humidity, they do not readily intermix and they stop for a while, and it is a creation of a stationary front. Understood? And after certain and during that period, slowly and slowly, westerly started somewhere, air started moving upward, and then after such long time, some little bit pressure has changed, and then warm westerlies started what? Dilating away toward the east along the axis of dilation, and cold polar easterlies started dilating away along the axis of dilation towards the west. Due to dilation of these cold polar easterlies and warm westerlies in the different direction, in opposite direction, air amount in the center has been reduced. And this is the low pressure has been formed, and this is the start of temperate cyclone. And now the फिर हमने आ गए frontal wave stage. Then after the creation of low pressure, that cold polar easterlies from the western side, they started invading with the high force toward the warm sector. It is the formation of cold front, and with the heavy and torrential rainfall through the cumulonimbus cloud, where the slope is 1 upon 40 to 1 upon 100, and then in a region they are giving torrential rainfall for 1 to 3 hours. On the eastern side, warm air mass started invading into the region of cold air mass. Warm air mass started invading into the region of cold air mass and started riding over with a very less slope, with a very slow speed, and that is 1 upon 100 to 1 upon 400 slope. And when it slowly started riding, it is making an nimbostratus, and then there is I said that altostratus and cirrostratus cloud, and giving a drizzle force continuous for 4, 5, 6, 7 days. Understood? In a given region. It is because it is in a wide spread or long area, and its speed is very slow, therefore it is staying for a particular region for long time. But after this stage is known as what? Formation of frontal wave stage. After that, the cold front and warm front started moving with comparative speed toward the south and started reducing the warm sector, and warm sector has been reduced, and then cold sector has been widely opened, and that is known as an opening of the wave stage. And when the frontal wave and opening wave stage is continued, then after that there is an isobar has been also developed. The winds are circulating in anti-clockwise in the northern hemisphere. Understood? And when it is circulating anti-clockwise and then open wave stage, and along the frontal, बार बोलते रहेंगे, along the cold front, heavy and torrential rainfall continue with the high speed, and along the open warm front, drizzle is going on in the form of these clouds. Then the third it is coming initial, fourth it is coming frontal wave, open wave, then it is coming stationary front, frontal wave, open wave, then it is an initial occlusion. At the low pressure center, the first occlusion done by the cold air mass of cold front and cold air mass of warm front, and after that heavy rainfall torrential keeps on happening. Low pressure region has been shifted upward, and then after the initial occlusion, then further the cold front and warm front become very vigorous, and they started coming toward and shrinking the warm sector, and advanced occlusion take place, and then thereafter death of cyclone. Understood it? And this is known as also 6 stages of temperate cyclone and all. Now we are going to understand polar front junction. What is the height of warm air mass? 6 to 8, or it can be 10 also. On an average 6 to 8 you can say. Okay. What is the height of warm air mass? Cold air mass? 4 to 5. And where this cold polar easterlies and warm westerlies are meeting? 50 to 60 degree latitude. तो दोनों में कैसा दिख रहा है? दोनों रीजन में कैसा ग्रेडियंट है? What is the change? Temperature, pressure, humidity को साइड में करते हैं. Humidity से तो rainfall and all it is happening. Yes. So what are the two types of changes? What are the two types of discontinuities? Temperature and yes, temperature gradient, and there is a pressure gradient. What is the height of warm air mass and cold air mass? So if I say that cold air mass is coming from this region, cold air mass is coming from this region, they have stopped for a while, and here who is coming? Tell me first. What is the height of warm air mass? This much. And what is the height of cold air mass? This much. Understood it? So the warm air mass is up to this and cold air mass is up to this. So what we will find? In the warm air mass, this side is very high amount of air, but in the cold air mass, this side is what? Yes, very, very less air. Getting my point? Who has? ये कैसे आ रहा है? Due to temperature gradient and pressure gradient. Who is causing? I said that temperature है यहाँ पर temperature difference. One is the warm air mass, another reason I said that cold air mass. So ये पूरा reason आप लोग क्या है? What is? आप लोग कैसे हैं? All of you are what is ना? Warm air mass. And then warm air mass height is what? 6 kilometer to 8, and cold air mass is, I said that, 4 to 5. So what happened? This side it is a pressure and this side is very less air. क्योंकि cold air mass क्या है? Below. What is the height? तो और इस 8 किलोमीटर पे cold air mass के ऊपर कैसा होगा? Very less air. Due to high pressure gradient, what happened? The wind started moving, and they started what? Deflecting towards right. Deflecting towards right. ये पहला कौन सा front बना हुआ है? Stationary front. I am just showing at the point of the stationary front there is a temperate cyclone. Who is there? Sorry, temperate cyclone. Polar front jet stream. So there is a warm air mass. Height is 8 kilometer, and here it is a cold air mass. So from this side there is no air. The wind started moving fast and then deflecting towards right, and they become like what is it? Polar front jet stream. So where the polar front jet stream is forming? At the transition zone between cold air mass and warm air mass due to the compatible availability of temperature gradient and pressure gradient. Yes or not? Polar front jet stream has been formed. And after that, ध्यान से देखेंगे what is happening. Here it is. I said that perhaps you remember it is a stationary front. In case of a stationary front in the upper atmosphere, who is moving? Tropical jet stream. Polar front jet stream. ठीक रहा? So I said that when there is a warm Westerlies and cold Polar Easterlies, then there is a formation of what I said that parallel to this polar front jet stream. But thereafter, what is that? Cold front, and there is what I said that warm front. And the cold front, what happened? The cold air mass in the cold front means when it is in putting the pressure, the warm air mass has caused the rainfall all, and this section has no air. So what is the cold front? This way there is a cold front, and this way the warm front. So when the cold front has gone up, so this side is cold air mass and this side is what? Warm air mass. And the warm front, this side has been covered by slowly and cold air mass, and this side is who? Warm air mass. Yes. So if it is in a warm air mass and this side is in a cold air mass, then the wind will come and deflect towards right in the northern hemisphere, and it will become what? Jet stream this side. And here it is in a warm front, and then warm front is there, then the warm front means warm air mass. This side is all of you are warm and you are shrinking like this. So now I can say that the warm air mass is up to this, and on the warm front, and this side is cold air mass. It means jet stream started becoming wavy. Jet stream started becoming, yes. As the frontal wave form, the same way our what? Jet stream also becoming, I have said that, abhi maine kya bola? This is what? Warm air, and this is in a cold air. Simple, very high pressure gradient, then wind will, so wind has deflected towards right, and become what? Polar front jet stream. As the front proceeds, become cold front and warm front. So if it is in a cold front, what is the height of the air mass over there? ये कौन सा air mass है? Cold. And this side who is? So यहाँ पे wind कैसे move करेगा? Under the high pressure gradient force. They will move like this. And the warm front also, I said that what is there? Warm air, it is in a warm air front. Warm front पे, this is a warm air mass, and this side is cold. सारे air ऐसे move करेंगे. So what is the direction of the movement of jet stream? They become wavy. That becomes, और ये कौन सा हो रहा है? Polar front jet stream is becoming wavy. It is known as Rossby. It is known as what? ROSS. And now आप लोग फिर देखेंगे for next stage what is happening? Cold front and warm front further, so that the jet stream will move like this, because the cold air is this side and then warm air is this much. So I said that, is it clear? So our jet stream is becoming more and more wavy, and it is known as Rossby waves. It means, I said that polar front jet stream follows the
frontal stage formation. Yes or not? And as the frontal stage formation proceeds, it becomes wavy, and that is known as what? Rossby wave. And if it is becoming, तो ये दिख रहा है. So this is the way that polar front jet stream is able to reach up to 30 degree north latitude also. जो मैंने बोला था कि you can't understand now today कि why it is moving in the Maritime region. आपको इतना ही समझ सकते थे कि बेल्ट शिफ्ट हो रहा है. That you can think like this. But today I saw that it is happening thousands of kilometers. It is happening, I have said that it is happening in thousands of kilometers, and it lies between 70 degree north latitude to 30 degree north latitude. This is the, and therefore 30 पे ये क्या reason आ जाता है? Maritime region. Understood? So we can be able to see this is in a Rossby waves, and further it will again finish, and there is an again start of what? Stationary front, and again the jet stream will keep on moving like this. Then again it will become wavy. So what we have seen? So polar front jet stream. If I say that moving, initially moving, yes, tell me, initially moving parallel to isobar along the transition zone of stationary front. Yes, initially moving parallel to the isobar along the transition zone of stationary front. जब stationary front has been formed, at that point क्या हुआ? When the stationary front has been formed, at that point they started moving parallel to the isobar along the transition zone of upper stationary front in upper atmosphere. As per the temperature gradient and pressure gradient. Which are the two changes are there? Temperature changes are there, and which are the pressure changes? As per the initially moving parallel to isobar along the transition zone of stationary front in upper atmosphere, as the temperature gradient and pressure gradient. As per the understood? Second steps, what happened? Thereafter, अब इसके लिए आगे स्टेज बताने के लिए I'll have to say something. Conservation of angular momentum का concept we have to understand. And what is the conservation of angular momentum? I said that m1 v1 r1 equals to m2 v2 r2. Momentum is m1 v1. Yes. Momentum किसको कहते हैं? m1 v1 equals to m2 v2, but there is an, I said, angular momentum with respect to r. So I said that यदि आपको याद हो r cross p, याद है आप लोगों को? 11th में पढ़ते थे, लेकिन फिर भी यहाँ पे ऐसे कुछ जानना नहीं उतना, ये doesn't matter. So I said that m1 v1 r1, m2 v2 r2. Can I cancel mass? Mass of air will be remains. Mass of the air will, what left with? We left with what? v1 r1 and v2 r2. Initially, you know that the jet stream is moving like this. Thereafter, the jet stream started taking like this. And when the jet stream started taking like this structure, तो इसका मतलब है it has some arc. Arc का मतलब है it will have some circle. This is in a, this arc से हम लोग क्या समझेंगे? It is in a kind of circle, and it will have some what? Radius. And thereafter again, further Rossby आप देख रहे हैं तो further it is in a what? Becoming wavy. It is becoming more wavy. So when it is becoming more wavy, then you can see that radius has further reduced. Radius has becoming more and more wavy means radius is decreasing. So suppose इसकी radius I said that 4 kilometers, suppose 4 unit, or total suppose energy is 100, or इसकी radius I said that 10 unit. So if I said that if the radius is 10, then speed must be 10 to making it 100. If the radius is 4, तो 100 बनाने के लिए speed कितना हो जाएगा? So when the radius is less, then the speed is increasing. आपने कभी बचपन में in the class कोई भी देखा होगा कि one doll is like this, another doll is like this. Another doll को आपने rotate किया तो its speed is more, and when the doll is like this, its speed is less. इसलिए जब jump करते हैं divers तो अपने आप को अपने radius को क्या करते हैं? देखा होगा ना पानी में. They try to bend themselves as much. जितना bend करेंगे उतनी speed बढ़ती जाएगी as per the conservation of angular momentum. So as much wavy this jet stream will be there, speed will keep on happening. और इस केस में इसकी speed कहाँ चले जाती है? 560 km per hour. Polar front jet stream reached up to 560 km per hour. Do you understand what is the reason behind that increase in the speed of this? And this thing is not happening in the subtropical jet stream. It is only happening in which? This kind of wave is forming in which? और आप भी polar front के साथ ही तो बन रहा है. Otherwise it will keep on moving straight. So the first we have seen the formation of stationary front, and then thereafter I will say that second point, as the different frontal formation process proceeds, polar front jet stream becoming wavy means becoming more and wavy. It is known as Rossby wave. तो Rossby wave पहले आया होगा या construction of temperate cyclone and front पहले लोग समझे होंगे. First they have understood what? Concept of killer. Then field Rossby wave has been found. Okay, this is the way. Third one, I said that this Rossby wave or polar front jet stream follows conservation of angular momentum. Therefore, when Rossby wave has more curvature, its speed is highest. Its speed is highest. जितना ज्यादा कर्व होते जाएगा, its speed will keep on increasing. ये सब मैथमेटिकली जैसे बताया, ये सब चीज भी आपको लिखकर वहां बता देना है. I said that we have been able to see, like I said, that in the polar front jet stream, तो आप लोग क्या क्या देखे आपने यहाँ पे? फ्रंट फॉर्मेशन आपने देखा. Which are the front? Stationary front, cold front, warm front and occlusion. In the occlusion, which are cold occlusion and warm occlusion. Understood? लेकिन along with this, you have seen the 6 stages of the temperate cyclone formation. लेकिन along with this, you have also seen that at the same time, who is moving? Polar front jet stream. and then polar front jet stream, ध्यान में रखेंगे, drags temperate cyclone from west to east. So west to east drag करने वाला कौन है? Who is? Polar front jet stream. Understood? Formation होते जा रहा है and इसके low pressure को खींचते चला जा रहा है कौन? Polar front jet stream. The polar front jet stream drags temperate cyclone from west to east. And now where they are, where this temperate cyclone is there, where? So maximum आप देखोगे कि यहाँ पर they will meet, yes or not, there will be good amount of moisture from both the sides. Yes. So this region, which Europe I said that? Which Europe I said that? Western Europe will have an what? Good amount of what? Formation of what? Temperate cyclone. The answer. And thereafter it is emitting from this side and emitting from this side. यहाँ पे कौन सा आ रहा है? Maritime polar और यहाँ पे continental tropical. Moisture कम होगा लेकिन rainfall तो temperate cyclone से होगा. So there is an this side. So कैसा देख रहे हैं? From northeast of North America to the Western Europe, we have a temperate cyclone distribution. Yes, tell me where is the distribution of temperate cyclone? Northeast of North America to the Western Europe. Understood? Now there is who is coming? Cold warm westerlies with the maritime tropical, and it is a continental polar comparatively less, and this Europe, this part of North America is receiving what? Temperate cyclone. लेकिन इसमें moisture बहुत लेकर आ रहा है, the heavy temperate cyclone rainfall. And similarly थोड़ा सा इसी region को थोड़ा back ले जाएं तो यहाँ पे आ जाएंगे हम लोग. So the eastern Siberia to the northwest of North America. So where is the another temperate cyclone? Eastern Siberia to northwest of North America. Understood? So where is the distribution? So the first distribution is, write down. The distribution is from northeast of North America to distribution North America to Western Europe. Second distribution, yes, कहाँ से कहाँ तक है? Eastern Siberia to, yes, Eastern Siberia to northwest of North America. Understood? दूसरी जगह पे भी होंगे, थोड़े बहुत होंगे, very less intensified. And क्योंकि अंदर जाते जाते as much will go interior, continentality will be more effect and moisture will be less, then this kind of situation cannot occur too much. जैसे जैसे interior continent में जाओगे there will be less. Clear? इसका मतलब कि यहाँ पर इस रीजन का टुंड्रा और टैगा और इस रीजन में टैगा, तो यहाँ पर टैगा काफी डेंस मिलेगा, यहाँ पे टैगा काफी डेंस मिलेगा, यहाँ पे कम मिलेगा, बिकॉज इंटीरियर में रेनफॉल रिड्यूसेस. यस और नो? एंड एक्सट्रीम क्लाइमेट में मिलेगा. टेम्परेचर विल बी कॉन्टिनेंटल में क्या होता है? टेम्परेचर वेरी कोल्डर इन द कोल्डेस्ट इन द विंटर एंड द सो एक्सट्रीम क्लाइमेट विल बी देयर इन द इंटीरियर. यहाँ तक मॉइस्चर बहुत कम रहेगा. एंड सम रेनफॉल इज ऑल्सो हैपनिंग. यहाँ से कौन आ रहा है? विच एयर मास इज कमिंग? टेल मी. तो यहां से आ रहा है कोल्ड पोलर ईस्टर्लीज और यहां से कौन जा रहा है? वार्म वेस्टर्लीज आर गोइंग ऑन. एंड यदि और भी वेरी वीक इट इज गोइंग ऑन, मॉइस्चर इज लेस, तो हु विल कैरी द मॉइस्चर? मैरीटाइम, आर्कटिक काइंड ऑफ इट. और वही थोड़ा सा यहाँ पे रेनफॉल करेंगे. अंडरस्टूड इट? सो दीज आर द होल व्हाट इज एन माइन्यूट अंडरस्टैंडिंग ऑफ इट. Okay, so this is the way we have been able to see which are the three topics. Yes, front, temperate cyclone 6 stresses, And then front में कौन कौन सा? Stationary, cold, warm and occlusion. Yes, which are the front? First stationary, second cold, third followed by occlusion. वो नहीं बोलोगे तो कहाँ से होगा? That is the death of cyclone. And then which are the 6 stages of temperate cyclone formation? Stationary front, wave, frontal wave, open wave, initial occlusion, advanced occlusion and death of cyclone. Understood? याद हो? So the first factor, you know that large supply of warm water. Then I said there is an presence of group of islands, upper air divergence, presence of ITCZ and Coriolis force, weak shear force, easterly wave produced under the influence of northeast and southeast trade wind, and atmospheric instability. These are the factors which are causing formation of tropical cyclone. And then और इसका formation जो होता है, it is forming between 5 degree to 20 degree north as well as in the south. And why it is not below 5 degree north to 5 degree south? One that you know, because between 5 degree north to 5 degree south, in the first class I have said, there is a very weak or negligible Coriolis force, therefore there is no formation. The southern limit is due to, I said that, weak Coriolis force. So we are going to see and आप लोग बनाते चलना. There will be no special dictation or special writing and all. आप लोग जितना अच्छा समझ जाओगे, that much you can be able to write better way. If I say that हमने कहा कि this is an equator, and if I said that in equator, when the sun comes in the 21st March, yes, at the equator equinox, after that the sun started moving toward the Tropic of Cancer. Slowly and slowly this region started getting hot and hot. Yes. So by June, 21st June, it will be able to reach at equator, at Tropic of Cancer. Yes. So for 3 months, this region has got high temperature. For 3 months, this region has got the temperature. And again, so when the sun rays are falling, here it is in this region, so here it is a 70 or 80 degree falling. And when the sun is coming over there, vertically, then even then this region is getting heavy, sun insolation, 70 degree, 80 degree, 90 degree. So it is in a warming, and when the sun comes again in the month of July and August, here it is around, and by September को यहाँ आ जाएगा. So between this, by reaching here, अभी भी in the month of August, the sun it is in a very high in the northern hemisphere. By reaching August month, this water become warm enough to give water vapor. Clear? अच्छा, warm enough कहने का मतलब क्या है? What is the meaning of warm enough? First factor, you remember, large supply of warm. You know that then specific heat of water is very low, and it takes time to get warm. Suppose I said that this is a sea surface and its temperature become 27 degrees Celsius, and there is a water vapor is going on, and that is converting into cloud and latent heat of condensation, released heat. और जब हीट रिलीज हो रहा है देन इट इज ना धीरे धीरे ये क्लाउड ऊपर जा रहा है एंड देन देयर विल बी व्हाट एंड सपोज डेप्थ ऑफ द सी वार्म टेम्परेचर जो 27 बोला इट इज इन 5 मीटर. हाउ मच डेप्थ दिस 27 डिग्री सेल्सियस टिल द डेप्थ ऑफ 5 मीटर. लेकिन आफ्टर 5 मीटर जैसे ये पानी एवोपरेट हो गया 5 मीटर का तो नीचे का 22 डिग्री सेल्सियस का पानी यहां पर आ गया एंड देन एवोपरेशन विल स्टॉप. यस और नॉट. साइक्लोन कैन नॉट डेवलप. साइक्लोन डेवलप के लिए क्या चाहिए? देयर शुड बी अ कंटिन्यूअस सप्लाई ऑफ large supply of warm water. So to become 27 degrees Celsius till the depth of 50 to 60 meter, and it will not going to happen in the month of March, April, May and June. Sun heating is more, but slowly and slowly that the upper water started getting warm and it is able to reach up to what 50 to 60 meter. Yadi if it is only upper surface is warm and you say sir 28 degrees Celsius cyclone should start, yes I said that it start. It will form also, but in between it will finish also. The reason behind supply of warm water stop, and then supply of warm water means what? I said that if it is in a 27 degrees Celsius और ये ऊपर गया, earlier classes में मैंने कहा था cloud formation. Suppose I said that 1 lakh liter of water and it has given some heat after the condensation, and this heat causes this atmosphere to what is become expanded. Latent heat of condensation has released the heat, and that therefore the temperature in the what is an atmosphere has increased, and then this way it become lighter. What are the two things happen? It become lighter. Another I said that there is also creation of what? Low pressure. Due to more heat it become warm and created a low pressure. Therefore the cloud form will what? Move up, and it has come up to this height. And then this time what happened? It is in a lighter and also low pressure. Earlier 1 lakh liter water is going due to the sea surface temperature, but now due to this low pressure they will attract more, and this time I said that it is in a 1.75 lakh water gone up. And they have converted into more cloud, bigger cloud, and bigger cloud has given more latent heat into the atmosphere during the condensation, and that is this time more heat, and the low pressure is more, and this time low pressure I said that high low pressure. ये low pressure कैसा बनता जा रहा है? It is very high. And then this time not only 1.75 lakh come, it will be because of the more low pressure it will attract more water, and then it will keep on coming. और आस-पास के छोटे-छोटे storms will also, smaller storms will also started attracting because of this low pressure. And then this cloud has gone up further, and this time they have released what is it 1.75 or ज़्यादा ले लिया 3.25. So this time 3.25 lakh liter has released the more water latent heat and more heat, and this time more cloud, and it is going to keep on happening. लेकिन यदि पानी यहीं तक रहता तो कुछ देर के बाद ही surface water warm has been what? Stopped, and then what is I said that will not be able to have a developed cyclone. So therefore sea surface temperature should be till the depth of, yes or not? समझ में आ गया? To continuous supply of heat is very much required for the developed cyclone. What is the first factor? What is the first factor? Sea surface temperature should be equal to or more than 26.5 degrees Celsius till the depth of 50 to 60 meter to large supply of water or continuous supply of warm water. Understood it? Otherwise what will happen? We will not be able to have developed cyclone. The development of cyclone will stop. समझ में आ गया? Because the colder water from the below it will come. लिख सकते हैं आप लोग? समझ में आ गया completely? So this way we'll be able to see in the ocean the first factor. हमने क्या बोला? Yes, I said that. First I said that हमने क्या बोला था? Disturbance, depression, cyclone, super cyclone, super typhoon. Is it clear? Which are the name I said? Disturbance, depression, cyclone, super typhoon. Understood? in the initial level, what I said that very weak tropical disturbance came into existence. क्या है? Large supply of warm water has given some low pressure, and initial level पे what we are able to give, what we are able to get. So the first factor has given us very weak tropical disturbance. Understood? What he has given? Very weak. Which factor? तो कैसे डिफाइन करोगे ये स्टेप में? फास्ट. किस मंथ में? अगस्त के बाद. समझ में आ रहा है? स्लोली एंड स्लोली. August to December month. Up to what? In the northern hemisphere, from the month of August to December. In northern hemisphere, from month of August to December. What happened? Sea surface temperature becomes, yes, tell me, more than 27 degrees Celsius till the depth of. लिख सकते हैं कि नहीं लिख सकते हैं आप लोग, या मैं बोलते रहूं और आप लोग लिखते रहोगे? आप लोग जब, इसीलिए मैंने बोला कि वट एवर द पॉइंट्स आई से दैट यू हैव टू कीप ऑन राइटिंग. सेम चीज को मैं बाद में वही बोलते रहता हूं, तो वट हाउ यू कैन डू इट फास्ट व्हेन आई से समथिंग कीप ऑन राइटिंग. I said that in the month of, in the northern hemisphere, from the month of August to December, the sea surface temperature become, yes, tell me, equal to or greater than 27 degrees Celsius or 26.5 degrees Celsius till the depth of, most important point is what? 50 to 60 meter. Otherwise, till the depth of 50 to 60 meter, which is very much compatible to provide us developed cyclone. And it will be what? For providing developed cyclone. It will be able to provide, yes, developed cyclone. किधर? And इसके वजह से हमें क्या मिल गया? Yes, tell me, very weak tropical disturbance. एक low pressure छोटे छोटे से मिलने लगे, and then the air started rising up. Now the next, it is, I said that another factor is, I said, और ये चल रहा है, this phenomenon is going on, और this is now, first factor will be superimposed over the second factor. Second factor, I said that presence of group of islands. Presence of group of islands. I said that this is one island and it is surrounded by, I said that comparatively a smaller island. And these are comparatively so I said that land get heated fast, yes or not? As per the specific heat, as per specific heat, what happened? Land get heated 4 times faster than water body. Correct? Got it? इसमें से कौन सा आइलैंड सबसे ज्यादा हिट अप होगा? Which island will be more hit up and from where the more air will go above in the atmosphere? Huh? The island at the center. They have a large land mass and from there more air will go. And they will have a creation of, what I said that, suppose it is a creation of 994 MB. How much? Suppose 995 MB. How much? And it will be surrounded by, some in the water body. Water body भी यहाँ पर बन जाएगा और ये water body ठंडा होगा. So there will be surrounded by what? High pressure. And one low pressure has been formed in the island. Yes. और साथ साथ में यहाँ पे क्या हो रहा है, ओशियन सरफेस इज ऑल्सो, अभी सी सरफेस टेम्परेचर आई हैव सेट. नाउ दिस आइलैंड has become, I said that 998 MB, comparatively less warmer. But this island will be also surrounded by, yes, water body which is in a colder than this. It is known as what? Subtropical, sorry, comparatively high pressure isobars. And this island will be, I said that 1002 MB. ये भी heated है 1002. Is it clear? So land get heated faster 4 times than the water body as per the specific, as per the is it clear? As per the specificate. Now you can see that due to this differential heating of land mass and water body in the island groups, what we are able to see, small storms has been created in large number. ये छोटे छोटे storms बन गए. Yes or not? Surrounded by high pressure. There is a small storms has been created in large number. Understood? With low pressure at the center. Small, they have been formed. And one of the island will become more low pressure than the others. And one of the island become more low pressure than the others. And other island group will become what? Comparative high pressure centers. इसके comparison में they are becoming high pressure centers. And इसके comparison में these are the high pressure centers. And they started moving towards, I said that they started moving towards this low pressure center and deflecting towards what? Right in the northern hemisphere and left in the southern hemisphere, right in the northern hemisphere in the anti-clockwise fashion, and start moving toward this low pressure center, and it has given more moisture. Yes? So other low pressure centers, surrounding low pressure center become also high pressure center comparatively in the form of high pressure isobars, and they started moving toward the more lowest center, low pressure center in the form of anti-clockwise fashion. And they're contributing moisture along with the warm air, moisture and warm air, and made it further more low pressure. So it will पहला वाला क्या था? Very weak tropical disturbance. And it has converted into, tell me, weak tropical disturbance. अब थोड़ा सा pressure और low हो गया. Very weak नहीं है, weak tropical disturbance. It has converted into weak tropical disturbance. So the first stage has given us what? Very weak tropical disturbance. Second has given us weak tropical disturbance. Understood? Right now. Due to differential heating of land mass and water body, land mass get highly heated, than surrounding water body. In case of island, island will become low pressure center due to 4 times heating than water body surrounding. This way, low pressure island will be surrounded by comparative high pressure isobars. low pressure island will be surrounded by high pressure isobar water body. In case of large group of island, large groups of island, there will be several low pressure centers or storms but one of the low pressure center on a given island become intensified low pressure center and start attracting other low pressure centers or storms which are comparatively high pressure. Such smaller low pressure centers or storm moving towards intensified low pressure center with a little anti-clockwise fashion and contributing enough moisture to make low pressure center intensified low pressure center as a weak tropical disturbance. So there is a development of what? Weak tropical disturbance. Now it is, तो ये किस में convert हो गया? It has converted into what? Weak tropical disturbance. And above there, जब ये weak tropical disturbance, large amount of convergence of air is coming, and they started also rising up. They also started what? And when the air is going up, so it will make this region, suppose it is in the same pressure, when it is going up, it will become in a what? More high pressure than the surrounding. Yes. So the air will start diverging. जब तक ये जा रहा है तब तक it was in a weak tropical disturbance. When it started going up, and after reaching and in the upper atmosphere become very highly anticyclonic or divergence. So upper anticyclonic or divergence started. Once a mechanism started, so what will happen? It started sucking the air from the down. Yes or no? Yes or not? After the formation of weak tropical disturbance on the sea surface or group of island, and when in the upper atmosphere divergence started. Understood? When the upper mechanism तुरंत तो तैयार नहीं हो जाएगा, it will go up and then slowly contributing, and then फिर ये mechanism start हो गया. So I said that हमने क्या कहा? Yes, upper air divergence started, then they sucking more air from the what? Down, and made this weak tropical disturbance into, yes, developed tropical disturbance. Weak से अब कैसा हो गया? It has converted into developed. अब now the pressure difference is around 20 MB, 15 MB. Understood? The pressure difference become 20, 15 MB. So it is a developed tropical disturbance. The wind started moving fast. First case ने क्या दिया था? Very weak tropical disturbance. Second case has given was weak tropical disturbance and upper air divergence. Who has started this upper air divergence? ये सारे ही तो start किए. and then it started coming up. आपको ही पता है, I've said so many times, ये बहुत गर्म होगा तो बहुत ज़्यादा, the maximum air will come, and if it is, suppose I said that it is in a 700 and it is in a 700 and it is in a 700, when it is going more and then it becomes 740 or 750. अब इसने मशीन तैयार कर दिया, it has started the mechanism, and then what happened? High pressure it become low pressure, it become what? Low pressure, and then the air started what? Diverging. And when the air started diverging itself, it started what? Sucking the air from down. First, there should be a start of divergence. और divergence कौन start करेगा? जैसे जैसे इसमें air बढ़ता चला जाएगा. And when it becoming more and more air, it will become high pressure, and then it started divergence. The second phenomena is what? Upper air divergence. So after the development of upper air divergence above weak tropical disturbance in the upper atmosphere, then the anticyclonic condition, yaad hai na, high pressure or divergence will start sucking the air from the down and made weak tropical disturbance into what? Developed tropical disturbance. Write down. So very weak tropical disturbance, say weak tropical disturbance, 2 steps we have seen. And after that, which step we have to see? Developed tropical disturbance. ध्यान में रखना, आप लोग केवल पढ़ते आते थे कि अपर एयर डाइवर्जेंस, लेकिन अपर एयर डाइवर्जेंस ने साइक्लोन ने खुद ही बनाया है. लेकिन स्टार्ट होने से पहले जब तक एक मशीन नहीं खींचने लग जाएगा, कभी कभी आप कुछ डालने लग जाते हो, फिर उसके बाद मशीन स्टार्ट हो गया तो अपना तेल खुद ही खींचने लग जाता है. यस और नो? So that it will start, once it will start, and then started sucking, the mechanism to start first. So write down what the point I have said. Upper air divergence. Third point is upper air divergence in the bracket anticyclonic condition. After formation of weak tropical disturbance over the sea surface and group of islands, in the upper atmosphere, upward moving air and moisture in the upper atmosphere, upward moving air and atmosphere, upward moving air and moisture created enough high pressure or divergence, so that mechanism of circulation start. जैसे ये हो गया. As the mechanism of circulation starts by the upper atmosphere, तो अपर एटमॉस्फेयर में क्या होगा? एयर स्टार्टेड डाइवर्जिंग, देन air started diverging with high speed and sucking more air from the ground. Therefore, on the ground, weak tropical disturbance converted into weak tropical disturbance converted into developed tropical disturbance. With a pressure difference of around 20 MB. With a pressure difference of around 20 MB. Understood? So this is an equator, and suppose it is in India. Suppose I said that. Okay. And यहाँ पर हमारे लिए there is an Andaman Nicobar Island groups are there, and there is a cyclone has been developed, and then what is the which kind of formation? Developed tropical disturbance. Developed, and now अब यहाँ पर क्या आ गया? There is a what? There is a developed tropical disturbance. Fourth point I have said that presence of ITCZ. Presence of what I said that? And what is the meaning of presence of ITCZ? Means there is a who is coming? Northeast trade wind. पहला छोड़ दो. Presence of ITCZ का formula क्या है? What is the meaning of ITCZ? Intertropical convergence zone. And itself ITCZ is in a low pressure. Yes. ITCZ क्या है? Yes, tell me. ITCZ is the concept of low pressure. Further, it enhance the development of tropical disturbance. ये further more developed tropical disturbance. अभी developed tropical disturbance, more developed tropical disturbance. और जब more developed tropical disturbance होगा तो ITCZ has been converted into what? ITCZ ने इसको किसमें convert कर दिया? Depression में. ITCZ has already the low pressure, and I have what? Developed tropical disturbance due to the upper air divergence. अब यहाँ पर ITCZ has made it to convert into what? Depression. Then the low intensification of low pressure of ITCZ had made it depression. Had made it into what? And जब ये depression में convert हो गया, ध्यान से, the wind that which are the wind? Northeast trade wind, and then southeast trade wind, which becomes southwest. Southeast trade wind, they started converging fast toward this disturbance. It has been a depression, na? It has converted and fastly, and they are coming with the lots of moisture. And then there is an MB difference is fast, and the MB difference is fast, and this is an I. This is in a center with the low pressure. The wind cannot come. MB difference, the more deflection. Yes or not? So center पे क्या बन गया? Yes, tell me. यहाँ पर one, it is in a low pressure with the disturbance, which has been converted into depression, and then wind started. पहले suppose करो disturbance था, the wind are deflecting towards like this. Even then यहाँ पर पहुँच नहीं पा रहे थे. But now it has been converted into depression, more low pressure. If it is becoming more low pressure with the depression, the wind speed increased. Pressure difference means more cold is force. Higher the speed, more the cold is force. Then the wind started circulating. And now the wind is not able to reach up to what? This region. And ये बन गया large eye of the cyclone. The reason where the wind is not able to reach, it is known as what? क्योंकि यहाँ से जाने से पहले he is not going to the center. वो क्या हो रहा है? More the speed, more the deflection. More the speed, more the deflection. More the speed, more the deflection. So the wind is not able to reach, and it becomes a development of what? Eye of the cyclone. And when they are coming, this northeast trade wind and southeast trade wind is coming with what? Tell me. They are coming with what? Lots of moisture. And when they are coming with the lots of moisture, यहाँ पे आ रहा है, they are coming towards this lots of moisture, then what will happen? Moisture will what? There is an eye, the circle where they are not able to reach, that becomes a what? Eye of the cyclone, and they started circulating around this. Everyone is circulating around it, and then they started rising around this eye. क्योंकि अभी इसके बाद जाना कहाँ है इसके पास? and there is an what? आपको ही बताया था कि मैंने latent heat of condensation has created further more low pressure in the upper atmosphere. They started sucking the air from the top down. Yes or not? They started rising up. Latent heat of condensation has created a more low pressure in the upper atmosphere, and they started what is in a circulating wind started moving upward around the eye, and when around the eye started rising up, they are contributing more moisture, more low pressure, and more low pressure means more pressure difference. Now it become what? 30 MB. Now 30 MB बन गया, तो speed increased. अब wind will not be able to reach, wind will deflect much early, and this way cyclone, eye of the cyclone become very, very large. And then wind started keep on what is it? Rising up, circulating around, and started rising up. Yes or not? And that is known as an eye wall. जहाँ पे first center become the circle, it is an eye, and where the wind cumulonimbus cloud keeps on forming, that is known as what? Eye wall, and that is in the form of cumulonimbus cloud and heavy and torrential rainfall. Heavy and torrential rainfall. This is an I said that heavy and torrential rainfall. Is it clear? समझ में आ गया? What is this? ये कौन सा है? And diverging away. So there will be a formation of cirrus and cirrostratus cloud. ऊपर में divergence होगा. And in the sky, if suddenly if you are able to see large number of cirrus cloud, it means it is an indication of what? Cyclone is going to come. It is an indication of cyclone is going to come. समझ में आ गया? Why? How? Who has given us large number of cirrus cloud? Upper air divergence. Understood? So ITCZ ने मुझे क्या दिया? ITCZ has converted tropical disturbance into developed tropical disturbance into depression. And the depression has what made the northeast trade wind and southeast trade wind to move and reach toward the center very high speed. Under high pressure gradient force, they started deflecting towards right and then circulating along a circle. That becomes eye of the cyclone, where the wind is not able to reach. Understood? And slowly this depression, and then when the wind started circulating around, and then latent heat of condensation in the upper atmosphere, they started sucking this circulating air upward with the cumulonimbus cloud, and they are contributing more latent heat of condensation, and that making it more low pressure, and more low pressure means eye of the cyclone will become लार्ज होगा. अब वहां पे बार बार बोलूं कि इट विल डिफ्लेक्ट फर्दर मोर एंड देन आई इज इंक्रीजिंग, ऐसा तो नहीं होगा. बार बार मैं बोलूं इट स्टार्टेड, जितना ज्यादा लो प्रेशर होगा प्रेशर डिफरेंस विल क्रिएट एंड मोर कोल्ड फोर्स विल हैपन. So therefore the diameter of the cyclone can be 15 kilometer, maybe 20, 30, 40, 50 kilometer. Yes, the eye of the cyclone can be how much? 15 to 50, 15 to 50 kilometer. It depends upon the intensity of pressure difference which is developing. So what is the fourth stage? I said that presence of ITCZ. And ITCZ ने क्या किया? Developed tropical disturbance को किसमें बना दिया? ITCZ is already a low pressure and this developed already. मुझे I have an what this is an यहाँ पे I have an developed tropical disturbance, लेकिन इसी समय हमारा ITCZ इसके ऊपर आ गया. Then it has converted into, समझ में आ गया, depression. And further deep to depression, then what will happen? मैंने बोला था ना, presence of ITCZ and Coriolis force. The fourth factor is what is it? Presence of ITCZ and Coriolis force. So write down. Fourth factor is presence of ITCZ and Coriolis force. When developed tropical disturbance come under ITCZ, then the low pressure further intensify, and convert into depression. means pressure difference developed around 25 to 35 MB. Pressure difference developed around 25 to 30 MB. Under such high pressure difference, wind with moisture, northeast trade wind and southeast trade wind with their moistures, एक तो wind है, दूसरे winds, and other it is a northeast trade wind and southeast trade wind with their moisture, started moving towards depression, with the high force and speed. Therefore, with high force and speed, therefore, under Coriolis force, started deflecting rightward in anti-clockwise fashion, and wind is not able to reach to the center, and created a large circle with calm condition. Understood? It is known as eye of the cyclone. This condition, eye of the cyclone, has further intensified pressure gradient, which become around 30 to 40 MB. Clear? तो दो फैक्टर्स आ गए. One factor, high pressure difference come 30 to 40 MB, wind will come faster and they are not able to reach to the center, so they are started circulating. And another, upper atmosphere may latent heat of condensation, the low pressure from the latent heat of condensation, they started what? Making the wind move upward with the cumulonimbus cloud with high speed circulating around eye. So write down, such high pressure difference and latent heat of condensation in the upper atmosphere started making wind to circulating fast around the eye with upward convection, which helped in the formation of eye wall, surrounding eye. Clear? This rising air with moisture able to form cumulonimbus cloud able to form which cloud? Cumulonimbus cloud with torrential rainfall. So this cumulonimbus cloud and then cumulonimbus cloud in the temperate cyclone, दोनों में difference है. यहाँ पे large moisture with torrential rainfall. Clear? समझ में आ गया यहाँ पर? So यहाँ पर अब क्या करना है? I has been what is formed like I said in the center and the eye wall में the wind are circulating under the latent of condensation and it is moving upward. It keeps on moving upward. And then I may speed can vary up to what I just said that 50 km per hour to what I said that 200 km per hour. In case of cyclone, the wind speed can be what? 50 km per hour to 50 to 200 km per hour with the different intensities. Understood it? And when they are coming and if they are able to contribute more moisture than the wind speed, then if they are able to contribute more moisture, then the wind speed further intensified under the Coriolis force and eye of the cyclone keep on enlarging. And when the eye of the cyclone keep on enlarging, then the wind speed around the eye and the eye wall also getting higher and higher. And when the wind speed able to reach 210 km per hour even for 1 to 3 minutes, it is known as super cyclone. And if it is able to reach up to what I said that 230 km per hour even for 1 to 3 minutes, it becomes super typhoon. तो ये समझ में आ गया कि अब now it depends upon the moisture contribution, warm air moisture contribution to make it more and more warm. And if it will become more and more warm, more moisture, then it will make it to what is a more pressure gradient, and more pressure gradient make the what is a more Coriolis force. And Coriolis force जहाँ पे if the air is not able to, if the air is reaching up to this, now air is reaching up to this. So that become this much cyclone, the eye of the cyclone will become large enough. Understood? So the change the para. When contribution of latent heat of condensation is high enough, then northeast and southeast trade wind along with other wind under high Coriolis force will be able to create cyclone with large eye. Cyclone with large eye and upward moving and circulating wind in the eye wall will proportionally increase. If the speed of circulating wind in the eye wall reached equal to or beyond 210 km per hour, it is known as super cyclone in the bracket even for 1 to 3 minutes. And if speed exceeds 230 km per hour, it is known as super typhoon. diameter of, change the para, diameter of eye of the cyclone varies from 15 to 50 किलोमीटर. ध्यान से देखेंगे यहाँ पर एक चीज, ये जो ऐसे विंड दिखा रहा है, ध्यान से, जब ये हाई प्रेशर बन गया, द सम ऑफ द विंड स्टार्टेड व्हाट इज ना डिसेंडिंग, टचिंग टू द आई वॉल, विद इन द आई. Most of the air is what is na moving away. Most of the air is what is na moving away in the form of what is na wind. But some of the air descending not in the eye wall but in the eye, touching to the eye wall. When they started descending, touching to the eye wall in the eye through the adiabatic compression, they further increases the temperature of eye. Under descending air, what will happen? It will increase the temperature. And when the temperature will increase further, it will make the eye to be what? Yes, more hotter and more pressure difference. Is it ever understood it? Right now? From the upper atmosphere, some air used to descend in eye. Some air is to descend in eye, touching to the eye wall, and descending air through adiabatic compression further increases temperature of eye, and it help in further intensification of cyclone. Clear? समझ में आ गया स्ट्रक्चर? This is, I said that, so I said that cyclone has been, I said, formed. और suppose करो कि next one I am going to say Westerly wave, sorry, weak shear force. और साइक्लोन जो आपने देखा, देर इज एन, आई सेड दैट आई वॉल इज देयर. इसका मतलब बहुत बड़ा वर्टिकल स्ट्रक्चर है. इट हैज एन वर्टिकल स्ट्रक्चर, इट इज एन वेरी हाई वर्टिकल स्ट्रक्चर. एंड व्हाट इज द मीनिंग ऑफ शियर फोर्स? शियर फोर्स मीन्स यहाँ पे ज्यादा फोर्स और यहाँ पे कम फोर्स. देयरफॉर इट विल बी लाइक दिस. सपोज आई सेड दैट हु ड्रैग्स दिस ट्रॉपिकल साइक्लोन. जनरली आप लोग पढ़ते हैं नॉर्थ ईस्ट ट्रेड विंड एंड साउथ ईस्ट ट्रेड विंड ड्रैग्स इट फ्रॉम ईस्ट टू वेस्ट. अभी टेम्परेट साइक्लोन को कौन ड्रैग करता था? पोलर फ्रंट जेट, एंड दैट इज फ्रॉम वेस्ट टू ईस्ट. एंड ये ईस्ट टू वेस्ट हु इज ड्रैगिंग? नॉर्थ ईस्ट ट्रेड विंड एंड साउथ ईस्ट ट्रेड विंड. लेकिन एक्चुअल में होता कैसे? हु ड्रैग्स इट? तो आई सेड दैट, लेकिन पहले हम लोग इसको समझ लें. दिस इज एन वर्टिकल स्ट्रक्चर. I said that northeast trade wind and southeast trade wind is dragging the cyclone from east to west. When it is dragging, तो ध्यान से रखना, यदि if it is dragging with the, I said that 10 किलोमीटर पर आवर, धीरे धीरे आ रहा है. If it is coming 10 किलोमीटर पर आवर, तो इसका मतलब everywhere it is getting the force of what? 10 किलोमीटर. So the whole structure, if my structure has to move equal in amount, everywhere I should have now what? Equal amount of force. And suddenly, if I get more force from the top, if it is in a 10, and I got what is in a 14 from the top, then upper structure will move away. And if the upper structure moved away, तो जिसने latent heat of condensation जो कि attract कर रहा है, they will what is in a stop. and the death of cyclone will occur before the development of cyclone, before the formation of developed cyclone. So there should be shear force कैसा होना चाहिए? Very weak. Yes or not? The shear force should be what? Weak. Understood it? So write down. For maintaining the vertical structure of tropical cyclone, for maintaining vertical structure of tropical cyclone, there should be weak shear force, otherwise vertical structure will be dismantled and cyclone cannot fully developed, cannot be fully developed. Understood? Weak shear force. Generally, next point we are going to say, क्या था next point after the weak shear force? Easterly wave. क्या था? Easterly wave, or better to say northeast trade wind or southeast trade wind. लिख लेंगे direction. Easterly wave or direction of tropical tropical cyclone. Now tell me, who is coming here? Northeast trade wind, southeast trade wind. In a large area it is coming like this. Suppose and then southeast trade wind it is coming, तो जहां पे ये मिल रहा है तो possibly हो सकता है कि कोई एक ऐसा रीजन हो जहां से there will be, if the northeast trade wind and the southeast trade wind is coming and then it is converging and then moving upward. It is a part of Hadley cycle ना. It is coming and then moving upward. लेकिन some region से ज्यादा उठा और कहीं से क्या हुआ? Less has been uplifted. So the more air nearby this, less upliftment and more upliftment has created what? Yes or no? So within the ITCZ we have what? Wind is moving from east to west. Actually he drags it. Actually who drags? Just tell me. Easterly coming from east within the ITCZ. So under the influence of what? Northeast trade wind and southeast trade wind, and easterly wave develop within the ITCZ. यहाँ से ज़्यादा उड़ गया और यहाँ से कम, तो there will be more air on the ground, and then slowly an easterly wave developed. We started dragging cyclone from what? East to west. लेकिन साथ में मैं बताऊं, along with, if you see that India is over there, so this is in a general direction. If I said that it is in a what? General direction for the east to west, who is causing trade winds under the easterly waves. But they used to follow, यदि बनेगा तो they should, like I said that it is in a Malaysia, it is in a Somalia and all, तो यहाँ पे बना हुआ cyclone they should go like this. But why it is going like toward the Karachi, and Karachi जाते जाते they started what is in striking Gujarat coast. According to the easterly wave, this direction cannot be possible. So generally they follow pressure gradient. जहाँ उसे pressure मिल जाएगा, they will start moving. In India, last year 2015 में, in the November month, and a tropical cyclone develops in 2015, and it is about to reach Andhra coast in the November month. But by reaching here, the low pressure system has been disturbed यहाँ पर, and thereafter इसकी भी intensity घूमते घूमते कम हो गई, and then one low pressure center has been shifted towards, फिर दिसंबर के first week में this low pressure center shifted towards चेन्नई. तो ये पूरा cyclone के तो था ही नहीं. This small cyclonic structure strike Chennai and caused heavy rainfall. Understood? that is a flood of Chennai. क्लोन को घुमाते घुमाते ले जाना है ना, धक्का देते हुए थोड़ी ना ऐसे जाना है. क्लियर? सो कहाँ थे? Easterly wave. Write down. Under the influence of northeast trade wind and southeast trade wind, under the influence of northeast trade wind and southeast trade wind, a easterly wave created within ITCZ which drag tropical cyclone from east to west. From east to west. Yes. I said that suppose it is dragging towards east to west. और यहाँ पे भी एक साइक्लोन बना and thereafter it is dragging towards east to west. So it is coming like this, and this path of tropical cyclone under the Coriolis force will start deflecting towards right. So the path of tropical cyclone will be कहीं भी रहेगा, that they will have a what? Curvilinear path. And if it comes under high pressure, if it comes under subtropical high pressure belt, then there will be a death of cyclone before reaching to the ground. Before reaching to the ground, yes or not? क्योंकि high pressure मतलब subtropical high pressure, and what is happening at subtropical? Air is descending. अब यहाँ पे साइक्लोन के सेंटर पे पूरा एयर डिसेंड होने लगा. This structure will what? Finish. So the death of cyclone will occur when it is coming over there. First point. And second point, पहला डेथ देख लिया हमने. Second, I said that this is in a suppose subtropical high pressure. What is the meaning of subtropical high pressure? The wind is diverging. Wind is diverging, and it will in the form of what? Clockwise, rightward deflection. साइक्लोन एंटी क्लॉकवाइज और एंटी साइक्लोन क्या होता है, बनाया था आप लोग इनिशियल क्लास में. When the path of curvilinear path of cyclone, tropical cyclone comes at the periphery of subtropical high pressure. I have said that subtropical high pressure is not a continuous phenomenon. If it comes at the periphery, not at in the subtropical high pressure, if it comes, then ये इसको क्या करेगा, इसको पुश करके then tropical cyclone move towards poleward, and poleward तक तो जाएगा ही नहीं, क्योंकि sea surface temperature वैसा मिलेगा नहीं, and thereafter moving towards high latitude, depth of cyclone occur. Understood? Another. So what are the two things we have seen? If it comes under the high pressure belt during the curvilinear path, death of cyclone will occur, and if it comes at the periphery of subtropical high pressure, this subtropical high pressure will drag it towards poleward, and further, in the absence of compatible condition, the death of cyclone will occur. Third, when the cyclone is moving to the coast, if it is able to come to the coast, then automatically the supply of warm water from the sea surface stops, land comes. And when the supply of warm water stops, after some period it will what? Finish. Okay, latent heat of condensation. The three things I have said. So write down. When the cyclone, tropical cyclone path is from east to west, in northern hemisphere, then under Coriolis force, it started deflecting rightward and able to get curvilinear path and able to get curvilinear path. During this curvilinear path, two things can happen. Three things can happen. First, if developed tropical cyclone comes under subtropical high pressure belt, automatically death of cyclone or cyclolysis will occur. Death of cyclone or cyclolysis will occur. Second, if moving tropical cyclone come at the periphery of subtropical high pressure, then this subtropical high pressure will further drag this tropical cyclone poleward. Clear? Third, if tropical cyclone is able to hit coastal region, then in the absence of large supply of warm water, death of cyclone will occur. Change the para. Lekin the cyclone does not follow always the same kind of path. They used to follow what? Pressure gradient. जैसे आपको मैंने अभी बताया, I said that जहां पे उसे प्रेशर मिल जाता है उधर मूव करता है. जनरली कराची में डेवलप होता है और इंडिया देन द ट्रॉपिकल साइक्लोन फ्रॉम हियर स्टार्टेड मूविंग टुवर्ड्स कराची, लेकिन तब तक लो प्रेशर किधर आ जाता है? गुजरात में, एंड देन गुजरात एंड कोंकण कोस्ट पे स्ट्राइक करता है इफ इट इज डेवलपिंग इन द अरेबियन सी. So generally I said that tropical cyclone follows the which? Pressure gradient. So right now, generally tropical cyclone follows their path as per the pressure gradient. Understood? कैसा पाथ करता है? As per the pressure gradient. So which are the factors we have seen? Large supply of warm water, that is the sea surface temperature should be equal to or more than 26.5 degrees Celsius till the depth of 50 to 60 meter. You can say enough about it. Thereafter, that led to the development of very weak tropical disturbance. Thereafter, I said that presence of group of island, and then I said that the differential heating of what is a land mass and water body has created several low pressure centers. थोड़ा सा short में बोलते जाओ. And out of these low pressure centers, one of the low pressure center is able to develop the high intensified low pressure center. Therefore, the other low pressure center started also attracting towards it, and then contributing more moisture, and that is anti-clockwise fashion. And then that led to the formation of what? Weak tropical disturbance, not very weak tropical disturbance. And then when the air and water vapor started convecting upward, they are able to create a third factor is upper air divergence, able to create a mechanism for the circulation of what? air divergence, then the air started sucking further from the down from the weak tropical disturbance to convert into developed tropical disturbance. And when this developed tropical disturbance comes under the what? Next fourth factor is what? ITCZ. And presence of ITCZ and Corliss force. And then ITCZ will further, it is a low pressure itself, intensified the developed tropical disturbance into depression. And it has been converted into depression, and the fast moving northeast wind, trade wind and southeast trade wind started moving around it, and they started making it far better, and then it is becoming cyclone, more intensified low pressure center, and then eye wall, and they started moving upward. That is clear. And when it is in a moving upward, जो आपको clear है कि wind speed keeps on increasing, more pressure, more latent heat of condensation, and then it will lead to enlarge the eye slowly and slowly, and the speed of the wind can increase up to what I said, that 210 or 220 km per hour, 30 km per hour. It can convert into super cyclone and super typhoon also. And thereafter I said that from the upper atmosphere, some of the wind is also descending into the eye, touching to the eye wall, that also help in intensification of the eye to become more warmer under the adiabatic compression, and again it helped. And thereafter I discussed with you, I said that weak shear force, and then easterly wave under the influence of northeast trade wind and southeast trade wind. These are the things. Is it clear? And I said that last factor is atmospheric instability. इसमें डिस्कस तो करने की जरूरत नहीं है, क्योंकि अपर एयर, जब ऊपर एयर जा रहा है अंडर द लैटेंट हीट, तो इसको क्या बोलते हैं? जब तक एयर गर्म होता रहेगा वो क्या रहेगा? Instable ही रहेगा. Yes or not? Atmospheric instability is continued, and then it will keep on going upward. और कब रुक जाएगा? जहां पर उसको क्या मिल जाएगा? The air is what? Same temperature with the surrounding. And you can see, like I said, आप एक small structure बना लेंगे. I said this is in a cyclone. And this is an eye, and this is, I said that, eye wall. And from here you can see, like I said, that the winds are moving away under the compatible conditions. And here we have what? Cumulonimbus cloud with the torrential rainfall. And when it is moving toward this cirrostratus and cirrus, which is an indication of, I said that, cyclone to come. Understood? And it is, I said that, eye wall, and the diameter of eye is 15 to 50 kilometer. Diameter of eye is 15 to 50 kilometer. So what are the two things we have seen? Eye and eye wall. First eye bana, then eye wall started enlarging. Understood? And thereafter there is an inner spiral rain band. यहाँ पे भी some of the air which is not able to reach, but they started convecting upward. That is an inner spiral rain band. It is an outer spiral rain band. And you can be able to see, like I said, that, cumulus, possibly थोड़ा सा इधर उधर मूव करने लगा, nimbostratus can form, and then other kind of formation, cumulus, nimbostratus, or this kind of formation will be there, and its height will be comparatively lower than this. And this one I said, इसको मैं क्या बोलूँगा? Inner spiral rain band. It is an outer spiral rain band. Inner spiral rain band, outer spiral rain band. There will be a cumulus, cumulostratus, nimbostratus, cumulus, cumulostratus, nimbostratus, these are the clouds. Cumulus, cumulostratus, nimbostratus. And then eye wall is, width of eye wall is greater than eye, width of inner spiral end bed is greater than eye wall, and width of outer spiral end bed is greater than inner spiral end bed. The width keeps on increasing. And thereafter, you know that this wind started also descending downward. आपको बताया था कि हमेशा एक प्रेशर हर जगह एटमॉस्फेरिक सर्कुलेशन ऐसा डेवलप है. Yes. If it is descending high pressure, some of the wind will also move away. So the same structure you are able to see here also. And I said that यही structure पहले भी मैंने बताया था, this structure will see in the tropical cyclone. And here the wind started what? Descending. And where the wind started descending at the end of the spiral rain band, it is known as annular zone. ANNULAR-ZONE. And here the wind started descending, and it is an annular zone. And I said the winds are descending in this region, and here I said that and after coming here, one part started moving toward the eye, another it is moving away from the eye. So high pressure means what? It is an annular zone, and if high pressure, some will be moving away from this. और जब ये move away होगा sea surface पे, तो sea surface से थोड़ा सा water vapor लेके it will get enlarged and it can form in some cloud. At the end of the cyclone के बाहर भी एक आपको क्या मिलेगा? One cloudy structure due to this wind, and it is known as convective cloud. It is known as convective cloud. ऊपर में जाने के बाद आपको बताया था कि देयर इज एन हाई प्रेशर इज मोर एयर विट इज एन हाई प्रेशर, तो इट स्टार्टेड व्हाट मूविंग अवे एंड सम ऑफ द एयर बिकम हैवी एनफ टू व्हाट डिसेंड हियर इटसेल्फ. तो जैसे जैसे आप देखोगे यहाँ पर भी थोड़ा थोड़ा एयर इधर उधर डिसेंड होते रहता है. इट इज नॉट नेसेसरी टू डिसेंड ओनली विद इन दिस. कहीं पे भी एयर हैवी हो सकता है एंड दैट द एटमॉस्फेयर कैन नॉट होल्ड इट. तो थोड़ा बहुत एयर. So when the air started descending, then automatically it make it what adiabatic compression and increase in the temperature. तो ये यहाँ के लिए स्पेशली जब बताना था, ये phenomena हमेशा रहता है. Developed cyclone will have always in the eye touching to the eye wall, air is descending. Clear? समझ में आ गया structure? So there is an eye 15 to 50 kilometer, eye wall larger than this, inner spiral rain band, outer spiral rain band, and then there is a what annular zone, and thereafter there will be a convective cloud. So and you can be able to see नीचे में जो air move करेगा, the air that will come, how it will come? I said that anti-clockwise. लेकिन upper atmosphere में यहाँ से high pressure से it will move, क्योंकि एंटी साइक्लोन बन गया, and एंटी साइक्लोन it is a clockwise हो गया, so there will be what? So wind will diverge in clockwise fashion in the upper. तो दिख रहा है यहाँ पर. Here it is, I said that anti-clockwise, and in the upper atmosphere it is in a clockwise fashion, and you can be able to see large amount of what I said that cirrus clouds are there, cirrus stratus and all. Clear? How it become devastating into the coastal region. So devastation is I said that how it is devastation? Devastation is due to, if I talk about, first it is in a storm surge, and then front wind and rear wind, and front wind and rear wind high speed, and heavy rainfall. Heavy rainfall. I said that when the cyclone moves, you know that, so there is a low pressure center, and due to this, sea level has been raised up. Sea level has been, and when the raised sea level comes to the coast, so then it causes flood. That is known as the waves which has been made by the cyclone in the sea. Highs, I said that wave created by cyclone into the sea by the cyclone, it is known as storm surge. This is a high, and it causes coastal region to be flooded. So this high waves which has been generated by the cyclone, it is known as storm surge. So it is not, therefore that our like we have a tsunami as a wall. Tsunami आने के लिए हम लोग क्या करते हैं? Sea coast पे we are creating wall. Similarly, cyclonic wall. If we'll go into Japan and all, so for the protection that they used to develop what? The storm surge that is devastating. They create cyclone wall, and so in our India we have developed several kilometers of also cyclonic wall on the eastern coast of India to save us from this one. And the next I said that ध्यान से देखेंगे, it can be in a 50 kilometer very wide diameter of the cyclone. When the cyclone is moving, suppose in anti-clockwise, so first it will hit the whole city from this side in the coastal city. Yes or no? This side, the whole left side has been what? Broken. And then उसके बाद the whole city will come under the eye. धीरे धीरे क्या हो गया? ऐसे मूव कर रहा है ना? Suppose this is a city. So it is coming over there, then first all destruction. Now it comes under the eye, and then people will think cyclone has gone. अभी उनको पता नहीं है कि कौन आने वाला है. अभी आगे बढ़ रहा है, and then it is from the rear wind. Yes or not? Front wind, and now it is what? From the rear side it will attack. So this side also devastation. So there is no positive impact, क्योंकि हम temperate cyclone has a very good impact on the region, development, rainfall, slowly, लोगों की agriculture, industry, everything, social settlement, urban settlement, every kind of settlement, everything is growing because of temperate cyclone. But our tropical cyclone devastating each and everything. So temperate cyclone is boon for their mid latitude country, but tropical cyclone is curse for the tropical region and subtropical region. And one we have said, I said that heavy rainfall. And heavy rainfall ऐसा नहीं होता. Heavy rainfall if it comes now, then इसकी upper unveiled top जो होता है, like an umbrella top, that if you have seen umbrella top, इस umbrella top से suppose ये इंडिया पे आया, in the Hyderabad it is doing something, then यहाँ पे सारे जगह rainfall हो रहा है, in the Bihar, in the Chhattisgarh and all, Maharashtra, several regions will cause what? Flood condition. So not only that flood is through the rainfall, heavy rainfall, because they have contributed large amount of what? Humidity. Yes, which is going away. So this way, क्योंकि एक cyclone can be of 500 to what is 1000 kilometer. 500 kilometer to the whole cyclonic diameter can be 500 to 1000 kilometer. So I said that first it is Northwest Pacific. This region is in a northern part of Pacific and on the western part of Pacific. So in the Northwest Pacific, we have, I said that 36% of, I said that cyclone is concentrated, and that is coming with the several super cyclone and also. And perhaps you know that Japan, आपको शायद you know that Japan is lying between 30 degree north to 45 degree north. So it is above subtropical high pressure belt. Yes. And have you heard about the Japan is also facing cyclone? Yes. So how it has faced the cyclone? Perhaps you understand that when yesterday I have mentioned one thing, that when the anticyclonic condition is there and then cyclone come at the periphery of what? When the cyclone comes at the periphery of subtropical high pressure belt, then it drags it. So therefore it is able to reach 35, 40 degree and 45 degree latitude. Getting my point? So which is dragging and making it to move towards the poles, and that could be only because of what? This when this tropical cyclone is taking in a curvilinear path, and therefore the Japan is also facing this tropical cyclone. So in the southeast, what is the reason that there is what I said that there is a development of tropical cyclone? The reason behind in the northwest Pacific group of islands, there is thousands of islands are there, which is providing a better condition for the development of, I said, that disturbance. And I said that that is a weak tropical disturbance, and then there is a warm ocean current is there also. I know that the Kuroshio current and some other currents are warm ocean current is there, and always on the eastern part of the continent there is a warm ocean current is there. Warm ocean current is there. So therefore I said that in this region we will be able to have, I said that lots of tropical cyclone, large number of group of islands. Thereafter nearby Australia, again we can be able to have 11% of tropical cyclone of the world, and this region has why, again I said that large number of group of islands, and at the same time from here East Australian warm current is crossing. Okay? And then we can be able to see, I said that here, and in the oceanography you will study, there is a northeast monsoon current formation, southwest monsoon current, ocean current formation. In the world only this is the reason, in India is the reason where there is a seasonal changes and playing an important role. And India was, its temperature, that is one northeast monsoon current and southwest monsoon current is going on, and it is generally warm. And in this region we will be able to get 28 to 30 degrees Celsius sea surface temperature around, and it is giving us a good amount of chance to develop a tropical cyclone. And therefore, and comparatively, you know that in the Bay of Bengal, if you are watching it, there is a large number of, I said that, Andaman Nicobar island groups are there, and then ocean current. So in the Bay of Bengal, Andaman Nicobar group of islands, and the sea surface temperature reaches around 28 to 30 degrees Celsius, and southwest monsoon and northeast monsoon, it is in a warm ocean current. They are contributing good amount of, I said that, warmness to this region. Therefore we can be able to say that it leads to, but at the same time some of the cyclone formed in the Southeast Asia, is not able to develop. They keep on wandering and sometimes come into the Bay of Bengal. Those low cyclonic condition pressure also converted into what I said that tropical cyclone. So one it is, I said that, then Bay of Bengal. What is the reason for development of Bay of Bengal tropical cyclone? General I am talking. Yes. And Andaman Nicobar, presence of group of islands, and there could be, I said that what is the ocean surface temperature is around 28 to 30 degrees Celsius around, means you can be able to find throughout the year this kind of sea surface temperature. And what is the other condition which is causing the Bay of Bengal to have a more cyclone compared to the Arabian Sea? Yes.
in which Bay of Bengal has a smaller cyclonic structure. Smaller structure, and at this I said that if I am talking about a smaller structure तो बाद में बात करेंगे. I said it is in a kind of, you want to say it's like in a closed sea. Yeah? I said that recently I said that some of the cyclone which are not able to develop in Southeast Asia, they are able to come into the region of, by moving, come into the Bay of Bengal, and under the compatible condition they are also converting into cyclone. That you should also understand that their structure has been developed in this one, but due to some reason they are not able to develop fully. They come into the Bay of Bengal, and that those kind of vorticity, atmospheric vorticity also started developing in the Bay of Bengal. Another we can be able to see Arabian Sea, and Arabian Sea mein, what is the reason I said that Lakshadweep island is there, and then another I said that sea surface temperature, and then monsoonal current which is providing warmness, good amount of warmness. तो आपको दिखा होगा कि I am discussing it is an ocean current and then group of islands. It is, you know that ये हमेशा ही नॉर्थ ईस्ट का मतलब ये होता है, और वो सी सरफेस जब डेवलप होता है, दैट इज डेवलपिंग इन द मंथ ऑफ, आई सेड दैट अक्टूबर ऑनवर्ड. अब अक्टूबर ऑनवर्ड इतना ठंडा नहीं हो जाता है कि यू कैन से दैट इट इज एन colder enough. At that time temperature had been reached up to 28 degrees Celsius and 30 even, I'll say. आज आपको 4 periods of cyclone समझाया जाएगा, tropical cyclone India. In that you will understand that it is remained very comparatively warm. Means it is not in the month of February. I am not talking about in the month of February. क्योंकि southwest monsoon current force goes for 6 months around, and northeast monsoon current goes for 6 months. So in the month, and then what is the period for tropical cyclone? Anybody knows? What are the periods of tropical cyclone in India? Up to after July, August. Yes. There are the 4 periods of cyclones in India. First period is April, May. Second period is July to September. Third period is, I said that, October, November, and fourth period is December. These are the 4 periods of cyclone. These are the 4 periods of cyclone in India. And I said, and कहीं पे भी these are the, आपको मैंने पहले भी कल भी बताया कि sea surface temperature is the first important factor, should be 27 degrees Celsius at 26.5. First factor ये मैंने बताया था. Second factor I have said that it should be what is the presence of group of island. If these are having, then it will sure trying to make the condition for the formation of tropical cyclone. Understood? तो कहीं भी आप देखोगे in the near Madagascar, in the Madagascar, why there is a 10%? Why it is in Madagascar 10%? I said that यहाँ से warm ocean current is coming and is in a Mozambique channel and near it is a Madagascar current. ये सारी चीजें बताई जाएंगे ओशनोग्राफी में. And I said that इसके यहाँ पर you will say that warmness is there and you can see large number of group of islands. आप लोगों को पता होगा. Yes, Comoros and then Seychelles and then several groups of islands are there in this region. And that is another you can be able to see that in the region of this, and then again warm Antilles current, and then thereafter development of Gulf Stream is beyond this, but there is a warm Antilles current it is developing in this region with the help of North Equatorial current and South Equatorial current. तो आप अपने आंसर्स को with the help of oceanography ऐड करेंगे, then you can be able to write. इसके बाद other conditions perhaps you must be knowing. First factor I have said that warm, large supply of warm water. Second factor I said that yes, presence of group of island. Third I said that upper air divergence. Fourth I said that presence of ITCZ and Corliss force, and thereafter I said that weak shear force, and then I said easterly waves under the influence of northeast trade wind and southeast trade wind. Simply, and thereafter you can maintain these are the things which are able to develop, and they are converting into tropical cyclone. UPSC can ask a specific reason tropical cyclone formation. Understood it?
specific region tropical cyclone formation. Getting my point? But you know that I said that Brazil has in 2006 Brazil has got cyclone. Can you tell me what is the reason? Just think of it. Okay, if the exam mein aa jaye, then you can be able to, you should answer it. You should try to answer. What could be the possible reason that the Brazil, where there is no such condition is prevailing, which can lead to the tropical cyclone formation? Yes, keep on saying whatever. Okay. Clear? Yes. Warm ocean current, it is there. Warm Brazilian current. Okay. Yes. What could be the reason? Deforestation. Forest and land can be the factor for formation of cyclone in the sea, ocean. Yeah, they are attracting towards the Brazil. Attracting के लिए आप इसको बोल सकते हो ना. I am asking why do the cyclone developed into this region? They must have strike after that, no? In 2006. पहला क्या point था? What? Just think of it. यदि आप structure, you have to understand the structure. I have said what is the first point in the tropical cyclone? Sea surface temperature. चलो इसको यहाँ पे मिल गया. It has been able to develop. It can be in a smaller, very weak tropical disturbance. Another factor is group of islands. Group of islands ने क्या किया था आपको याद है? It has created further, I said that, further low pressure, and this low pressure is converted into very weak to weak tropical disturbance. Thereafter, upper air divergence. Upper air, yes or no? Clear? Do you know that jet stream has also upper air divergence? When the jet stream moves, most of the area it descends. Most of the area descends, and some of the area sucks. याद है ना? Yesterday I have done subtropical jet stream and then sucks. Yes? Is it clear? So when it sucks, then it creates more divergence itself. Just second point को हटाओ. Presence of group of island. Just think of it. आपको ये दो रीजन मैं दे रहा हूँ. One, it is this part of North America. You have to think it is regularly coming, and this part of I said that Mr. Brazil. दो क्वेश्चन हैं जो at the end I'll ask you. Think of it in the during your process. कि why do this reason he is having a tropical cyclone. This doesn't have. यहाँ पर आपको पता है कि there is no cyclone, but I have written 16% of the cyclone of the world. In comparison to I said that 11% in Caribbean Sea. तो याद हो गया. पहले हम लोग देखेंगे. In the Pacific, how much we have? In the Pacific, how much we have? 36. This is 16. जो ये लिखा हुआ. 36 and 16% become 52% and 11% 63%. So how much it is a total in the Pacific? 63% of tropical cyclone. And I said that, which I said? Next point I said that Indian Ocean. In the Indian Ocean, Arabian Bay of Bengal 10%, Arabian 3%, and then near Madagascar, Eastern Africa, it is getting 10%, near Australia, it is 3%. So total 26%. Understood? We left with 11%. And only I said that 11% it is in the Caribbean Sea. Understood it? In the Atlantic Ocean. Atlantic Ocean, Pacific Ocean 63%. Pacific Ocean में कितना है? Yes. Pacific Ocean में how much? 63%. Indian Ocean 26% and Atlantic Ocean 11%. Okay? और भी मुझे reason can you tell me that Pacific में बहुत ज़्यादा क्यों आ रहा है? Just can you think like why so large amount of what is the tropical cyclones comes into the Pacific Ocean? island groups हैं, that is okay, supported by at the same time large mass of warm ocean current. यदि बहुत बड़ा है Pacific, they will also give an what? Large amount of warm ocean current which keep on convecting upward compared to the other ocean, So this is the distribution we have been able to see. Which continent is not receiving cyclone? Which continent is not receiving cyclone? Europe and South America. Europe and South America is not receiving cyclone. Understood it? Question can be like this also. So these are the question can be a specific regional basis also. And another I said that in Japan it is known as typhoon. जापान में इसे टाइफू कहते हैं. In China it is known as typhoon. In Australia it is known as Willy Willy, and India it is known as cyclone or tropical cyclone. In North America, yes, hurricane. You must have, this is clear? What is the, if I say that, if I talk about nomenclature of cyclone, anybody can? Nomenclature of cyclone. अब ये क्वेश्चन पूछा नहीं जाएगा वैसे. This question has been asked. हाँ? हाँ, उसी के बारे में पूछा. हाँ? Why? Just मेरे से हमने एक क्वेश्चन आया. Why we not give name to the temperate cyclone? Perhaps the answer is with you. क्योंकि ये तो regular phenomena है. In the temperate cyclone, it is in a kind of not cyclone very devastating, everyday phenomena, and that is not, it is in a named, but it is in a what? Specific, spatial, yes or not? Tropical cyclone is a specific and a spatial phenomena which is devastating in nature. Therefore, its nomenclature is there. And इसमें कोई पूछा नहीं जाएगा. Every what is in a regional level पे क्या करते हैं? The country get together and they create an what is in a list of what? All the countries are there having orders, and then they have given some names. Suppose 8 countries in the Indian Ocean, so they have given the names like I said that Sola, Fola, Hudhud, कुछ भी नाम दिया, and then Nilofer. So एक बार जिसको आया, suppose I said that India faced 3 cyclone in the same year. So what is the 3 cyclone will be, जो list उसके बाद होगा वो list. So 8 countries are there. The 8 countries. So I said that A, B, C, D, E, F, G, H, 8 countries are there, and they have given the list for certain period of, and the names are, why I said that A, B, C, D, E, F, कुछ भी नाम दिया गया है. Every country has given then Hudhud, Nilofer, and any kind of it. So suppose India, and then I said that Marcy, कुछ भी नाम दे गया. सपोज हुदूद के बाद हमारे इंडिया में साइक्लोन आया, हुदूद and the next cyclone again in the month of November come, its name will be Nilofer. In the next, वैसे पाकिस्तान मतलब गुजरात कोस्ट में आया था उसको नीलोफर नाम दिया गया था. Just I am saying that, and after that the third cyclone comes in the same year, Masi. So whatever it is coming, the name will be, this 8th list has been completed, another list is also is there. So we have a prepared list, and accordingly this name will be coming one after the other. Similarly in the Atlantic Ocean, the countries are together for their origin, they have given the name. And Hudud was given by country Oman. Like I said that the Oman is also part of it. So several countries are there which are surrounding Indian Ocean. 8 countries are associated with this. This question is less significant. It will not be asked. Now we are going to see the tropical cyclone in India. First, April, May, second, June last say, June to September you can say, October, November, another I said that, December. These are the 4 periods of tropical cyclone in India. First, April, May. You know that in the month of April, May, I said that ITCZ is able to reach, here it is, and it is forming between 8 degree north to 12 degree north. 8 degree north it is forming between 8 degree north to 12 degree north. Understood? In the April and May. And the reason, if I said the next point, if I have to see sea surface temperature, sea surface temperature. If I see sea surface temperature is around 27 degrees Celsius, and मैं यहाँ पे हमेशा ही very warm रहेगा compared to the any other oceans of the world, compared to the any other oceans of the world. The reason behind यहाँ पे warm ocean current, open oceans are there, therefore the hotness is able to transfer. But here the hotness is not able to transfer. Understood? The remain what mostly it remain lies here. Okay, it is in a kind of what? Arabian Sea, and then Bay of Bengal Sea is a kind of what? Closed sea, and therefore it's in a temperature maintains throughout the year more than the other, because in the Atlantic Ocean it is an open, so therefore this kind of ocean formation is there, and then heat is able to transfer. Pacific Ocean is also open, therefore heat is able to transfer. But in the what I said that Arabian Sea and then Arabian Sea and Bay of Bengal, in comparison to Atlantic and Pacific, they are highly closed. Therefore, the heat generated along the equator is not able to transfer to the heat generated along the low latitude. Heat generated along the low latitude is not able to transfer to the high latitude. In case of I said Atlantic, the heat generated at the low latitude is able to transfer to the high latitude, because we have seen the Pacific Ocean is open, Atlantic Ocean is open, so the heat is able to what is in transfer. But in our India, it is not able to generate what is a transfer from the low latitude to the high latitude. It remain within. Therefore, we can be able to have high temperature of the ocean compared to the other. And here it is in a 27 degrees Celsius. And then, और इसमें ध्यान में रखिएगा, you have to remember more and more. And then sea surface temperature is 28 degrees Celsius in the Bay of Bengal. ध्यान रखिएगा, Bay of Bengal has sea surface temperature comparatively more than Arabian Sea. And perhaps you know that the Bay of Bengal is comparatively what it is, closer than Arabian Sea, comparatively closed than Arabian Sea. And यहाँ पे if you see the depth is around 20 to 30 meter. What is the depth up to which it is warm? 20 to 30 meter. Clear? No. Large number, that is not going to affect too high. It is in a coastal region will get affected. Not the comparatively full ocean is going to get affected because of this. Clear? Tropical cyclone is not along the delta, that I will tell you. So I said that, यहाँ पे छोटा दिख रहा है बड़ा हिस्सा. I said that here it is developing and here it is, I said that how much depth of the water which has been able to become warm, 27 to 22, 30 meter. They can be able to convert into developed cyclone. It will be what is a developing kind of cyclone will be there. Yes, tell me. Developing. It cannot be developed cyclone because for the developed cyclone the depth should be what is in a 50 to 60 meter. And here the formed tropical cyclone कहाँ जाता है? Then I said that you know that at the local level, you know that there is at the local level, I said that intertropical convergence created, ITC. At local level, ITC creates. What I said that? At local intertropical convergence. What creates? Intertropical convergence. At local level, small low pressure system created. And I said that therefore पहले ये ITC कराची के आसपास डेवलप होता है तो देखेंगे तो this I said that this tropical cyclone can follow the path. This tropical cyclone formed in Arabian Sea can strike along the coast of Malabar or can strike along the coast of what? Gujarat. Understood? Which are the coast he can strike? Yes? Gujarat and Malabar coast during the month of April and May, and then the way the Nilofer has struck the Gujarat coast in 2015. Clear? I said that this is for the, which I said that Arabian branch. तो आप क्या बोलोगे Arabian branch during the month of April, May? They are able to, I said that convert into not in a developed cycle due to the, as the sea surface temperature is very warm, 28 degrees Celsius, 27 degrees Celsius, but till the depth of what is I said, 20 to 30 meter. And but they have been able to find a good amount of pressure gradient towards Gujarat and good amount of pressure gradient towards Malabar as per the presence of ITC, intertropical convergence. Understood? जो बोल रहे हैं कि इस ट्रॉपिकल रीजन में जहां पे winds are converging, it is not intertropical convergence zone, it is an ITC jet नहीं, it is an ITC, intertropical convergence, and that led to attract this what tropical cyclone into this region. So which are the two? Gujarat coast and Malabar coast can strike and during this period. In the same thing happened here, that I said that one formation is there, and this formed cyclone between 8 degree to what is 12 degree north. They can strike, remember that, from the Godavari to Kaveri. Sorry, Godavari कह रहा हूँ, that is Mahanadi to Kaveri. This kind of ITC can prevail anywhere. This ITC can prevail anywhere between this, and accordingly they can behave and then strike. The region between, I said that region between Mahanadi to Kaveri. Can you remember? दो बार मैं बताऊंगा महानदी टू कावेरी. One it is in December month and one I will say in the April and May month. Is it okay? Yes, याद हो गया, in the April and May. So it will be a devastating or it will be a less intensified tropical cyclone. Yes, it will be what I said, that less intensified. April and May month will be tropical cyclone, will be what I said, that less intensified, because it is not able to get developed since they have not enough fully developed depth of what is in a warm water. Shall I remove this? Clear? Next one, I said that from the mid of June onwards to, I said that September, now slowly and slowly I said ITCZ is able to reach ITCZ is able to reach 25 degree north latitude. Now the ITCZ is able to reach how much interior? 25 degree north latitude, and that time between 12 degree north to, I said that 15 degree north and 12 degree to 15 degree. If you'll see that during this period, I said sea surface temperature is been able to become, like I said, that 28 degrees Celsius, and then depth is also 30 meter. And here the sea surface temperature, if we'll talk about, it is around, if I say that 29 degrees Celsius, थोड़ा सा हमेशा warm रहेगा इससे, and then depth is 30 to 40 meter, better to say 40 meter around. Clear? Good amount of what is, and I said that sea surface is warm. Sea surface is, पहले वाले में आपको क्या मैंने बताया था, this one is 20 to 30, now it is 30, and then it is 30 to 20 to 30, now it is, I said that 40 meter. Clear? So now if I am talking about in this region, cyclone should form, yes or no? Better cyclone can develop. It is the depth is what is, I said that 40 meter, and the sea surface temperature is there, and also ITCZ is there, yes or not? What is there? ITCZ. If ITCZ is there, they should develop into a developed cyclone, but it is not developing. Yes, I said that, and you know that it is in the Himalayas. Perhaps you know that mountain regions. These are the regions of mountains, and you know that why I have said that what is the fourth factor. Yesterday I mentioned that ITCZ and Corliss force. Because of the presence of ITCZ, it has converted into depression. And thereafter, I said that strong northeast trade wind and strong, I said that southeast trade wind started converging fast and they started what is rotating, and then before coming to the center they started what is rotating and making an eye of the cyclone. और जब तक eye of the cyclone is not forming, that is not a cyclone. Clear? The wind is only, I said that, ऐसे ऐसे गर्म होकर ऊपर जा रहे हैं. That is kind of it. So if you see that there is a group of, I said that, a large group of, I said that, and then you know the Arakan Yoma, and then Pegu Yoma, here it is, and then lots of Himalayan zones are there. Here I said that southeast trade wind crossing the, listen me, south, और इस समय southwest monsoon आ रहा है, perhaps you know that. जून में क्या जाता है, monsoon comes, and then southeast trade wind crossing the equator, it becomes southwest monsoon, and the wind is moving with the vigorously. And they are ready to come to the, I said that they are ready to come to this region to give an what? Rotating effect, vorticity. And when it is coming, but it is not able to get, I said that, northeast trade wind. It is not able to get. Just tell me. This region is not able to get, this ITCJ, it is not able to get what? Northeast trade wind. Can it provide vorticity? Vorticity इसको मिलेगा? So दोनों मिलाकर करते हैं ना. One is cannot be able to give the vorticity. So I said that in the June to September month, I said there is a sea surface temperature compatible. I said that it is 29 degrees Celsius. And then I said that at the same time 29 degrees Celsius, depth is around 40 meter. It can give a developed cyclone. But absence of, I said that, absence of northeast trade wind or very weak northeast trade wind. There is an absence of northeast trade wind or very weak northeast trade wind, not helping to provide eye and rotatory effect to the cyclone with the southeast trade wind in the form of southwest monsoon. So sea surface temperature, depth, but absence of northeast trade wind or very weak northeast trade wind is not helping to provide, I said that, eye and rotatory effect. These two things are there. If the eye is not able to form and rotatory effect is not able to go, then the cyclone cannot form. Yes or not? So the cyclone is not forming during this period in the Bay of Bengal and in Arabian Sea under the absence of, what I said that, under the absence of northeast trade wind. And what we get finally, a cyclonic wave. हमें क्या मिलता है यहाँ पे, tell me what we are getting? A cyclonic wave. Yes, tell me what we are able to get. So cyclone is not able to develop, but लेकिन ऐसे ही मुझे क्या दिख रहा है, sea surface temperature is very high, and I said that till the depth it is there, some low pressure system has been developed. I said that amount of upper air divergence, but the northeast trade wind is not there, so it is not able to, what I said that, developed into a particular kind of what, rotation. And if the rotation is not there, the eye cannot be formed. Clear? So because of this, it is converted into cyclonic wave, or it converted into a cyclonic wave. So thanks to this cyclonic wave, I said, so here we are not able to develop a cyclonic wave, cyclone, and I said that cyclonic wave. And now this region is very hot. I said that Rajasthan, Sindh region is what? Hot. and when it is very hot, it has created a low pressure. It has created what? So I said that cyclonic wave is there, and then there is, I said that northwest India is highly heated. Northwest India is highly heated. Getting my point? Northwest India is highly heated. Or it converts into what? Low pressure. Northwest India converted into what? आपको ही पता है, it creates into low pressure. And that time what happened? You know that the southwest monsoon कैसे move करता है? It comes and southeast trade wind crossing the equator, then turn right, and then it become a southwest trade wind. Monsoon का मतलब regular reversal, therefore trade wind has been taken the name of monsoon, and it is moving like this. Yes, and when it is moving like this, I said that it cannot come toward this region. It never can. You know that Arabian Sea rainfall कितने region में देता है? Only into this region and some into this region, not in this region. Arabian branch of southwest monsoon is not giving the rainfall. Now I have said that there is a cyclonic wave is there, and this cyclonic wave, and there is a low pressure, then cyclonic wave started moving towards. It is not a developed cyclone, it is in a wave kind of it, low pressure system with some rising air. Understood? Low pressure system with rising air. Then what happened? Then it started dragging the southwest monsoon. नहीं तो ये इतना बड़ा, this kind of big structure cannot be pulled toward this. Can you think of? इतना बड़ा big structure of southwest monsoon nobody can carry toward the northern Indigo Gangetic Plain. The whole of MP. This is a large area where there is I said that there is a need of what? Rainfall. So thanks to this south cyclonic wave, and then what is a northwest hitting? Which hitting I said that? Hitting of northwest. They carry the southwest monsoon, Bay of Bengal branch towards Indian subcontinent. किधर आ गया ये? Indian subcontinent. North Indian subcontinent, parts of, I said that northern Andhra, Chhattisgarh, and this way this region is receiving rainfall. And then southwest monsoon has been dragged. Therefore from the June onward, 15-20 June onwards, we started receiving rainfall in this region. Otherwise, earlier it was giving rainfall only in the northeast India. So thanks to this cyclonic wave, from the month of what I said that June to mid-June to September. Understood it? So first one we have seen April, May. In April, May, simply I have said that there is an Arabian branch. In the Arabian branch, temperature of the sea surface temperature is 27 degrees Celsius, between 8 degree north to 12 degree north, and then till the depth of 20 to 30 meter. And in the Bay of Bengal branch, we have been able to see it is 28 degrees Celsius till the depth of 30 meter around. And there is an able to develop some kind of what is small intensified cyclone, and this cyclone under the ITC, intertropical convergence, a low pressure under the pressure gradient, they started moving towards, I said that Gujarat coast and Malabar coast in India by the Arabian, and from the Bay of Bengal side it can strike anywhere from the Mahanadi to Kaveri. Understood? And then month of June and September they should develop into a very good cyclone, but it is not able to develop. Understood? Next one, it is October, November. In October, November, you know that again now ITCZ started shifting southward, and ITCZ will come here. And when the ITCZ is come down near to the equator at that time, so the ITCZ is nearby this. Perhaps you know that. Okay. And what is the meaning of ITCZ? Intertropical Convergence Zone. इसका मतलब कि यहाँ पर convergence strong होगा. Yes. Now the northeast, it is a trade wind has been developed. Northeast trade wind has been developed from the September month onwards. October, November में क्या है? Northeast trade wind is coming. Also southeast trade wind crossing the equator. It is in a southwest monsoonal wind. So we have a, now let us come and see. I said that October and November month, I said that the sea surface temperature become around 29 degrees Celsius in the Arabian, and then the depth is around, I said that 30 to 40 meter. But in the, I said that sea surface temperature in the Bay of Bengal, it is reaching around 30 degrees Celsius. क्योंकि अभी भी सन किधर है? सितंबर यहाँ पर आ गया है. अक्टूबर में तो सन यहाँ पे 22nd September सन इज ओवर द इक्वेटर. यस सर ना, जस्ट थोड़ा सा कुछ दिनों में यहाँ पर रहेगा, लेकिन इवन देन दिस रीजन विल गेटिंग हाई हीट. यस और नॉट? सो दिस रीजन विल कीप ऑन गेटिंग द हाइट इन द October November month also. So sea surface temperature 30 degrees Celsius and depth is able to reach around 50 to 60 meter. How much? Depth is, now can it give in a developed cyclone? Yes. ITCZ is there. It can be able to rotate fast. Yes. And at that time this is Godavari, and here it is what? Mahanadi. And there is a developed cyclone has been formed, and during the month of October and November, a low pressure system in the form of intertropical convergence zone, ITC, or better to say low pressure system, has been what? Developed between Mahanadi to Godavari. Remember that. Mahanadi to Godavari. यहाँ पे low pressure system near to the, what is in a coastal region, we are able to see. And I said, now tropical cyclone can hit anywhere between Mahanadi to Godavari. So I said that in 2015 we have seen which cyclone? Hudhud. Which cyclone we have seen? Hudhud cyclone. Last year December month में कौन सा cyclone आया था? मुझे नाम नहीं याद आ रहा. वाद्रा या क्या नाम था? वर्धा. दिसंबर में था. अभी हम लोग यहाँ पर हैं. October and November. Hudhud cyclone has come, and you know that it has a strike. I said that Andhra. तो कौन सा रीजन? यस, इफ विल से द उड़ीसा में फर्स्ट विल कम इन उड़ीसा. तो ध्यान से मेरे साथ देखेंगे. आई सेड दैट इफ विल से दैट बिलो इफ इट इज, आई सेड दैट गजपति. कौन सा डिस्ट्रिक्ट? गजपति, गंजम, खोर्धा. विच आर द डिस्ट्रिक्ट? आई सेड दैट गजपति, गंजम, खोर्धा. विच आर द डिस्ट्रिक्ट? आई सेड दैट इन उड़ीसा. उड़ीसा, यदि आप थोड़ा डिस्ट्रिक्ट वाइज लिखेंगे यू विल गेट द मोर मार्क्स. गजपति, गंजम, खोर्धा. एंड खोर्धा डिस्ट्रिक्ट के अंदर ही यहीं पे भुवनेश्वर आता है. विद इन द खोर्धा डिस्ट्रिक्ट वी हैव, आई सेड दैट भुवनेश्वर. गजपति, गंजम, खोर्धा. It is not forming at Mahanadi. It is not coming at Mahanadi Delta, because at the Mahanadi Delta there is a fresh water mixing is there. and due to the fresh water mixing, I said that the temperature, sea surface temperature also, what I said that reduces. So at any deltaic region, then the cyclone, if it is coming, they become very weak, so that region will not be affected. Deltaic region is not being affected. So I said that which are the district in the Odisha? Gajpati, Ganjam, Khordha. Thereafter in the Andhra Pradesh, in Andhra Pradesh it can hit, I said that Srikakulam, Vijayanagaram, Vishakhapatnam, East Godavari, Krishna, East Godavari, or you can say parts of Krishna. East Godavari. Srikakulam, Vijayanagaram, Vishakhapatnam and East Godavari. This is the reason that they used to hit, and you can be able to see it is a highly affected and devastating region. And then Hudud cyclone, which has it is about to, the path was not completely clear, it can hit something in the Odisha, but finally it was hitting, direction was more orientation towards what? Andhra coast. And then you know that around 70,000 crore loss, infrastructural loss has been done, but human loss has been very less, as it is. If you will go into 1999, in December month there is a tropical cyclone. Perhaps you know that super cyclone hit Odisha in 1999 December. That is a super cyclone, and that hit the Odisha, and there is a 10,000 loss of human being. The greatest disaster we consider if you are not able to save the people. Lekin यहाँ पर hardly we are able to manage. Some loss is there, that is around 21, 22 people what is a loss. Infrastructure loss तो हमेशा ही उसको we can't stop it. So this is the, I said that along the coast of, I said that eastern coast of India during the month of October and November. समझ में आ गया? Sea surface temperature is how much? 30 degrees Celsius till the depth of, so large amount of it. And then I said that it is hitting the coast between Mahanadi to Godavari. Clear? Next point, in 2015, I said that आपको पता है कि there is a Chennai flood camp. 2015, what camp? Chennai flood. And the Chennai flood, I said that there is one cyclone has been developed, tropical cyclone has been developed, and they are moving towards I said Andhra coast, moving towards Andhra coast. Clear? Chennai flood in the month of November. In the month of November, October, November, we are reaching which period? October, November. And at that time, यहाँ से क्या हो गया? Low pressure system which has been disturbed. In this, that is in a low pressure. So absence of what? Low pressure system, he is not able to strike Andhra, so they keep on rotating and losing the energy and giving rainfall in the Bay of Bengal. Clear? And thereafter it has been said, like I said, यहाँ पर, then by in December month, in December month, low pressure system come above north of Kaveri. There is a Kaveri delta, and Kaveri के north में यहाँ पे low pressure system developed. So after that what happened? यहाँ पे जो cyclone था, this cyclonic structure has what is a weak, and therefore weak cyclone of November month in Bay of Bengal strike Chennai coast and nearby region with heavy rainfall. So weak हो गया, तो weak का मतलब the speed will be what is it? 20 किलोमीटर पर आवर, 30 किलोमीटर पर आवर, जैसे टेम्परेट साइक्लोन में हो जाता है. डिस्टर्बेंस इट बिकम वीक. तो आपको साइक्लोन जैसा जो ट्रॉपिकल साइक्लोन डिजास्टर्स होता है, दैट इट इज नॉट लुकिंग लाइक दिस. सो इट बिकम वीक, बट दे हैव स्ट्राइक एंड कॉज चेन्नई टू बी व्हाट इज अ फ्लड. अंडरस्टूड? लेकिन वन ऑफ द साइंटिस्ट इन इंडिया हु हैज गिवन एन आइडिया आल्सो दैट यू नो दैट यहाँ से आपको पता हो कि ट्रॉपिकल ईस्टर्ली जेड स्ट्रीम आता है, दैट इज डेवलपिंग फ्रॉम द तिब्बत. फ्रॉम द तिब्बत आपको आज बताया जाएगा ट्रॉपिकल ईस्टर्ली जेड स्ट्रीम. And this tropical easterly jet stream in the southern China, there is a large amount of, I said that dust particles are there, and then polluted particles. These polluted particles came, and it has been trapped by this. And you know that the polluted particle act as a what? Cloud condensation nuclei, and that has helped in the further more cloud formation. Okay, and thereafter you can be able to see that is causing more rainfall. Okay, but the cyclonic structure is the major factor that it has been in the December flood of Chennai. And यहाँ पर जो the cyclone which developed in, so ये समझ में आ गया कि अक्टूबर नवंबर month will strike. Where they will strike? Godavari to Mahanadi, October November month. And here it can strike the region of, I said that Konkan coast. इस समय कोंकण कोस्ट पे क्या हो सकता है? Cyclonic attack can be there in the month of October and November. Konkan coast and Malabar coast. यहाँ पे लो प्रेशर सिस्टम ITC डेवलप्ड, और आपको ही पता है कि लो प्रेशर सिस्टम के लिए एक साइकिल मैकेनिज्म बनना चाहिए ग्राउंड पे लो प्रेशर डेवलप करने के लिए, और इट कैन अटैक अलोंग द कोस्ट ऑफ कोंकण कोस्ट और इट कैन अटैक द कोस्ट ऑफ मालाबार. सो ओनली इन द अरेबियन ब्रांच 2 periods आर देयर, April, May and October, November. Only the 2 periods. So it is clear about October, November. So October, November में what is the sea surface temperature of the Bay of Bengal branch? 30 degrees Celsius till the depth of. So it can give in a developed cyclone, and where the low pressure system finding between Mahanadi and Godavari. So therefore in this region they can strike. Next one, it is, I said that December month. In December month, if I talk about December month, I said ITCZ has already shifted into, I said that ITCZ has already shifted into southern hemisphere. In December month I said that ITCZ shifted into southern hemisphere. Second, left several atmospheric vorticity in Bay of Bengal who have not been able to develop into developed tropical cyclone during October-November month. In the October-November month, there will be formation of such kind of, it can be, I said that 20-30 atmospheric vorticity is going on. Clear? But chances है कि October में November में one of them is able to get in a condition to what is developed into cyclone, and they strike what I said that between Godavari and Mahanadi. But जब ये ITC चीट जला गया in the southern hemisphere, then there is no chance to develop for whom any. लेकिन वो atmospheric vorticity is present. Atmospheric vorticity is present. अब ये क्या हो सकता है? What can be there? So we have some atmospheric vorticity is there in the Bay of Bengal. We have several atmospheric vorticity in the Bay of Bengal. Clear? Those who are possibility that those kind of tropical cyclone can convert into what is in a developed cyclone, but they are atmospheric vorticity. They are itself, I said that atmospheric vorticity, but there is a chances that the compatible condition they have been able to get. Like I said that one cyclone of less intensity coming from Southeast Asia, and they have been the part of, I said that इनमें से किसी atmospheric structure को उसने अपना low pressure दे दिया. They have been able to convert into developed cyclone. And this is the December month, that is the last week of December month, I said that Odisha has faced super cyclone. I said that सोचो कि उसको Southeast Asia का एक क्या हो गया, that is, and I said that one kind of what is a low pressure system. You know that low pressure system is in a kind of what atmospheric vorticity in the Southeast Asia which are developing and but not able to, and it come and so many atmospheric vorticities are there, and one of the atmospheric vorticity is able to get a chance to develop into a developed cyclone, and suddenly sea surface temperature December में ठंडा नहीं हो जाएगा. It will slowly and slowly February, January, February, March तक जाते जाते it will started what is it getting lower. फिर slowly and slowly I said that April में से फिर started increasing. Understood? Because it is in a kind of closed sea. So I said that left some atmospheric vorticity in Bay of Bengal who have not been able to develop into developed tropical cyclone during October November month. They are remaining over there. They are circulating around, and under the compatible condition, under compatible condition, it can develop into a developed cyclone. Example we can say like what is a cyclonic structure developed in Southeast Asia. Where I said that? Cyclonic structure developed in Southeast Asia can come and pass through Bay of Bengal, and one of the atmospheric vorticity, one of atmospheric vorticity is able to convert into developed cyclone, tropical cyclone by with the help of that low pressure system. ये जो low pressure system जो cyclone South East Asia से आ रहा है. So when the South East Asia से some cyclonic structure is coming, and then possibly it what become this atmospheric vorticity can become convert into developed cyclone, and then at that time they can hit anywhere between Mahanadi to Kaveri. Mahanadi to Kaveri. कभी भी डिफरेंशियल हिटिंग ऑफ लैंड मास एंड वाटर बॉडी कुछ ऐसा रहता है कि कभी भी लो प्रेशर यहाँ पर भी रह सकता है, यहाँ पर भी, और ये क्योंकि हमारे पास क्या स्टैटिस्टिकल डाटा है ऑफ सो मेनी इयर्स, एंड वी हैव सीन इन द डिफरेंट स्टैटिस्टिकल डाटा दे सेड दैट कि दे हैव स्ट्राइक्ड इन दिस रीजन, क्लियर? सो दे हैव गिवन इन द दिसंबर मंथ दैट दे कैन स्ट्राइक इनटू दिस रीजन, क्लियर? कभी जाके ढूंढोगे ना तो दिमाग चकरा जाता है पढ़ते पढ़ते. Statistical data is very much hardly you can be able to find in the some of the foreigner author and writer that they have written something like this. So most of the things you have seen, which are the period of tropical cyclone we have seen? April, May, June to September, अक्टूबर, नवंबर एंड दिसंबर. अब शायद आपको समझ में आने लगा कि कैसे साइक्लोन एंड ऑल, एंड शायद ये 4 periods ऑफ साइक्लोन हैज बीन टॉट बाय द अदर्स और नॉट, आई डोंट नो. पढ़ाते हैं? नहीं पढ़ा. सो आई सेड दैट, सो द नेक्स्ट, यस, वी हैव टू सी मॉनसून इन इंडिया. Before coming to monsoon in India, we have to understand jet stream, the 2 jet streams which are, I said that tropical easterly jet stream and fin latter jet stream. Okay. Anybody can say what is tropical easterly jet stream? थोड़ा गलती कर दिया. What is fin lateral jet stream? Yes, fin lateral jet stream. बोलो जो भी पता है, किसी ने जो जिनको भी पता है, they can contribute your ideas. नाम सुना? Have you heard? Heard? Okay. चलिए. What is fin lateral addition? Intensified. Okay. You know that average height of Tibet Plateau is 4,000 meter. Average height of Tibet Plateau is 4,000 meter. And if we can see that in the eastern side its width is 1000 kilometer, in the western side its width is 600 kilometer, and then the east to west its length is 2000 kilometer. If we'll take it around, it is giving us an idea about around, you can be able to say that very large 20 lakh or 17 lakh square kilometer, around 17 lakh square kilometer. And then what is the total area of India? 32.8 lakhs. Understood it? And Tibet Plateau, you can see that it is in a half of it, around half of it. It's in a very large area. First it is, I said that very large area. And how much is the large area? Around how much? 17 lakh square kilometer, and average height is 4,000 meter. Getting it? You know that so what is the average height of Tibetan Plateau? What is the average height of Tibetan Plateau? 4,000 meter. The higher the height, you know that the temperature decreases also, but at the same time sun insolation is more. At the same height there is an air, at the same height there is an, I said that, land. The land will be 2 to 3 degrees Celsius more warmer than, I said that, air. Understood? And which is more heating, so it is known as a Tibetan heating. It is known as, I said that, Tibetan heating. I said that 2 to 3 degrees Celsius more. And it is already, and here if I say it, so 4 kilometer from the here, I said that due to Tibetan heating, the air from here started rising up. And at a height of 6 kilometer, it creates a high pressure. In Tibet, how much? At the height of 6 kilometer, how much pressure it created? High pressure, anticyclonic condition above Tibet. At what height? At what height? At what height above the mean sea level? 10 kilometer. At what height? From the Tibet plateau at height of 6 kilometer, I said that. It is, I said that 6 kilometer, but this 4 kilometer becomes total height. It is what? What is the total height? 10 kilometer. And if you'll see from the near equatorial region, I said that near equatorial region, if you go at the height of 10 kilometer and if it has a 500 MB, what is there? And above at the same height, there is a 400 MB was existing. How much pressure was existing? 500 MB above the Tibet at 10 kilometer, and then towards equator 400 MB was existing. It means the pressure difference was not 200. As I said that subtropical jet stream के लिए कितना था? 200 MB difference, moving very fast, and here it is in how much difference? 100 MB difference. So you can be able to see that the wind from here, they started moving upward. High pressure above the Tibet and very large area, large mechanism they have created, and this large air which started moving toward the equator, and when they started moving towards the equator, they deflected towards right. What is the pressure difference? 100 MB. 200 nahi hai. So if 200 hota, so that becomes parallel to this, parallel to isobar. It is a 100 MB difference. They started what? Deflecting and reaching near what is a Mascarene island group and Ethiopian island groups, sorry, Ethiopia, and they started descending. And it started what? Descending. That is clear. And when they started descending, this region become what is a Mascarene high and which high? Ethiopian high. Understood it? And thereafter, if it is high pressure and India is under the low pressure, India is under the, so the wind started coming from here and then it started descending over there in this Ethiopian and all, and after descending over there, already India is at low pressure. In the month of June, India is what? Just tell me. Low pressure and very highly heated because आपको बताया था subtropical jet stream किधर शिफ्ट हो गया था? North of Tibet. And after the north of Tibet, when the subtropical jet stream, there is a formation of tropical jet stream, and they have moved upward, then it started moving toward this low pressure. But what happened? Deflecting towards right in the northern hemisphere, and they started descending over Mascarene high and which high? Tell me. बोलो तो सही. Ethiopian high. When descended, created a high pressure over there, and there is a low pressure, and the southwest monsoon is going on. उसने southwest monsoon को क्या किया? Yes, tell me. They have started. Southwest monsoon has one given kind of what is it? Tell me, southwest monsoon का क्या है? Yes, tell me, southwest monsoon का क्या role है? That it is going with this speed. So large area. तो यहाँ पर हमने large area 17 लाख स्क्वायर किलोमीटर. तो यहाँ पे लिख देता हूँ. पहले देख लें. पहले बता ही दो. Then when they started descending, two things are happening. It is creating a high pressure, and during descending, it creates an adiabatic compression. And adiabatic compression increases the heat, and when it is increasing the heat, some kind of moisture is available. So they started also carrying the what is a moisture and also pushing the southwest monsoon. It is increasing the intensification of monsoon. Yes or no? So it is increasing the intensification of monsoon and also providing what? Moisture, and India receives good amount of rainfall. Understood? So who is supporting? Who is supporting? समझ में आ गया? Who is supporting? Tropical easterly jet stream. Supporting and pushing it. Two things are happening. What are the two things? It is making a high pressure, and then pressure gradient develop करता जाता. And under this pressure gradient, they started pushing the southwest monsoon, intensifying the southwest monsoon. One, it is intensifying, another contributing more moisture. Contributing two things. By the adiabatic compression, it is contributing more moisture. The two things are happening. I said that intensification of southwest monsoon, second providing more. How? And why? More moisture by the adiabatic compression. Yes? Clear? समझ में आ गया? इसका मतलब कि ये जो 10 किलोमीटर की हाइट है, when this in 100 MB difference, then it started moving and then what? Deflecting towards right in the northern hemisphere, and they started falling in which region? Muscarine and Ethiopia, and making it is descending over there, and by descending they creates a what? Muscarine high and Ethiopian high. Understood it? Is it okay? समझ में आ गया? क्लियर कट आइडिया हो गया कि एक्चुअली में क्या हो रहा है? जहां हैवी हो गया तो गिरने लग जाएगा. अभी तक तुम लोग ये क्वेश्चन पूछोगे, ये सोचो कि why it started descending. If the region become heavy enough and cannot sustain further long, और उसके beyond it is not able to move, then it started what? Descending. Next one I said that, समझ में आ गया? Tropical easterly jet stream supporting to the monsoon. Next one I said that Findlater or Somali jet stream. Which jet stream I am talking about? This is okay. If I am talking about in this region, this is in a Somalia country, and Somalia country के पास क्या है? There is in a one kind of what is in a Somali cold current. What is this and how it is originated? Just tell me if you can. How do the Somali Ocean cold current come into existence? How do the Somali cold current come into existence? Fast. I said, आपको पता है कि साउथ वेस्ट ट्रेड विंड एंड देन देयर इज a साउथ ईस्ट ट्रेड विंड, इट बिकम साउथ वेस्ट ट्रेड विंड, एंड यू नो दैट. चलो पहले मैं इसके बारे में, ये क्लियर हो चुका है. ट्रॉपिकल ईस्टर्ली जेट स्ट्रीम क्या बोलोगे आप? पहला लाइन हमने क्या बोला था? टैबेट इज इन अ वेरी लार्ज एरिया. पहले इसके बारे में लिख ले, फिर संभाल लीजिए. क्या लिखेंगे हम लोग? यस, टेल में लिख लेंगे. Tibetan Plateau, which is around 17 lakh square kilometer area, with an average height of 4,000 meter, able to start a very large mechanical engine like tropical easterly jet stream, When subtropical jet stream, change the para, when subtropical jet stream shifts north of Tibet, then in Tibet sun insolation causes extra heating of 2 to 3 degrees Celsius, and warm air convect upward till the height of 6 km around and 10 km above the mean sea level. Compared to equatorial side, at the same height, upper atmosphere above Tibet has high pressure or anticyclonic condition. High pressure or anticyclonic condition with a 500 MB and equatorial side with 400 MB in the upper atmosphere. Under such high pressure gradient force, in the upper atmosphere, wind started moving from Tibetan Plateau towards equator, and under high Coriolis force, it deflected towards right. And moving in upper troposphere parallel to Kolkata-Bangalore line, and after becoming heavy enough near Mascarene Island and Ethiopian highland, this part of tropical easterly jet stream started descending. Descending air created Mascarene high pressure zone and Ethiopian high pressure zone. Under such pressure gradient with respect to India, it further pushed and intensified southwest monsoon. Further pushed and intensified southwest monsoon. And descending air through adiabatic compression contributed good amount of moisture to southwest monsoon. Therefore, under the influence of tropical easterly jet stream, India receives continuous rainfall, continuous good amount of rainfall. Clear? Now, if I said that suppose under the compatible pressure gradient, then it started moving under it 100 MB difference, and then it started descending down. Sometimes what happen when it is moving, it is not able to go here, they started descending in the North India itself. They started descending in the North India. And when it started descending, because it become heavy, because it is not able to come under the pressure gradient, जब इसको कोई खींच नहीं पा रहा है, so after crossing it started descending in the North India. When it started descending in North India, they causes heavy high pressure in India, and then under such condition I said that cyclonic wave is not able to come into northwest India, and there is an break of monsoon take place. I said that break of when the tropical easterly jet stream started descending, ध्यान से, in this region, then it causes what? Break in monsoon. 2 to 3 days it is okay, but if it is 2, 3, 4 days it is okay, but it continuously for 2 weeks it becomes drought in India. So समझ में आ गया? Who is causing break in monsoon? Tropical easterly jet stream. Sometimes also tropical easterly jet stream is also descending in the, I said it is also descending in the Himalayan zone. Also descending in Himalayan zone, they trap the air, and also it leads to the air is trapped. जब वो air which is convecting upward, convection upward is there, then those air has been trapped and then to an height, and they have been converted into heavy cloud and causes, I said that, cloud burst. Because in the Himalayan zone some water vapor convection is going on, and in the valley that region has been trapped, convecting air, and then they have been able to not, and condensation hai, condensed होके they causes cloud burst. So this tropical easterly jet stream also causes two things. One, it is break in monsoon, and another it is, I said that, cloud burst. Understood? The reason I said that it is not only one reason of cloud burst, but it is also one of the reason of cloud burst. Do not consider with, I said that completely in the June month you have seen that. आपने June month में क्या देखा था? Have you seen in the June month? Uttarakhand flash flood, cloud burst has been taken place. So one factor is also this. So write down. This study, easterly jet is causing descending of air, trap the moisture in this region, and जब trapped हो जाएंगे, pressurized हो जाएंगे, compressed, and they convert into what is a large amount of moisture in a particular valley region, and they started falling down. और यही चीज नहीं होता है, यहाँ से कंट्रीब्यूशन भी होता है. यहाँ पर एक आपको वो भी आता है, क्या कहा जाता है, साउथ वेस्ट मानसून का लो प्रेशर सिस्टम भी क्रिएट होता है. सो वो मैं मैपिंग वगैरह सब कभी बताते रहता हूँ, वहाँ पर इतना ज़्यादा डिटेल यहाँ पे नहीं आ सकता, लेकिन ये भी आपके लिए डिटेल ही है. सो राइट डाउन. सो द नेक्स्ट पॉइंट आप क्या लिखेंगे? इट इज सपोर्टिंग इट. Now break in monsoon, and break in monsoon कैसे होगा? What is the reason behind? Weak developed tropical easterly circulation. Yes or not? It is a circulation. It is in a circulation. So, break in monsoon. When tropical easterly jet stream could not fully develop, then it used to become heavy enough in northern part of India and start descending down and creates high pressure Such high pressure in northern Indian plain obstruct the movement of southwest monsoon Bay of Bengal branch. Southwest monsoon Bay of Bengal branch. Clear? Southwest monsoon. अब वो जा रहा है तो ऑलरेडी हाई प्रेशर आ गया, he cannot be able to move further and it can lead to, it means this phenomena is known as break in monsoon, and if it continues for 2 to 3 weeks, it is considered as drought. It is considered as drought. क्योंकि अब रेनफॉल क्या हो गया, इट विल बी लेस देन नॉर्मल. अब 2-3 सप्ताह रुक गया और इंडिया इज रिसीविंग 100 आवर्स ऑफ अ रेनफॉल and 2-3 weeks रुक जाने का मतलब several hours is not taking place, and therefore it is considered as a break in monsoon. At the same time, it also causes cloud burst kind of phenomena in Himalayan zone by trapping convecting warm air and moisture. Trapping which one? Warm air and moisture. Clear? कि क्लाउड इतनी हैवी हो जाता है कि इतना हैवी हो जाता है कि दैट इज स्टार्ट व्हाट इज फॉलिंग डाउन. आपको ये पता है कि गिरने के लिए क्या चाहिए, it should become heavy enough, or someone is also putting pressure. Yes or not? There is an also pressure, and at the same time they have been compressed enough, and when they have been compressed enough, then become cloud, become what is in a jitna space nahi usse zyada water vaporate is there, then it started what is in a converting into heavy cloud. तो इसकी डेवलपमेंट नीचे की ओर होने लग जाती है. Yes or not? Because it's not going to develop upward, it is going to develop downward and then become heavy and then started falling down. Understood? So this is the way that the cloud burst, and in a 1 hour it can give a very high rainfall, maybe a 3, 4, 5, 10 centimeter rainfall. Understood? In 1 hour 10 centimeter rainfall can be there. Cloud burst can be there. Next one is Findlater jet stream and Somali jet stream or Somali jet stream. Understood? you know that suppose the wind is moving like this. When the wind is moving away from the coast, what will happen? If the wind is moving away from the coast, what will happen? They will drag the upper layer, and upper layer को क्या बोला जाता है? It is known as Apleminian layer. Okay. Which layer is this? ओशन सरफेस का वार्म सरफेस, और इसके नीचे का लेयर होता है थर्मोक्लाइन लेयर. जब भी वाटर को देखोगे ओशियन का, ऊपर का थोड़ा गर्म होगा, नीचे का क्या रहेगा? थर्मोक्लाइन लेयर. और जैसे ही व्हेन वी आर ड्रैगिंग द wind, it is moving away from the coast, offshore wind, then it will drag the upper layer, and then cold water from the thermocline layer will move up and make the coastal region as what? Colder. And this way we have been able to see Somali ocean current, which I said that Somali, and it is in a which kind of it? Cold ocean current. Somali is in a which kind of it? Cold ocean current, and it is developing only in summer. It is developing only in summer. The reason behind, I said that southeast trade wind, it is moving like this. So this Somalia is facing which kind of it? Offshore. Somalia में कैसा दिख रहा है? If it is I said that it is moving like this, the Somalia is facing in a kind of what? Offshore wind. So the Somalia country is facing, I said that, offshore wind, and this offshore wind causes upwelling of cold oceanic water from the thermocline layer, and it is able to create Somali cold ocean current. So right now, during summer, Somalia eastern coast has offshore wind pattern, therefore eastern coast of Somalia is facing drag of warm Apleminian layer, drag of warm Apleminian layer, drag of warm Apleminian layer, and upwelling of cold thermocline layer. This upwelled cold oceanic water, is known as Somali current, Somali cold current. Clear? So Somali cold ocean current की वजह से क्या हो जाएगा? Tell me, what will happen? This region will have the cold ocean current की वजह से the region will be comparatively what is in a colder, air will be, and the air get compressed, and on the other side this is in Madagascar. I said that there is a Madagascar, and there is a Madagascar current, and there is a Mozambique channel. Which one I said that? And it is in a warm, or ये कैसा है? Cold, and it is in, I said that, warm. So in this region from the Mozambique region, and I said that Madagascar, I said that warm it is there will be convection. Yes, tell me, there will be convection or not? So there is a convection has been taken place. Comparatively to this region, upper atmosphere will be high. जहाँ convection होगा उसका upper atmosphere will be high or not? In the Somali there will be convection? No, because it is cold, and cold does not cause convection, but instead they try to compress. So इसके ऊपर में same region पे it is at height of 1.5 km and 2 km, not more than that. What is happening at height of 1.5 and 2 km? Somali के पास क्या दिख रहा है? On the ground it is in a high pressure, and in the Mozambique and Madagascar. What you are finding? Warm ocean currents, and warmness से क्या हो गया? Low pressure, and then convection upward, then there is a high pressure, and then upper atmosphere above Somali. What we have? If it is in the air has been compressed, there will be less air, and at the same time convection has made it more air. So from the Mozambique channel toward I said that Ethiopian and Somalian region at a height of 1.5 kilometer to 2 kilometer, the wind is moving fast, not higher fast, and started descending and making this Somalia region to be further high pressure, and this high pressure again creates an what? Helping the southwest monsoon, intensive high pressure, and the India is low pressure. So again it is helping what? Intensification of southwest monsoon, and that is known as, it has been discovered by Findlater, therefore it is also known as Findlater jet stream. Spelling Findlater, Findlater. So write down. Above Mozambique channel. Channel समझते हैं ना कहाँ पे है Mozambique channel? It is between Madagascar and Mozambique country. ये कहाँ पे है? This is Madagascar, और इसके बीच में क्या है? Mozambique channel. Understood? So I am talking about this. क्या बोल रहा था मैं? Yes. Above Mozambique channel, high pressure exists. Above Mozambique channel, what exists? High pressure exists, and comparatively above Somali, low pressure exists. Therefore, at a height of 1.5 or 2 kilometer, a wind moving with high speed from Mozambique to Somali and after becoming heavy enough start descending down. After becoming heavy enough start descending down. Clear? And creating Somalian region to be more high pressure. Further, one more study has been given by, and it's it is known as Somali jet. It is known as Somali jet stream or Findlater jet stream. Further, one more study has been given by Findlater near 8 degree south latitude. ध्यान से पहले यहाँ देखें, near यहाँ से पहले देखें 8 degree south latitude, and here if you'll go there is a Kenya. Yes or no? Kenya. तो आपको केवल ज्यादा नहीं समझाऊंगा. There is a what very in the upper atmosphere very high pressure gradient exists. कहाँ से? 8 degree south latitude in the Indian Ocean towards the Kenya there is a high, what is a, इसको बोला जाएगा ईस्टर्ली जेट स्ट्रीम. इट इज कमिंग फ्रॉम ईस्ट कंप्लीटली. वो ये ईस्टर्ली नहीं है, वो ट्रॉपिकल ईस्टर्ली. एंड देन स्टार्टेड मूविंग टुवर्ड्स, एंड अगेन इट इज हेल्पिंग इन द व्हाट? क्रिएटिंग हाई प्रेशर इन द ईस्टर्न अफ्रीका. Another study has been also given by Mr. Whom? And write down near, क्या बोला था मैंने? South latitude in Indian Ocean, strong convection created very high pressure in the upper atmosphere, created very high pressure in the upper atmosphere in comparison to Kenya and Ethiopia. Therefore, in the upper atmosphere, wind started moving from 8 degrees south latitude to Kenya and descending down near Kenya and further supporting and intensifying southwest monsoon. चले तो यहाँ से ये ऐसे गया और ये केनिया, this is Kenya, this is Somalia, this is Kenya, so here it is coming and then also it is supporting. समझ में आ गया? फिर lateral jet stream, tropical easterly jet stream, break in monsoon. So these are the two. Jet stream is important for understanding the monsoon in India, and one we have earlier understood, subtropical jet stream. Subtropical jet stream existing in India for longer, I said that period. You know that in India it exists for longer period, yes? And when it exists for longer period till 20 degree north latitude and created a high pressure, ये पूरा region कैसा बन जाता है? High pressure. And therefore the wind wetting into the what is in a southwest is not able to what is coming into it, जो कि हम लोगों ने कल की क्लास में yesterday we have completed subtropical jet stream and all. थोड़ा सा केवल कंसेप्ट दूंगा. हल्का सा केवल कंसेप्ट दूंगा. ये है ला नीना का, जो कि ओशियनोग्राफी में यहाँ पर एक पूरा, जब आप ओशियन करंट समझ लेते हैं, व्हेन यू अंडरस्टैंड द ओशियन करंट, और आपको ही पता है कि इफ द विंड इज गोइंग अप लाइक दिस और विंड इज गोइंग अप लाइक दिस, तो यहाँ पे डिसेंडिंग एयर, लिसन मी केयरफुली, डिसेंडिंग एयर दिख रहा है यहाँ पर, इन दिस वेस्टर्न इंडियन ओशियन नियर ईस्ट ऑफ अफ्रीका, डिसेंडिंग एयर, एंड द लार्ज ऑफ डिसेंडिंग एयर विल कंट्रीब्यूट इनटू व्हाट, more moisture, adiabatic compression. And when the southwest monsoon and high pressure, and the southwest monsoon will move further, more intensification, and India receives more than normal rainfall, and India faces flood and all. That is La Nina. तो जब ये समझेंगे, when we will do ocean current tomorrow. So I said next one we are going to see some concept has been given which has been rejected by our world community. और थोड़ा थोड़ा आइडिया बताते चलूँगा. And then there is a Monex monsoon expedition 1973 has been also done by, I said that who has done monsoon expedition? Russia and India. And from the India side, Mr. P. Koteshwaram. I said monsoon if you see some classical concept is there. In the classical concept, there is an Halley's concept is there. Flown concept is there. Tun yin concept is here. But if you see, and another I said that modern time, I said in this one we have seen Monex is there, just a monsoon expedition, 1973, and they have given us an importance of, I said that subtropical jet stream, जो कि हम लोग कर चुके हैं. He has given the concept of what I said that subtropical jet stream, tropical easterly jet stream, and another I said they have given the importance of this. It means they have emphasized thermal heating of Tibet and northwest India. दोनों का इन्होंने importance दिया. Thermal heating of Tibet and northwest. Thereafter, there is an El Nino and La Nina, that is considered an ENSO, El Nino Southern Oscillation, जो कि ओशिनोग्राफी की कल की क्लास में El Nino Southern Oscillation. And another I said that Indian Ocean dipole, that this concept come in 1997. Indian Ocean dipole. Clear? Subtropical jet stream आप देख चुके हैं. Yes, the role of subtropical jet stream, because in the month of March and April and May we should wait for the monsoon can come in India. India is highly heated, but even then it is not converted into what is a monsoon को drag कर सका, because subtropical jet stream causes what is in India to descend of air, and therefore pressure gradient cannot develop. Last week of May there is a sudden shift of subtropical jet stream north of Tibet, and then that led to sudden creation of low pressure, and then the first week of June there is a what? Who strikes? I said that कौन strike करता है? Yes, क्या नाम है? Monsoon strike as a burst of monsoon. So we'll give a little bit idea about all that these classical concepts. I said that he has utilized, I said that thermal concept. He itself utilized thermal concept. ज़्यादा आपको deep में इसके बारे में जानने की जरूरत भी नहीं है, but he said that there is a gigantic land breeze and sea breeze, gigantic land breeze and sea breeze. He talked about gigantic land breeze and sea breeze. He said that during summer, when I said during summer, as per the, you know that the land get higher, highly heated. दोनों में कौन सबसे ज़्यादा highly heated होगा? Land, 4 times faster. During summer, land get highly heated with the low pressure in comparison to near water body of ocean. So the ocean, that the land become what? Low pressure, according to whom? Halley's. We emphasize that gigantic land breeze and sea breeze. So therefore, when it becomes very low pressure, and anything you know that deflect towards right in the northern hemisphere, so there is a formation of what? Southwest monsoon. So gigantic, it is in a what? I said that sea breeze. हम लोग जानते हैं कि sea breeze not gigantic, only at the coastal region it is effective. But it is in a Halley who has given this concept. What he has given the concept? Gigantic, sea breeze and land breeze. And sea breeze in the form of, I said that, southwest monsoon. समझ में आ गया? That has given us, summer में क्या मिल गया मुझे? Southwest monsoon. This concept has been given by what I said that Halley thermal concept. हुआ क्या था? Yes, tell me what happened in the thermal concept? In the summer, I said that land get highly heated than water body, and the land become low pressure center and water body become high pressure center. Simple. And under the what is a rightward deflection in the northern hemisphere, deflected towards it and become what is a wind started coming from sea to the land. By deflection in the rightward becomes southwest monsoon. Understood it? Or in the winter he said that what happened? Land get highly cold by releasing heat. Highly cold by releasing heat with the high pressure and comparatively water body surrounding what is I said that water body surrounding is कैसा है? Warmer with low pressure. So under the Coriolis force, so wind started moving from what is an land to sea. अब ये land breeze बन गया. Winter becomes what? Coriolis force. I said that land breeze northeast monsoon, जैसे ये हो यहाँ से ऐसे कोई भी आ रहा हो, that becomes what? Northeast monsoon. They started under the Coriolis force, land breeze become what? Northeast monsoon. This is Halley's concept. Flown concept. And he has given the importance of ITCZ. He has given the importance of shifting of ITCZ flown. One it is, I said, that's summer, and another I said winter, summer and winter. Shifting of ITCZ. He said that in summer ITCZ shifts in the north. ITCZ shifts in north. ITCZ किधर शिफ्ट हो गया? ITCZ shifts in north. Therefore, southeast trade wind crossing the equator, southeast trade wind what? Crossing the equator, because it is a tropical convergence. तो ये दिखाना चाह रहे हैं कि साउथ है क्या? What is the southwest monsoon? ये बोल रहा है southeast trade wind है. Those who wants to come towards ITCZ. ITCZ means itself, और ये आप लोग भी जानते हैं, लेकिन यही तो रीजन नहीं है ना मानसून के लिए. I said that किधर था? Southeast trade wind crosses equator and become southwesterly wind and known as southwest monsoon. Known as southwest monsoon. Clear? Another shifting of ITCZ. I said that in the winter, sun goes into the south. So the ITCZ has moved into the ITCZ has been moved into the. यहाँ पे ITCZ north में था. Here it is an ITCZ in the what? Shifts in south. Clear? And here I said that northeast trade wind started moving toward this, and it becomes northeast monsoon. And it becomes, I said, so ITCZ shifts in south, and क्या मैंने बोला? Yes. Therefore, northeast trade wind become effective and started moving towards ITCZ as a northeast monsoon wind. Clear? So one it is in the summer and one it is, I said that it is in winter. Clear? Shall I? हटा दो. Another, I said that there is a Tunian concept, and it is including shifting of ITCZ plus northwestern hitting. Which term that he utilized? किधर? बस ज़्यादा इसमें लिखने की जरूरत नहीं है. ITCZ शिफ्ट हो रहा है, नॉर्थ वेस्टर्न हीटिंग हो रहा है, मानसून इसलिए उधर डिफ्लेक्ट हो रहा है. क्लियर? समझ में आ गया? So ITCZ same figure, or same figure में if you see that if it is in a hitting, monsoon is deflecting towards it. North western hitting. कहीं ना कहीं कुछ हद तक all are what is na, to an extent it is correct, but not complete explanation is not there. So these are considered as one of the classical concept. And then Monix कब हुआ? Where the Monix has been done? 1973 by the Russia and India. And then famous scientist was there, with him is P. Koteswaram. Is it okay? And they have given the importance of, कर चुके हैं हम लोग, they have given the importance of what? Tropical easterly jet stream, subtropical jet stream, and in this one he has given the importance of Tibetan hitting, northwestern hitting, or tropical easterly, subtropical jet stream we have done. Clear? This thing we have done, tropical easterly jet stream, subtropical jet stream. And then another concept थोड़ा सा आपको मैंने ला नीना को दिखाया था, and El Nino is just opposite to it, but it required around 1.5 hour. When we'll do ocean current, then it will be. And so another is, I said that Indian Ocean dipole, it is also the part of it. Clear? लेकिन जस्ट ऐसा है, थोड़ा सा एक आइडिया देता हूँ. In 1997 it has been declared that the India will not receive rainfall, there will be a less rainfall. India will face El Nino. El Nino means I said that no rainfall, less rainfall, and India will have what, less than the normal rainfall. But what happened? India has got more than normal rainfall. Everybody started searching out what is the reason behind, and the new concept came, that is Indian Ocean dipole. Okay? The two things, positive phase and negative phase of Indian Ocean dipole. Okay? So El Nino and La Nina and means ENSO. El Nino and La Nina together considered as an ENSO. El Nino southern oscillation, change in the pressure system. And after that, क्या मैंने बोला? Indian Ocean dipole. Now we are going to see monsoon in India. First there is an onset of monsoon.
and then under this it is, I said that southwest monsoon, Bay of Bengal branch and monsoon. Clear? 15th May to 15th September. I said withdrawal of monsoon or retreating monsoon, and we'll see from the 15th September to 15th December. And one of the famous phenomena is October heat and rainfall in Maharashtra and Andhra region also. Rainfall in Maharashtra and Andhra. October heat. Then we have a northeast monsoon, and that is from the 15th December to 15th March. And you know that the region which is receiving rainfall, Andhra coast, southern Andhra, southern Karnataka plus Tamil Nadu. Northeast monsoon. Someone says that southwest monsoon causes 80% and the northeast monsoon causes 20% of the rainfall of India. But it is not so, like it is 90% it is southwest monsoon. And then northeast monsoon how much? 10%. 90% rainfall in India is by northeast monsoon, is southwest monsoon, and 10% of rainfall is through, I said, northeast monsoon. Then there is an, I said that, pre-sour monsoon, and these are in the form of mango shower, cherry blossom, and Kal Baisakhi, nor'wester, or Chira Borle. So we have to see this 4 period of monsoon in India, and these are in the form of, I said, onset of monsoon, and that is from the 15th May to 15th September. Which are the monsoon? Yes, fatapat. Onset of monsoon 15th May to 15th September. Withdrawal of monsoon 15th September to 15th December. Northeast monsoon 15th December to 15th March, and 15th March to 15th May pre-shower monsoon. Some of the things you should be what by heart रटना है. आपको कई बार बोलें क्लास में भी, if I am doing something, don't waste your time, wrote the points. Clear? As much you'll wrote the points, exam में that much help it will be there. Clear?
I said now first we are going to see onset of monsoon. And you have to draw a beautiful figure of India to represent it in rainfall. So, first we are going to see Arabian Sea branch, and at the same time these figures should be remembered by you. ये figures को आप याद रखते चलेंगे. Arabian branch. I said that in the Arabian branch, if I am finding, so the southwest monsoon in the first week of June strike Malabar coast, yes or not? And strike Malabar coast, Malabar coast normally means perpendicularly. Understood? Normally means perpendicularly. And then what is the height of Western Ghat in this region? Yeah? 2000 meters. That is, I said that Nilgiri Hills, Annamalai, Cardamom and Agastyamalai. It has been uplifted, yes, at the time of formation of Himalaya. So normally it is hitting and then causing, I said that 300 centimeter rainfall. So the normal hitting, and here it is in the Kannada coast and in the Konkan coast, it is, I said, it is hitting, I said, how much? How they are hitting? Obliquely. How do they are hitting? Clear? I said, इसको आप जानेंगे तभी, you know that. अच्छा ये मुझे बताओ, हायर हाइट पे रेनफॉल ज़्यादा होगा या लोअर हाइट? हायर हाइट. सो ध्यान से देखना, जब मैं वेजिटेशन बायोजोग्राफी में बताया जाएगा. So here it will be, I will tell you a kind of moist deciduous forest, semi-evergreen forest, evergreen forest along the Western Ghat, just little bit semi-evergreen, suddenly there is a what? Thorny forest. क्योंकि understanding of rainfall pattern helps you understanding what is a vegetational structure in India, natural vegetational structure in India. और यहाँ पे चले जाएंगे तो यहाँ पर एक शोला forest, that is an extra, it is there. And say solar forest का मतलब होता है it is wet temperate forest. It will be taught in your biogeography. So 200 centimeter rainfall has been given to which I said that Konkan coast and Kannada coast. Understood it? And thereafter, other side there is a leeward effect is there. And you can be able to see, like I said, here it is, I said 60 centimeter, 50 और यहाँ तक आते 40, 30 centimeter, 60, 50, 40, 30 centimeter, थोड़ा सा there is 60 and 50 centimeter in the other side of Tamil Nadu. Understood it? And this region converts into, I said that semi-arid, that this region converts into semi-arid. याद हो गया? Yes. How much near to Coimbatore and all? It is 60-50 centimeter. Yes. And this kind of rainfall helps in the growth of cotton textile, cotton growth. Cotton growth needs what? Less rainfall. Next one that I said, next क्या बोलना हमें? Next one I said that another branch is moving into the Narmada Rift Valley, and you know that Narmada Rift Valley in the sense Vindhya range, and there is a Satpura range. Vindhya range and north में Vindhya and the south में which one I said that Satpura range. In the Narmada Rift Valley, low pressure has been found. Comparatively, I said that low pressure has been found, and that is books में कहीं लिखा रहता है trough means low pressure. Clear? So the one branch of, I said that southwest monsoon Arabian branch moved into which region? Narmada Rift Valley, and in the Narmada Rift Valley there is a mountainous regions are there, and the orographic यहाँ पे, and that is how much rainfall it is causing? 100 centimeter rainfall, and here it is able to reach Chhattisgarh. चले अमरकंटक प्लेट्यू यहाँ पर कहाँ पहुँच गया? अमरकंटक प्लेट्यू. Clear? And if you know that there is several hills are there in the Gujarat, Kathiawar, Venu Hills, Elite Hills, Gir Hills, Ginnar Hills, Mandau Hills, Setrunjo Hills, several, but all hills are, I said that height is very low, 500, 600. They will not stop too much, yes or not, this branch? And they are able to cause rainfall in this region 50 to 60 centimeter. How much? In the Kathiawar or Saurashtra region, southwest Arabian branch is causing how much rainfall? 50 to 60. And if you go into the Kutch region, only वहाँ पे एक छोटा सा hill है, only Kutch hill, and it is very small hill. There is no obstruction. Understood? Very less, and then the rainfall is in the form of 10 to 20 centimeter. 10 to how much? It is a kind of desert. But यहाँ पर क्या होता है? Several things. यहाँ पर this coast is an emergent coast. एक आप लोगों को फिर ज्योग्राफी में जियोमॉर्फोलॉजी समझाता हूँ. It is an emergent coast. One, it is this region is an emergent coast. Earlier this region was simple idea रखेंगे. It was under the ocean. Under the ocean means there will be salinity. What will be there? Salinity. What will be there? Salinity. And if there is salinity is there and deposition of river deposit sediment slowly lead to the what? Emergent type of coast. It has been emerged and that lesion become completely west. कैसा दिखता है? कैसा दिखता है? Marshy. रण का मतलब क्या है? मार्सी. Yes or not? Marsi means daldal. Run of Kutch. Whole Kutch is not run of Kutch. Parts of Kutch is run of Kutch. And that run of Kutch, marshy and saline. Why it becomes saline? Do you understand that? Reason behind? For becoming of its salinity, it is what? Deposition of what? Sediments into the oceanic region, nearby continental itself. And यहाँ पे धीरे धीरे deposit होते हुए it become an emergent type of coast. So the two coasts are emergent, this one and Malabar coast. Understood? इसका आपको पता होना चाहिए. आपको मैंने बताया था intrusive granitic magmatic eruption, and that is an I said this way. तो इस रीजन में कोई हिल नहीं है. Understood? And only we have 10 to 20 centimeter rainfall. Got it? Next one I said that when it is moving towards it, Aravalli range around it is an 800 kilometer long, and it is standing from what is in a Delhi से start होता है. You know Delhi University, there is a Majnu ka Tila till Sirohi district in Maharashtra, Rajasthan, and little bit in the I say कहाँ पर आ जाता है? Yes, tell me. Gujarat, Banaskantha region. And here it is. इसकी हाइट जो है, इफ आई से दैट दिल्ली में आपको पता भी नहीं चलता है कि आप अरावली पे हो. यस, यू आर नॉट एबल टू अंडरस्टैंड. हाइट इज अराउंड 200-300 मीटर above the mean sea level. But if you go this side, the height becomes, I said that, very high. And then the Guru Shikhar peak is the highest peak, you know that, 1722 meter. So this region has a little bit higher peak and it obstructs, and this region receives 50 to 75 centimeter. How much rainfall is there? How much rainfall? 50 to 75 centimeter. Obstruction by the southern Aravalli hills. Southern Aravalli hills. Is it clear? Thereafter it keeps on moving parallel to Aravalli. It keeps on moving. और इस बार आप देख रहे हैं कि बहुत ज़्यादा ही मॉइस्चर लैडन विंड लेकर आ चुका है. मॉइस्चर इज मोर, एंड दिस रीजन हैज बीन फ्लडेड. नाउ इट इज मूविंग पैरेलल टू Aravalli. So it is not the southwest monsoon Arabian branch further has not been stopped by Aravalli, because the Aravalli is parallel to this. And when it is no, then western part of Aravalli, Rajasthan पूरा इतना है, ये है राजस्थान. One it is in the west of Aravalli, one it is out east of Aravalli. Understood? And they are not able to receive the rainfall. और मैंने आप लोगों को बताया था कि राजस्थान, जिस दिन कन्वेक्शनल रेनफॉल के लिए बताया था कि इन द राजस्थान above in the upper atmosphere what creates anticyclonic, and बलूचिस्तान के साथ दिखाया था. And therefore anticyclonic condition in the upper atmosphere, there is an what 30 to 40 centimeter rainfall. Understood? Okay. And finally, there is no obstruction. Punjab and Haryana is completely in a plain. So no rainfall in Punjab and Haryana. Finally, it causes rainfall in, I said, by reaching Jammu hills, it is causing, I said, 30 to 60 centimeter rainfall. Jammu hills of Shivalik range. समझ में आ गया? How much? I said that Malabar coast 300 centimeter rainfall for the 3 months around, but you know that it keeps on having a rainfall for 8 to 9 months under the land breeze and sea breeze. And I said that leeward side of Tamil Nadu, it is getting how much? 50-60 centimeter rainfall, and it is normally what is normally hitting Konkan and Kannada coast. How it is hitting? Obliquely. और जब obliquely hit करेंगे तो आपको ही पता है कि if it is an obliquely hitting, तो not perpendicularly hitting all, it is rising up. Obliquely hitting, some are rising at and some are what is going away. So therefore the rainfall is reduced in comparatively in which coast? Kannada and Konkan. Understood? Thereafter, a trough which has been created in Narmada Rift valleys, that part has moved into the Narmada and causing, one part has moved into Narmada and causing 100 centimeter rainfall. It means southern MP is receiving how much rainfall? Around 100. Then in the Kathiawar or Saurashtra region of Gujarat, it is receiving how much? 50 to 60 because of the some hills are there. And then 10 to 20 centimeter rainfall in Kutch. Southern hill of Arauli obstructed it and causing how much? 50 to 75 centimeter rainfall. Arauli is higher. And further it moved parallel to Arauli without any rainfall. But whenever it has an anticyclonic condition created in the upper atmosphere, that is causing convection of this southwest monsoon and cloud and causing rainfall. And by reaching Jammu hills, or what you can say that Churia, Jammu is better to say Jammu hills, not Churia. It is able to cause how much rainfall? 30 to 60 centimeter. Understood it? So we have completed this. Now we are going to see Bay of Bengal branch. Where it is? When the southwest monsoon Bay of Bengal branch, और आपको पता है कि ऑलरेडी ये हाईली हीटेड लैंड है ये भी, यस, यहाँ पे सब ट्रॉपिकल हाई प्रेशर ने यहाँ पर इस रीजन में मूवमेंट होने नहीं दिया. यू नो दैट इट हैज गॉन अवे इन विच पीरियड? टेल मी, इन विच पीरियड इट हैज गॉन अवे? लास्ट वीक ऑफ May. सब ट्रॉपिकल जेट स्ट्रीम शिफ्ट्स, लेकिन देयर इज नो इफेक्ट ऑन दिस पार्ट ऑफ द लैंड. यस, Therefore, साउथ मानसून अंडमान निकोबार में, यदि इंडिया में देखा जाए लैंड में सबसे पहले मालाबार पे आता है. इफ यू सी दैट आइलैंड पे सबसे पहले अराउंड आई सेड दैट 15th of May to 25th of May के बीच में it strikes where, because there is a low pressure system is comparatively over here. It is clear. So there is not too much obstruction. तो यहाँ से सब ट्रॉपिकल जेट स्ट्रीम का इफेक्ट पहले ही रिड्यूस हो जाता है. In the region of this, because here आपको याद बताया था मैंने कि हिमालय is very high and it is obstructing the Hadley shell movement. याद है, it is obstructing the, but in this region there is what I said that Yunnan plateau, Shan plateau, these are the plateau structure, mountainous structure is not there. So यहाँ पे सब ट्रॉपिकल हाई प्रेशर बेल्ट जो है सब ट्रॉपिकल जेट स्ट्रीम इधर मूव कर जाता है. तो this way it moves like this. तो इस कारण से यहाँ पे comparatively low pressure hitting रहता है and it heated what is enough in the 15th May to 25th May. So यदि देखा जाए तो who receives earlier monsoon? Andaman and Nicobar. So Andaman Nicobar it is receiving 15th to 25th May and it is causing 300 centimeter rainfall. Andaman. Further Arakan Yoma, Pevi Yoma, and it enter into northeast. And it causes 200 plus centimeter rainfall in northeast. 200 plus centimeter rainfall in northeast. लेकिन देखा जाए तो it is moving parallel. It is moving parallel to Tamil Nadu and this region Andhra, southern Andhra. Therefore, it is not causing rainfall in the Tamil Nadu. Tamil Nadu, most of the region does not receive rainfall during summer. Understood? The summer dry. Tamil Nadu region summer, or that is also one climatological reason is that they fighting for Kaveri river. Yes or not? Water requirement. More water requirement during this. But at the same time, what is the meaning of cropping pattern? Can you tell me what is the definition of cropping pattern? Raise your hand. Cropping pattern. You have to study in the GS also. Paper 3rd. Tell me fast. मेरी तरफ देखने लगे सर, आप ही बताओ. हाँ? Yes. चलो, तो इसका मतलब ये हो गया कि if the महाराष्ट्र, आपने देखा महाराष्ट्र 50-60 सेंटीमीटर, and then you know that sugarcane needs how much? 100 centimeter plus rainfall, and then Maharashtra is doing sugarcane. It is in a cropping pattern. Maharashtra is growing sugarcane. It is in a cropping pattern. No. हाँ? अब इरिगेशन कहाँ है महाराष्ट्र के पास? पानी कहाँ है? प्रॉब्लम है वहाँ पर. I said that last year it was in a man-made drought. Maharashtra was facing man-made drought. कहाँ थे? अच्छा, cropping pattern. Simply I said that in a list of crops growing in a given geographical region as per the climate. Cotton is growing as per the climate and all, that is good. But sugarcane, as per the climatic condition, rainfall is not that much. So it is against the what is in a cropping pattern. And the same way if you will go into the Tamil Nadu region is also doing. They have a very high temperature, climate is supporting, but the rainfall is not supporting for the doing rice. And they are doing, some region are doing twice and thrice, क्योंकि वहाँ temperature throughout the year it is high. So there is a cropping pattern of rice is twice a year and thrice a year. And you know that rice needs 150 to 250 centimeter rainfall. Because 1 kg of rice needs 5000 kg of water to produce 1 kg. Then you can sow paddy, it is puri marsi mein kiya jata hai. And then this is another, again it leads to what is a Kaveri river disputes. समझ में आ गया? So one it is there, what is a physiographic and climatic pattern. Another I said that there it is an, I said, cropping pattern that they have developed, which is not as per the completely climatic. So instead of growing for, they should grow for 1 or 2 years, and as per the climate, rainfall is less, then you should grow some other kind of what is in a crops which is supporting in that kind of what is in less rainfall. So they are, तब उसको हम लोग क्या बोलेंगे? Cropping pattern. Clear? Now, so this is about, I said that now it is how much rainfall it is. I said that 200 plus centimeter rainfall, and here it is. But यहाँ पर सारा आपको क्या दिख रहा है? Next point I said, in the Meghalaya there is a Garo, Khasi, Jaintia. Garo, Khasi and Jaintia. And in the Khasi hills there is a Monsoon Ram and then Cherrapunji. In the Khasi hills there is a Monsoon Ram and Cherrapunji. And this region is like in a what? Funnel shape. This region is like, and I said that so when the southwest monsoon Bay of Bengal branch comes, when the southwest monsoon Bay of Bengal branch comes, it is obstructed by, yes, this from all sides. Either to जा ही नहीं सकते, it is coming from this side, it is obstructed from all the sides, and all the rainfall took place in this region, and especially in which region? Khasi hills. Who is the front one? Khasi. So Khasi पे सबसे ज़्यादा rainfall होगा. If it has been asked Garo, Khasi, Jaintia, which one region will have more number of high amount of rainfall? Khasi. Where is the largest number of waterfalls? Khasi hills. Understood it? So I said that this is the structure and funnel shape, it is supporting it. And the rest of the northeast is receiving, I said, 200 plus centimeter rainfall. So I said that here it is in a good amount of moisture, और साथ ही साथ थोड़ा सा along the foot hills of Shivalik थोड़ा सा low pressure होता है, और ये wind थोड़ा इधर भी जाके rainfall करते रहता है at the foot hills of the Shivalik, and then some at foot hills of Shivalik. Comparatively यहाँ पर air बहुत ज़्यादा आ गया और यहाँ पर comparatively air कम होता है. So what happened? Some of the what is the moisture started moving along the foothills of the Shivalik and causing rainfall. Understood it? So we have seen like this. Now in the mid of June around, you know that there is a formation of cyclonic wave. Yes, thanks to the cyclonic wave, and there is this is a highly heating. and then cyclonic wave drag southwest monsoon Bay of Bengal branch. इतने बड़े इंजन को इधर लाना आसान नहीं है. It has created by this cyclonic wave, and it is causing rainfall in the northern Andhra, and then I said it is causing the rainfall in Odisha, northern Andhra, Odisha, Chhattisgarh, Jharkhand, West Bengal, Bihar, and then UP, and I said Punjab, Haryana, Delhi, Haryana, Punjab and Jaipur. कहाँ का रेनफॉल कर रहा है? Where do these rainfalls are? First it is, I said that northern Andhra, then Odisha, Chhattisgarh, Jharkhand, West Bengal, Bihar, UP, and then Delhi, Jaipur, and thereafter Haryana and Punjab. And then again it meet with the Jammu Hills. Again it meet with Jammu Hills. Clear? Now you can, like I said that when it is dragging over there, the first you have to remember, like आपको ही पता है, this is an eastern ghat. What is this? Eastern ghat. All these are what? Eastern ghat. And at the same time, who is dragging it? Tell me, who is dragging it? Cyclonic wave. And then in the West Bengal, 150, Jharkhand, 150, Odisha, 150, Chhattisgarh, 125, Bihar, 125. Can you remember this much rainfall? How much in the West Bengal? Side of western side of West Bengal is Jharkhand. How much? Odisha 150, Chhattisgarh 125 and Bihar 125. Is it clear? Now then Bihar में कैसे rainfall हो रहा है? वहाँ पे तो plain area है. How it is the rainfall it is happening? Cyclonic wave. वो उठाता है. Yes or not? Cyclone नहीं है. Cyclonic wave. Whole UP is in a plain area. Whole Punjab and Haryana is in a what? Plain area. Understood it? It is helping the what is in a wind to convect upward. Is it clear? The UP में till Allahabad 100 centimeter. What is I said that? Till Allahabad 100 and in western UP 80 to 90. How much it is I said that? जैसे जैसे it is going interior, the rainfall is reducing. Moisture is reducing, and by reaching Delhi, Haryana, Jaipur, Punjab, it is causing 50 to 60 centimeter rainfall. How much? So Delhi, Punjab, Haryana, how much it receives? Tell me. 50 to 60 centimeter rainfall. याद हो चुका है? And then northern Andhra, it is receiving around, you can say around 100 centimeter. Northern Andhra around 100 centimeter. It is clear? So what are the rainfall pattern? I said that. Yes, tell me. Southwest monsoon. Further, after doing the rainfall in the northeast, I said that one low pressure system along the foothills has been created, Shivalik, and that has been dragged towards it, and the foothills of the Shivalik is getting good amount of rainfall. Further, in the mid or last week of June, that the cyclonic wave started dragging the southwest monsoon of Bay of Bengal branch towards central part of India and northern Indian plain. And in the West Bengal, it is causing, I said that 150 centimeter rainfall. And in the Jharkhand, it is 150, Jharkhand 150, Odisha 150, Chhattisgarh 125, Bihar 125. In northern Andhra, around 100 centimeter. Further, till Allahabad in the UP, it is 100 centimeter, and western UP 80 to 90 centimeter. Understood it? And then Punjab, Delhi के साथ साथ Haryana, Punjab and little bit Jaipur receiving 50 to 60 सेंटीमीटर. एंड नाउ मेरे साथ कुछ प्लेट्यूज है, उसके नाम आपको क्लियर होने चाहिए. एंड देन आई सेड दैट this is Baghelkhand plateau. Which one I said that? Baghelkhand, Bundelkhand, Madhya Bharat Patar. Baghelkhand, this is I said that Bundelkhand, and this one I said that Madhya Bharat, क्योंकि यहाँ से बारावली हो गया, मध्य भारत पठार. And this is I said that Malwa plateau. Which are the region I said that? Which are the plateaus? बघेलखंड, और यहाँ पर यू कैन राइट ऐसे ममरकंटक प्लेट्यू. बघेलखंड, बुंदेलखंड, मध्य भारत पठार, यस, मालवा प्लेट्यू. मालवा प्लेट्यू, मालवा प्लेन पंजाब एंड हरियाणा में. मालवा प्लेट्यू. एंड विच वन आई सेड दैट? अमरकंटक. अंडरस्टूड इट? क्लियर? सो द अमरकंटक प्लेट्यू जो आ गया वो 125 सेंटीमीटर और छत्तीसगढ़ को ले लिया. Baghelkhand is receiving, I said that Baghelkhand is receiving, I said 80 to 90 centimeter, 80 to 90 centimeter, and Madhya Bharat Pathar 50 to 70, Arali tak pahunchte hue. So eastern Rajasthan is receiving rainfall, and then there is in a Malwa, it is 50 to 70. Baghelkhand 80 to 90, Bundelkhand 80 to 90, and then I said which region I said? Madhya Bharat Pathar 50 to 70, and Malwa Plateau 50 to 70. याद हो गया? What is the how much in the Baghelkhand? अब वो तुम जियोमॉर्फोलॉजी क्लास में आओ, वहां पे मैं समझाता हूँ. इट इज एन ग्रेनाइटिक रॉक, ग्रेनाइटिक नीस, और इसके अंदर पानी नहीं जा पाता है. एंड व्हेन द रेनफॉल इज टेकिंग प्लेस, रन ऑफ, नो अंडरग्राउंड वाटर रिचार्ज, एंड देयरफॉर इट इज कमिंग अंडर द ड्रॉट प्रोन. क्लियर? वहां पर बताते समय जब वोल्केनो बताता हूँ, वोल्केनो की क्लास, दैट टाइम आई हैव टू. सो आई सेड, कहां पे था मैं? Malwa. So Madhya Bharat Pathar and Malwa Plateau, how much rainfall they receives? 50 to 70. याद हो गया? Yes. Now, next one I said that there is a Jammu and Kashmir, or it is able to meet with, I said that किससे मिला? अरेबियन ब्रांच से जम्मू हिल्स पे, और दोनों मिला के यहाँ पे 30 सेंटीमीटर 40, 50, 60 के आसपास कर देते हैं, and total 100 centimeter around rainfall takes place. Where it is? Jammu Hills. And the Jammu Hills pe who is meeting? Arabian branch. And which branch I said that? Bay of Bengal branch. वैसे तो मिलने के लिए यहाँ पर भी मिल रहे हैं. They are also meeting, I said, sorry, in this region. If we have seen that it is going along this, you know, one Narmada Rift Valley. So, ये कौन सा रीजन हो गया आपको? जम्मू एंड कश्मीर, दिस इज हिमाचल प्रदेश, दिस इज उत्तराखंड, एंड इट इज एन माउंटेनस रीजन एज आई सेड यू. और जैसे मैंने बोला कि इन द अपर एटमॉस्फेयर देयर इज एन वन हाई प्रेशर सिस्टम क्रिएट्स. व्हाट क्रिएट्स? किलर, व्हाट क्रिएट्स? एन एंटी साइक्लोनिक कंडीशन इन विच 3 स्टेट्स? जम्मू एंड कश्मीर, हिमाचल प्रदेश एंड उत्तराखंड. एंड उसके वजह से नीचे क्या क्रिएट होगा? लो प्रेशर, एंटी साइक्लोनिक कंडीशन, मैकेनिज्म तैयार होना चाहिए, एंड देयरफॉर स्टार्टेड अट्रैक्टिंग मॉइस्चर. तो यहां पर क्या हो गया? हाई प्रेशर ऑन द माउंटेनस ग्राउंड पे क्या हो गया? लो प्रेशर. दे स्टार्टेड अट्रैक्टिंग दिस मॉनसूनल ब्रांच टुवर्ड्स दिस रीजन, एंड देन व्हेन दे स्टार्टेड रशिंग अप लाइक दिस, द साउथ वेस्ट मानसून ड्रैग टुवर्ड्स, yes, low pressure created in J&K, HP, and which one? Uttarakhand. and they can convert into what I said, that they can convert into किसमें convert हो सकता है? Yes, tell me. Cloud burst and all high, and that is causing 152. I said that 200 centimeter rainfall. How much rainfall it is there? Himachal Pradesh 150 to 200, Uttarakhand 150 to 200, and then Jammu and Kashmir around 100 to 150. It is 100 to 150, but Himachal Pradesh 150 to 200, Uttarakhand 150 to 200. Understood it? क्योंकि वहां पर एक्स्ट्रा लो प्रेशर क्रिएटेड, एंड दैट इज एन dragging and making, जैसे जैसे हाइट बढ़ते जाएगी, if the height is increasing, then the moisture will keep on condensing more and more. Yes or not? Because coldness causes more condensation, and more condensation causes more rainfall. Understood? समझ में आ गया? Every state wise how much rainfall it is happening. Clear? और अब हमारा कौन सा बच गया है? This region, and that will be completed by northeast monsoon. Who will do this? बताए भी था लिखवाते समय, सदर्न आंध्रा, सदर्न कर्नाटका एंड तमिलनाडु. So just I am giving the figure. I said that Malabar coast 300 centimeter, leeward side 60 to 50 centimeter, and then Konkan and Kannada coast 200 centimeter, leeward 60, 50, 40, 30 centimeter rainfall. And thereafter I said Narmada Rift Valley trough created 100 centimeter. Kathiawar region, it is, I said that 50 to 60 centimeter rainfall. Kutch region 10 to 20. South of Arauli, it is 50 to 75 centimeter rainfall. Understood? Now moving parallel to the south of west of Arauli, it is causing 30 to 40 centimeter rainfall. And then by reaching Jammu Hills, it is causing 30 to 60 centimeter. Understood? Arabian branch. Now that Bay of Bengal branch, it is causing in about 15 to 25th May. It comes earlier to what I said, that due to the in the Chinese side, China, and then Indo-China side, क्या है? Comparatively, subtropical jet stream is not too much effective. Therefore, it strike little early, and that is in the 15th May and between 25th May, it used to strike, and causing 300 centimeter rainfall in Andaman Nicobar. Further, it in India, if you consider 200 plus centimeter rainfall by the obstruction of northeast eastern Himalayas and Purvanchal hills. And there is in the Meghalaya, there is an Garo Khasi Jantia is there, and the Khasi is these are able to trap the southwest monsoon moist light and wind in a funnel shaped structure and causing heavy precipitation, and even it is causing 1000 centimeter rainfall. Clear? And thereafter we have seen there is along the foothills of the Shivalik some low pressure. यहाँ पे ज़्यादा हवा है और that it is less, so there is one low pressure system created, and therefore along the foothills of the Shivalik that causes some rainfall. Further, southwest monsoon Bay of Bengal branch was dragged by cyclonic wave and the pressure gradient existing in the northwestern India, that is the Rajasthan and Sindh region, high temperature की वजह से, and then it started dragging the southwest monsoon towards the central part of India and then Gangetic plain of India, and causing West Bengal as an 150 centimeter rainfall, and then by obstruction of other eastern Ghat, it is in Jharkhand 150, Odisha 150, Andhra 100 centimeter, northern Andhra, and then Chhattisgarh 125 centimeter, and Bihar 125. Further in the UP till Allahabad 100 centimeter, and then western UP 80 to 90, and Punjab, Haryana, Delhi, and then Jaipur receiving 50 to 60 centimeter rainfall. Further, by meeting at Jammu Hills, the total rainfall is around 100 centimeter. Then we have seen Baghelkhand, Bundelkhand, Madhya Bharat Pathar, Malwa Plateau, Amarkantak. These are the Baghelkhand, Bundelkhand, it is receiving 80 to 90, and we have been able to see, I say, Madhya Bharat Pathar 50 to 70 and Malwa Plateau 50 to 70 centimeter. Therefore, it is in this region black soil है और rainfall भी कम है. Therefore, it is cotton is growing in this region Malwa and all. So we can be able to see, और इसी region से यहाँ पे भी rainfall कम है. पंजाब and हरियाणा के इस region में भी cotton होता है. This side of Coimbatore district we are doing cotton and all. And then जहाँ जहाँ पे rainfall कम है, and then soil is clay, that we will learn later on, and there will be a cotton is being under the production. Then हमने क्या देखा, and जहाँ जहाँ heavy rainfall हो रहा है वहाँ पे जो production it is very much. So Assam is what I said, that West Bengal, these are the two regions which is supposed to be what is Assam, West Bengal and Bihar. जहाँ पे सॉइल भी alluvial हो वहाँ पे jute is growing. And I said बता दिया हाँ, an anticyclonic condition created in the Jammu and Kashmir, Himachal Pradesh and Uttarakhand in the upper atmosphere dragged the southwest monsoon branch towards it and causing how much rainfall? Around 150 to 200 centimeter. Or earlier the Britishers used to do what is I said tea cultivation in the Himachal Pradesh because of such rainfall, but the temperature थोड़ा सा colder हो जाता है, the tea cultivation is not too much in the productive form. But Kangla district and all, there is a reason what? Tea cultivation. Since British time it has been started and still we are doing tea cultivation in this region. So we have seen this kind of it. Now next one I said that withdrawal of monsoon. And withdrawal of monsoon starts from 15 September to 15 December. Withdrawal of monsoon. I love to see when the students are making map of India. United States is easy to make, huh? पाकिस्तान में कुछ नहीं है, कुत्ता बैठा दो ऐसे पीछे से पूछ निकाल दो, that it will become like this, huh? ये थोड़ा सा मुंह आगे करके I have talked to you. What is the period of subtropical jet stream in India? Tell me. 15th September, na? 15th means again this all the pressure belts and then tricellular models are shifting again when the sun has gone getting into south. So all the belts again shifts. And 15 September subtropical jet stream comes again in northern India. Understood? Yes, subtropical jet stream again come in northern India. और ये region किस में convert हो गया? Wind started descending now. When it started? And when the wind started descending down, then it will become into what? High pressure. Yes. याद है ना? बार बार मैंने बोला था याद कर लेना. क्या बोला था? What is the date of subtropical jet stream? 15 September to last week of May next year. And if it is in a high pressure is over there, means subtropical jet stream again come in India. Bifurcated, one it is in the north of Himalayas, the one south of Himalayas. And it is happening till. So when high pressure is created, then the wind started what? Moving in the other direction. Yes or not? They will keep on moving away. And then when they are moving, अच्छा ये मुझे बताओ, all moistures in the atmosphere causes rainfall या some of the moisture is still in the atmosphere in the month of September. हाँ? अभी भी moisture होगा जो rainfall नहीं हो रहा. They should become heavy enough. I have said that to fall down. So when it is when the high pressure, I said that the withdrawal of monsoon, में हम क्या देख रहे हैं? I said that what happened? High pressure created in northern India and then Indian subcontinent. What created? High pressure. And they started, the wind started moving away. One side, I said that, ye kya ho raha? It is in Himalaya. The wind will only move toward the what? South. And this way the wind started moving under the coldest force also. Coldest force is also there. They started moving like this. By the time, whatever the moisture they are carrying, जो भी moisture होगा, by reaching here, Maharashtra, Andhra, understood? What happened? They condensed enough and heavy enough to fall down in the Maharashtra and Andhra. What happens? Tell me. Rainfall. What happens? So the rainfall, when it is in a retreating, then they started getting the rainfall. Understood? समझ में आ गया? Whatever the moisture which has been left into the atmosphere, after the monsoon get over, by the coming of subtropical jet stream and high pressure created in northern India, the wind started moving away and then started dragging. The unavailable moisture started accumulating by reaching Maharashtra and Andhra, and that started causing good amount of rainfall. Understood it? और ये process, this process is going on slowly and slowly. और इससे धीरे धीरे हम लोग पहुंच गए 50, we are able to reach December month. लेकिन एक और चीज हमें बताना है, तो दिस नॉर्थ इंडिया में रेनफॉल होगा? नो, ये तो केवल जो मॉइस्चर है. सो दैट इट इज विड्रॉल ऑफ मॉनसून. मॉनसून इज विड्रॉइंग. सो नॉर्थ इंडिया में क्या हो रहा है? विंड इज डिसेंडिंग, और डिसेंडिंग विंड. अनदर आई सेड दैट क्लियर स्काई. व्हाट इज देयर? Two things are there. Yes, no cloud, clear sky, sun heating is good in amount. सितंबर मंथ तक हमें दिखता है थोड़ा सा क्लाउडी, द टेम्परेचर इज लो. अभी भी जाके सुनोगे तो 32, 27, 26 ऐसा ही टेम्परेचर बताएंगे आपको. Why? We have a cloudy sky, and the cloudy sky reduces the temperature. But when suddenly after the September there is a sudden removal of cloudy sky, the more sun rays started coming, sudden hit, and then wind is descending, air is descending. That causes adiabatic compression. Yes, so October. What is the meaning of October hit? So withdrawal of monsoon has the two character. One, it is an October hit phenomenon due to the descending of air after the coming of subtropical jet stream. समझ में आ गया? You can explain subtropical high pressure belt and the descending adiabatic compression and clear sky. Because of that, more sun hitting us suddenly after September. Yes, but by the end of October, you know that the sun started completely shifting, slanting of the sun rays, and then there is a colder. It started becoming. So November month started becoming colder. So therefore, September and November is colder. Then in between what? Extra heat. October. I said now this withdrawal of monsoon, which is going like this, already it is dragging the wind like this, and by the time, अब हम लोग ये कौन सा month किया था हमने? 15th. So withdrawal of monsoon is from the 15th September to 15th December, and thereafter there is a which monsoon? Yes, tell me. Northeast monsoon. Which monsoon? और ये विड्रॉल हो भी रहा है, साथ साथ में दिस रीजन इज बिकमिंग इन हाई प्रेशर, क्योंकि सन हैज गॉन इनटू द साउथ. So this region become very high pressure. Then it is, I said that southern Asia and all this Asian region become very high pressure. What did it become? High pressure. And then comparatively low pressure in the southern Indian Ocean. Then the wind started moving in the form of northeast trade wind. So that it is a northeast monsoon, and that is, I said that 15 December to 15th March. But actually में December क्या November से ही आ जाता है. And then they started coming and hitting in which region? Southern Andhra. They started hitting in which region? Southern Andhra and Tamil Nadu. And after that it entered into, I said, here also Southern Karnataka. So these regions are getting what? Rainfall. Southern Karnataka, Southern Andhra, that is around 100 centimeter. And here it is, I said that 40 to 50, थोड़ा अंदर जाएंगे, that is reducing. So Southern Karnataka, that you have seen that southwest monsoon when the doing Arabian branch, leeward में भी इसको कितना मिल रहा था? 60-50. And then the Southern Karnataka is receiving by the what? Yes, tell me. Northeast monsoon, तो total rainfall कितना हो गया? 100 around. And that is not good for the cotton. But Northern Karnataka, you know that वहाँ पे 60-50 है, तो Northern Karnataka will produce cotton. और साथ में Northern Karnataka is in a lava plateau. Southern Karnataka is in a granite, जहाँ पे मलनाड मैदान, that you know. So this will support and rainfall. The southern Bangalore is the region where you can have an what? Rainfall in the winter, and then Mysore, Bangalore and all winter as well as in the summer. Good place to live. No use of AC. हाँ? दिल्ली में लोगों का तो AC के बगैर काम ही नहीं चलता. And in the by reaching, I said that Tamil Nadu coast, it is causing 110 centimeter rainfall. So Tamil Nadu is clear. So this is done by northeast monsoon. So we have seen onset monsoon, withdrawal monsoon and northeast monsoon. And one monsoon left, it is pre-shower monsoon, 15th March to 15th May. And we know that it is in a mango shower, cherry blossom, Kal Baisakhi, and then nor'wester. I have said that in the region of Nilgiri Hills, where I said that, यहाँ पे जो mountain range है, Nilgiri Hills, what creates? ITC creates what? Intertropical convergence. It's in a kind of a smaller disturbance. Okay, and there is an also creation of what? And it is in the month of April it is happening. And just above with the Baba Budan Hills, this is in a Nilgiri Hills, and there is in a Baba Budan. In the Nilgiri Hills, ITC or disturbance created, and it is causing and what? Low pressure center has been created is small, and then moisture from the nearby ocean started coming. Understood? Understood? ITC, intertropical convergence, is small, and then it started coming into what is an I said moisture from the nearby Arabian Sea. And Nilgiri Hills में क्या होता है? Due to this rainfall, mango get ripe. Mango get ripe. उस rainfall के बाद mango get ripe and started falling down. Therefore, it is known as mango sour. This rainfall is known as mango ripe and is mango shower. In the Baba Budan Hills, what happens? After this rainfall, such kind of ITC and then disturbance, in this region may rainfall say coffee flower blossom, खिलने लग जाता है. Therefore, it is known as cherry blossom. और साथ में यहाँ पे चेरी भी होता है साथ कॉफी के साथ. So this rainfall helps in what is a flowering of coffee plants, flower coming out, blossom out, and it is known as which rainfall? Cherry blossom. And in the Bengal region, such kind of ITC causes what? Rainfall, and it is known as Kal
Baisakhi, and after that in Assam it is known as Nor'wester. Understood? Kal Baisakhi, Nor'wester. और इस समय इंडिया में लू इधर क्या चलते रहता है? What is happening in the northern India? Loo is going on. So these phenomena are famous phenomena are what is in a pre-shower monsoon. Completely understood? So in the last classes we have seen about that ocean came into existence how many years ago? 3.9 billion years ago, or 3900 million years ago. And at the same time continent also came into existence the same time. And thereafter we came to also know that in the plate tectonic that oldest ocean is always destroying below the continental plate, and new ocean is forming along the divergent boundary. New ocean is forming along the divergent boundary. And perhaps you remember we are going to do the topic like I said that ocean bottom topography. Ocean bottom topography. Which are I said that? Ocean bottom topography. And you have to speak with me. The first I said shelf, slope, rise, abyssal plane. Shelf, slope, rise, and abyssal plane. ABY-SSL. ABYS. Abyss means deep. Abyss means, so abyssal plane is deep sea zone. Abyssal plane is which zone? Deep sea zone. I said, आपको याद हो, yesterday we have taken like I said that these two continents were together. Perhaps you remember. And then convectional current of magma making the plate to what? Diverge. In the plate tectonic I made you to understand, and this plate moved away, and this plate also moved away, and in this gap basaltic magma came, and then I said that solidified. You remember all? And over the long period may if the same thing happened again, this plate moved and again this plate moved. So this section has moved over there, and this section I said that moved here. So ये portion भी, it will be get broken, and then it came over here, and it came over here, and in this gap again new ocean crust has been created. So regularly the magmas are coming out in this region, and और यहाँ पे क्या हो रहा था? Just tell me. Old oceanic crust is what? Subducting. Old oceanic crust is what? So यहाँ पर 1 meter is forming. So this side is 1 meter. It is what? Subducting and destroying. So along the divergent boundary, new crust is forming, and along the convergent boundary, old crust is. और यहाँ पर भी same it is in a destroying like this. Means in the whole world, the amount of what is in a rate of construction is equal to what rate of
destruction. Therefore, we have still 71% ocean and then 29% land mass. Understood? ये picture है. अब now this picture I am going to get elongate. कुछ दिनों में ये portion कैसा हो जाएगा? After a certain period, मतलब day में नहीं, in some millions of years, I said that this region will be like this, and we will be able to get one of the deepest ocean here. It is like this, yeah. Understood? तो सबसे पहले कौन बना था? One portion जो कि यहाँ पे अटैच था. Second time there is this has been formed. Thereafter it has been bifurcated. Then third time this one. Fourth this one. Fifth this one. और अभी जो recent बना है sixth one. Yes, it is clear. So, and here either what is happening in this region? Old oceanic crust is what I said, that subducting. Is it okay? Now this is one continental margin and this is one continental. Which margin will have earthquake volcanic eruption? M or M1 side or M2 side? Where? So can I say that it is an active continental margin? And this is, and I said that passive continental margin. Which are I said that? Active continental margin and understood it. Which are the two margins I said? Active and tell me passive. और over the long period जब ये यहाँ पे था तो यहाँ से some deposition is keep on happening. तो ये लगभग जो अब दूसरा स्ट्रक्चर बनाने जा रहे होंगे तो बॉक्स टाइप बनाया so that you can understand it. So I am going to make another. Shall I remove this? ये same structure I will draw. So this is continent. Which are the landforms are we have? I said that the two we have passive continental margin. In this passive continental margin, continental shelf, continental slope, continental rise, abyssal plane, and in active continental margin continental shelf, यहाँ continental slope, oceanic fringe. Continental shelf in case of passive continental margin wider, or in case of active continental margin it is narrow. Continental slope in case of passive continental margin gentle comparatively, and it is what? Steeper. Okay. Shall I? Shall I remove this? Shall I move ahead? So what we have seen, like first passive continental margin देखने जा रहे हैं, and there is a first we are going to see continental shelf. Shall I remove this now? I said that this is in a continental shelf, this is in a continental slope, this is in a continental rise, and you know that it is a abyssal plane. Similarly on this side also continental shelf, this is continental slope, this is continental rise, and this is a abyssal plane. And here we have a continental shelf, continental slope, and this is oceanic ridge. Understood? First I'll say continental shelf. This is the ocean just near to the coast. This is the ocean, I said that just near to the coast. Just near to the, this is the land part and it is in a coast. Just near to the coast. Its average width, continental shelf average width is 130 kilometer. Average depth is 200 meters. So this depth is only how much? How much depth? Average depth. Somewhere it can be 70, 80, 90, 200, 250, somewhere. Average depth is, I said that. Understood? स्लोप, यहाँ पे स्लोप कैसा होगा, स्लोप कैसे मेजर करते हैं, यू नो दैट, परपेंडिकुलर अपॉन बेस, एंड परपेंडिकुलर डेप्थ कितना है एवरेज 200 मीटर, एंड देन बेस कितना, व्हाट इज द बेस 130 into 1000 meter. We have to take everything in the same unit. So 200 upon slope क्या निकलेगा, yes tell me, 200 upon 130 into 1000, and it will come upon 1 upon 650. Slope is less than 0.5 degree, means slope is less than 1 upon 650 means what? Less than 0.5 degree. Continental shelf. I said continental shelf. Shall I remove this section? ये वाला section. Calculation section. You know that in the continental shelf maximum sunlight comes, earlier I have also discussed, and what is there, maximum sunlight every goes, but the maximum animal lives over there, and then so that they can, whatever the food are forming, because they cannot swim, several animals cannot swim in the deeper part of the ocean. Whale can go, shark can go, but every animals cannot be in the deep sea zone. Understood? So I said that यहाँ पर क्या हो रहा है, इन द कॉन्टिनेंटल शेल्फ में क्या हो रहा है, तो देयर इज एन फाइटोप्लैंक्टन, एंड दिस फाइटोप्लैंक्टन इज एब्जॉर्बिंग कार्बन डाइऑक्साइड, एंड ये एब्जॉर्ब करके एक तो हमारे ओशन की एसिडिक कैरेक्टर को मेंटेन करता है. वाटर एंड कार्बन डाइऑक्साइड क्या होता है, कार्बोनिक एसिड, यस और नॉट, तो ये किसी और चीज में कन्वर्ट कर रहा है, इट इज कन्वर्टिंग इनटू द ऑर्गेनिक बॉडी में. Yes or not? Carbon dioxide and water makes which water, which chemical? Carbonic acid. I said that carbon dioxide is eaten by it, or phytoplanktons are eaten by whom? Zooplankton. And zooplankton, I have said that it is eaten by marine animals. Marine animals exist in this region. And when they will keep on dying and bury below, the sediments brought by the rivers along the continental shelf, they will keep on depositing and burying. So burying क्या है? Burying, there is a decomposition is taking place. No air, there is no aerobic decomposition. So they will remain in the anaerobic. They will remain in the. इसका मतलब हम लोग नाइट्रोजन सल्फर सबके साथ अंदर ही घुस जाएंगे जो एनिमल्स होंगे, मेराइन एनिमल्स. तो इसीलिए हम मुझे पेट्रोलियम में हमें क्या मिलता है, सम काइंड ऑफ नैप्था, नाइट्रोजन रिलेटेड, जिससे हम लोग नाइट्रोजनस फर्टिलाइजर इंडस्ट्री बनता है, जहां पे ऑयल रिफाइनरी होगा. ऑलवेज एवरी ऑयल रिफाइनरी इंडस्ट्री नियर बाय, आई सेड दैट नाइट्रोजनस फर्टिलाइजर इंडस्ट्री. और हु इज गेटिंग नाइट्रोजन फ्रॉम दिस, जैसे कोल से नाइट्रोजन से भी हमारा क्या बनता है, सिंदरी इन द व्हाट इज इन धनबाद रीजन एंड झारखंड कैसे बन रहा है, वहां पर भी देयर इज इन कोल बेस्ड, दैट इज फेमस फॉर कोल. सो देयर इज इन नाइट्रोजनस फर्टिलाइजर इंडस्ट्रीज आर बेस्ड ऑन व्हाट, पेट्रोलियम एंड coal, or one day when it will finish, yes or not, it will finish. तो आने वाले समय में यूरिया का डिमांड का we have to see the some substitute for the urea. I said that, तो ये कार्बन डाइऑक्साइड किस में आ गया, ऑर्गेनिक बॉडी में, in the body of in the form of what, hydrocarbons, and in the form of limestone. It comes in our body, कल भी मैंने बताया था. So we have which deposits, petroleum fuel. And then I said that what is gas, natural gas, and then I said that hydrates. What is the meaning of gas hydrates? I said that when the methane gas under the low temperature is over there, and when it is combined within the ice cube, methane gas has been what is within the ice cube. It is known as what? Gas hydrates. And in the Japan and at several places, these are what is high amount it is an extraction is taking place. Understood? So, and at the same time, their hydrocarbon body will convert into in this form, and then skeleton will convert into, yes, tell me, limestone. और एक चीज और आपको पता है कि यहीं पर क्या बनता है, कोरल्स. कोरल्स इज आल्सो लाइमस्टोन रॉक. Yes or not? So they will also form several crustacean. Their skulls are also what, limestone. So we'll be able to get what is a limestone rock over there and petroleum fuels. So continental shelf is very much important or not? एक दिन यदि ये सबमर्ज हो गया और ऐसे आ गया, प्लेट मूवमेंट हो गया, एंड देन ये क्या हो जाएगा इन द मिडिल पार्ट ऑफ द लैंड, ये कंप्लीटली सबमर्ज हो गया. सपोज राजस्थान में जैसलमेर में जाओगे, व्हाट विल गेट, पेट्रोलियम. इन द फ्यूचर देखते हैं कैसे निकलता है एट सेवरल प्लेसेस इन इंडिया. दिस इज आई सेड दैट व्हाट, कच्छ रीजन. ये कच्छ रीजन वाज ऑलरेडी व्हाट रीजन है, ओशियन पार्ट. और यहाँ पे क्या था, डिपोजिशन डिपोजिशन डिपोजिशन. आज इसीलिए तो कच्छ रीजन रन स्पेशली रन इज व्हाट, saline region. Saline and marshy over the time deposited और यहाँ पे marine animals converted into petroleum fuels. और इसीलिए यहाँ पे Sir Creek is in a problematic area between Pakistan and India, and the other creeks are also. So I said that this is the lower continental shelf just near to the coast. This is very much important as far as the mineral is in concern. As far as I said that mineral is in concern. Understood it? यहाँ पर what we are saying, there is no activity. यहाँ पर तो आपने देखा था कि it keeps on, क्योंकि ये पहले पोर्शन ऐसे था, it keeps on moving away, तो automatically over the long period some deposition of sediment थे हमारे यहाँ धीरे धीरे क्या हो गया. If it is like this, यहाँ पे deposition of sediment धीरे धीरे this way, it is like this. Deposition of sediment ने क्या किया, continental shelf को क्या बोलते हैं, 200 मीटर डेप्थ, और इससे ज्यादा होता तो it is not in a continental shelf. So deposition of sediments over the long period, this region has become wider continental shelf. Yes or not? And yesterday I have discussed with you, यहाँ पे क्या होता है, Quaternary waste sediment, and what is the river deposit sediment. And listen me carefully. This is I said that यहाँ पे suppose करो यहाँ से यहाँ तक continental shelf है. Continental shelf is from here to here. Suppose it is like this, 200 meter depth. And when the convergence is taking place, what happened? 200 meter depth reduced only up to this, only a small area. So continental shelf become narrow. Yes or not? And यहाँ पे क्या बन रहा है, mountain. So anywhere there is on the coastal region mountain range is there, that region will have what? Narrow continental shelf. And continental shelf is the reserve of petroleum fuels, other natural gases, gas hydrates and other. Yes or not? इसका मतलब who is in the benefit? Passive continental margin और active continental margin. तो आपको एक साइड मैंने क्या लिखाया था, narrow continental shelf and passive continental margin has yes wider continental shelf. Understood it? Now is it completely okay, continental shelf? So इसीलिए law of the sea, United Nations Convention law of the sea has been created कि कौन किसको कैसे use करेगा, that is also there. Understood? And then at several places, Caribbean Sea, if you'll go in the Gulf of Mexico, some countries are also demanding its side, and then over the period it created a problem, and some solution has been found on the basis of United Nations Convention. Understood? So clear continental shelf, where will be narrow and where will be wider? Passive पे wider. And the active continental margin, you know that due to the formation it become very narrow. Now I said continental slope. This is I said that what? This is continental slope. What is this? And this is also what I said that continental slope. And then generally, if I talk about generally continental slope has slope is around 5 degree to 15 degree. How much it is? 5 degree to, क्योंकि उसके बाद sudden the slope will come down after the shelf, because we have to go toward the deeper slope, and slope has 5 degree to 15 degree. But where there is an active continental margin, suppose I said that this is in a 15 degree slope. Yes, tell me, 5 degree to 15 degree. But what happened? So continental slope at the active continental margin will be what? Steeper, and at the what I said that passive continental margin it is gentle. Yes or not? 5 degree to 15 degree. Is it clear? So 5 degree to 15 degree continental slope along the passive continental margin, and then I said that slope of continental, it is what I said, 25 to 45 or even 55 degree it becomes along the active continental margin. Understood? So where the continental slope is deeper? At the active. ये आपको क्या दिख रहा है? This is continental shelf. This is continental slope. This is, I said that. Yes, tell me. Rise and thereafter. What is this? Continental shelf. Who is depositing the sediments along the continental shelf? Rivers. And उसी के नीचे क्या हो रहा है? Marine animals keep on burying. Understood it? Continental shelf, continental slope, continental rise, and thereafter abyssal plain. Continental shelf, slope, rise, abyssal plain. और यहाँ पे क्या है? Self, slope and trench. So it is an active continental margin and it is what? और middle part of the ocean में कल मैंने आपको करवा चुका हूँ मैं, yes. It will be a mountain ridge, mid-oceanic ridge, और बीच में क्या होगा? Rift valley. Yes, must be knowing. और ये क्यों uplift हुआ? Why it has been uplifted? Because of the hotness over there. Magma यहीं से diverge हो रहा है. So hotness से this region has been what? Uplifted. Therefore, it is looking like a chain of mountain range. It is known as a mid-oceanic ridge. अब हम लोग आ रहे हैं continental shelf की तरफ. You know that continental shelf has deposition of sediments. Sometimes this deposition of sediments started moving downward. And their speed, if I am talking about, if it started moving downward and there is a large amount of deposition of sediments, million tons of deposited sediment, due to some activity, it started falling down. And that is known as the turbidity current. Turbidity current. And इसकी speed हो जाती है 40 to 80 kilometer. What is the speed? This falling sediments की speed कितनी हो जाती है? 40 to, what is the speed? 40 to 80 kilometer per hour. जैसे कार जाता है ना, आप जा रहे हैं zoom. हाँ? It is moving like this. You can see here, this turbidity current is moving faster. Yeah. Along which continental slope. And where these are deposited? These are deposited along shelf. And they started flowing down. और इनकी इतनी speed होती है कि they used to cut this shelf to slope. They used to cut it. जैसे if you can see that it is coming down from here. But it is to cut it like this big gorge. It is known as submarine canyon. It is known as, I said that. So where the submarine canyon exists? Tell me. Shelf to slope. Submarine canyon. From shelf to. कैसे बना समझ में आया? और ये जब नीचे मूव करता है ना, you know that when it moves like this down and here it is, तो ये वो falling sediments नीचे पानी को thrust देता है and this water started going down. ये water ऊपर जाता है and it converts into tsunami waves. Tsunami करेंगे, one of the factor of tsunami is what? This kind of turbidity current, जिसको बोलते हैं submarine landslide. It is known as submarine. This kind of thing you can be able to see, it is along the Indus, and this kind of things also it is along the what? Submarine canyon and along the Ganges. The Ganga has also made a submarine canyon. They are also depositing the sediment. And also what you can see that, and this deposited sediment is known as a fan, alluvial. This is a kind of what? Alluvial. Understood? Or deep sea में जा रहा है, it is known as what? Abyssal plain. And due to, again I said that, ध्यान से देखें, what is this? Continental shelf. This is slope, and this is, and I said that abyssal plain. लेकिन क्या हो रहा है, the sediment coming from here depositing. कहाँ पे डिपोजिट हो रहा है, tell me? Between slope and abyssal plain. Where it is depositing? This is continental slope. This is, I said that this sediment is depositing between continental slope and abyssal plain. Can you see that this is rising? This slope is rising. This slope is. So continental rise कैसे बना? Tell me. By deposition of sediment between continental slope and, understood? Because what kind of slope it has? Tell me, what kind of slope it has? Very steep slope. And यहाँ पे deposition of sediment, then it becomes what? Rise. Slope has been rising. So इसके बाद आपने क्या देखना है? Just tell me, continental rise. यहाँ पे animals होंगे इस side में. Tell me. Huh? No. Light is not able to available. The food cannot be formed. Under high pressure, animal cannot exist. And where there is some kind of animals like exist, it is known as a through chemosynthesis, not photosynthesis, chemosynthesis. अपनी एनर्जी से ही केमिकल रिएक्शन से, you know that there is a tree light. जैसे आपने कभी देखा होगा जुगनू, they are what is their own energy converting into light to finding that as a so firefly like this. The same way it is in a tree light is some kind of animal exist. Is it okay? And thereafter abyssal plain. Continental rise समझ में आ गया कहाँ पे बन रहा है? It is made by the deposition of sediment between continental slope and abyssal. Is it clear? Continental rise. Thereafter I said, कल आप लोगों को मैंने बताया था हॉट स्पॉट. Within this hot spot, some of the volcanic mountain will form. बनेगा? Yes or not? Clear? If I said that now we are going to see abyssal plain. Which plain? Abyssal plain पे क्या क्या होगा? Mid oceanic ridge, rift valley. Yes. और ये प्लेन का मतलब ये कैसा होगा स्लोप? फ्लैट, कंप्लीटली व्हाट? इट इज इन अ फ्लैट. देयर आफ्टर रिफ्ट वैली. और क्या मिलेगा? सम माउंटेन्स. इसको बोलेंगे सी माउंट. इट इज नोन एज दैट सेड दैट सी माउंट मीन्स हाइट शुड बी मोर देन 1000 meter. Below 1000 meter it is not known as sea mount. Remember that. Sea mount means what? From the sea floor its height should be more than, and if it is moving up and its top has been cut down by the waves, so it is looking like flat top, and that is known as what? Flat top is known as height is more than 1000 meter. Now it is known as what? Geode. It is known as geode. Understood? So what are the things that you can see in the mid oceanic ridges? Yes sir. ये क्या दिख रहा है आपको? What is this? Sea mount. This is an island. If it comes, volcanic island we have seen yesterday. And if this island has been cut down, it will become a flat top. It becomes what? Yes. So corals कहाँ पे बनते हैं? Along this island and along these geodes. In the tropical region में where the corals grows? In the Pacific Ocean. In the Pacific Ocean, around 10,000 geodes are there. How many? It is less figure. 10,000 to 15,000. So many island. और ये island कैसे बना? Through the hotspots. Several hotspots there are. So समझ में आ चुका है? And now this is what? Another section यहाँ से magma जा रहा है और valley. Sometimes यहाँ से magma बहुत निकलता है, and then what happens? It comes above it, and it becomes an island. It becomes along the mid-oceanic ridge, Iceland has been formed like this. Iceland. और कुछ अंदर छुपे भी होंगे. It is not able to come out. Understood? So Iceland has been formed like this along the mid-oceanic ridge. Another one I said that. So which are we have seen? Tell me first. हम लोगों ने क्या क्या देखा? Yes, tell me. Continental shelf, continental slope, continental rise, and then abyssal plain. And they are found along what? Passive continental margin. And along the active continental margin, narrow continental shelf, steeper continental slope, and then suddenly there is an oceanic range. Understood? Clear? I said that continental shelf is the source of what I said that? Mineral fuels. You know that limestone, several things and there. And what is the average depth? 200 meter or 100 fathom. 1 fathom means 2 meter. And then what is the width? General width, I said that. 130 kilometer. And यहाँ पे ही, if you see in India, western coast of India has wider continental shelf. So this region has a good chance of what is having an what? Mineral deposits. Yes. And eastern coast has what? Narrow. So thereafter I talked about continental shelf. It is wider along the what? Passive, and narrow along the what? Active. Then I talked about what is slope. Continental slope. Continental slope is, I said that it is in a gentle 5 degree to 15 degree long. What is in a passive, but is steeper 25 degree, 45 degree, or even 55 degree. It is what? Along the active. Because of this. And then we have seen that I said that between continental shelf and continental slope, submarine landslides take place. And due to this, there is a formation of submarine canyon. Understood? Thereafter, we have seen there is a continental rise formation. कैसे बना? The sediments which is coming from shelf toward the slope and it is depositing between continental slope and abyssal plain. It is known as what? Continental rise. And thereafter abyssal plain. And abyssal plain has what? Mid-oceanic ridge, rift valley, and then we have seen sea mount, island, geodes. Understood? And then दो चीजें हमें देखना है. It is a white smoker and black smoker. What I said that? What is the temperature over there? 2 degrees Celsius. At the bottom of the sea, what is the temperature around? 2 degrees Celsius. And what is the boiling point of water? 100 degrees Celsius in our atmosphere. Yes or not? At the sea level. लेकिन जब mountain पे जाओगे तो there is something different. Pressure decrease होते जाएगा as will go above. So boiling point will keep on changing. जैसे जैसे pressure change होगा. तो यहाँ पर pressure बहुत ज़्यादा है या कम है? तो boiling point will be. समझ में आ रहा? I said that some water used to enter inside it. When the water used to enter inside it, और यहाँ पर क्या है? I said that some amount of what I said that it goes over there and it get heated by 350 degrees Celsius. It get heated by, I said that, mid-oceanic ridge, and through the rift valley and some of the cracks water enter और heat होकर इसका temperature कितना हो गया? Tell me. 350 degrees Celsius. तो hot water को क्या बोलेंगे? Hydrothermal. Yes or not? And in this one, content of iron is more and content of, I said that, sulfur is more. Iron and sulfur. Iron and sulfur gives black color to this. And when this water will come out, क्योंकि बहुत pressure है, and when it comes out in the black, in the form of bubbles. And its color is black because what is there in the water? Iron and sulfur. It is known as black smoke. इसका फायदा क्या होगा? बगल में some micro organism exist. इतने depth पे organism cannot exist. They need heat. Who is giving the heat? Volcanoes, and then it is coming out. Some minerals coming out. They started living. So one ecosystem started growing along hydrothermal vents. And which hydrothermal vent? And what is there in this? Tell me. Iron and sulfur. And if in this there is a content of silica and barium, then what is the color? So it will be what? White color, and it is known as what? White smoke. Understood? Now we have seen, like I said, that, and then what is the average height of the landmass on the earth? Mount Everest I did not ask. What is the average height of the landmass? Around, सबको जोड़ दोगे and area of the landmass से divide करोगे, it is coming around 800 meter. What is the average height? 800 meter. And what is the average depth of the ocean? 3790. What I said, that 3790 meter. 3700, it means around 4 kilometer. 37, understood? I have said height, it is a land mass. Then I said that continental shelf. Then I said that slope, rise, abyssal. And if I am showing all this in a graph, depth of the ocean bottom topography, depth of ocean bottom topography, and height of the land mass, average height of the land mass, it is known as a hypsographic graph or curve. Understood? So it is known as a hypsographic graph or curve. समझ में आ गया? Is it okay? So I have finished with which? Ocean bottom topography. Is it okay? So you can easily understand it. Okay, there. अब ये समझ में आ रहा राइज कैसे बना? ड्यू टू डिपोजिशन ऑफ sediments. Now we are coming towards ocean current. Which topic? Start with the topic. I said ocean circulation. Under the ocean circulation, we'll see in ocean circulation, especially we'll see surface current, and we will see also in the ocean circulation lead to the development of, I said that El Nino, thereafter we'll see La Nina, and these are considered as, I said, ENSO, El Nino Southern Oscillation. It is known as El Nino Southern Oscillation. Then we'll see MJO, Madden-Julian Oscillation. El Nino Southern Oscillation.
So these are the topics that we have to cover today. And in the surface current, we have to understand first factors for the formation of ocean current, and after understanding the factors, we'll understand Atlantic ocean current. In this one there is a North Atlantic gyre and there is a South Atlantic gyre. Thereafter we have Pacific Ocean current. In the same way we have to see Pacific, North Pacific gyre, and then we'll see South Pacific gyre. And in Indian Ocean we'll see South Indian gyre, and another I said that we'll see southwest monsoon current, and we'll see northeast monsoon current. A part of it we'll see, like I said, that west wind drift, and we'll see east wind drift. Okay. Okay. So these are the things that we have to cover. First I say the factors. Before that, we have to see that ocean current on the basis of speed. Ocean current on the basis of speed. These are, I said that, stream, current and drift. So ocean current on the basis of speed, when the speed is less than 1 kilometer per hour, it is known as drift, and this drift generally moves in large open sea or ocean. They are moving in the large open sea or ocean. Generally, I say. Current, its speed can be, I said that 2 to, I said that better to say 3 to 6, or better to say 7 kilometer per hour speed, and it generally moves along coast and equator. Generally moves along coast or equator. Generally moves along coast and equator. And the stream, it is made by combination of ocean current. It is made by combination of ocean current. It is made by breaking of, it is made by breaking of geostrophic flow under the influence of Ekman spiral and Ekman pumping. Generally it is, specifically it is on the eastern coast of continent in the northern hemisphere. In the northern, specifically it is eastern coast of continent in the northern hemisphere. And generally speed is 8 to 9 kilometers per hour. So which one is the fastest? Yes, stream is the fastest. So have you heard about black stream? What is black stream? Huh? Have you heard about black stream? No. Gulf stream? Yeah. Black stream is Kuroshio current. Black stream is Kuroshio current. Understood? And where it is along the eastern coast of the continent. And Gulf stream is also along the eastern coast of the continent. Understood? These two streams are on the eastern coast of the continent. Try to understand each and every basics So this is the difference between, I said that, stream, current, and I said that drift. Next one, I said that ocean current on the basis of temperature. Ocean current, shall I move this? हटा दो. Ocean current on the basis of temperature. These are what is in a warm current, and here it is cold current. And warm current simply moving from low latitude to high latitude. Warm current is moving from low latitude to high latitude, and cold currents are moving from high latitude to low latitude. It is moving from, clear? So if I say that the ocean currents we have to do, I said that surface ocean current. We should not do, I said that deep currents. There is a deep currents are also there, but the deep current has not to be studied neither in the geography optional nor in the GS. Clear? So now I said that there is some drift, current, stream is there. Now we have to see that what are the factors causing the formation of ocean current. What are the factors causing the formation of, shall I move? Factors causing the formation of ocean current. And factors causing formation of ocean current. I said so the first it is a natural factor or general factor, and another we have to see, like I said, modifying factor. Okay. What is warm current? Warm ocean current moving from low latitude to the high latitude. I said that if you see something like this, and when the ocean current, these are the low latitudes moving from this region, so it is, I said that moving from, suppose I 10 degree north to 45 degree north, it is moving like this, so it is in a warm ocean current. And when the current is moving from, I said that 45 to 10, it will be known as what? Cold ocean current. But even then, if current is moving from 45 to 70 degree, it will be again what is in a warm ocean current. From low latitude to the 70 degrees high latitude and 45 degrees low latitude. And then simple funda is there that the temperature of the ocean current here, it will be high, और ये इस region में जाएगा तो this region is colder, that the people will find this current is coming warmer. And then if the ocean current is going from this region, so if it is I said that ocean current in this region is suppose 26 degrees Celsius,
or in this region it is going 14 degrees Celsius, and in this region suppose I said that 0 degrees Celsius. So the temperature when the ocean water of 26 degree will go into this region, तो यहाँ पे temperature लोग बोलेंगे ठंडा, ये गर्म आ रहा, and 14 वाला इस region में जाएगा तो they will say, this region will say it is what? Warm. So any from the low latitude to the high latitude it will be always, and I said that. So from any 30 to 60, 60 to 80, anywhere it is moving, and any current if it is moving from high latitude to the what? Low latitude, it will be downward movement anywhere. Downward का मतलब high latitude to the low latitude, it will be always cold ocean current. Like I said that there is a Labrador current, there is an East Greenland current, there is, I said that, Canary current. So these are supposed to be the what? Cold ocean current. Understood it? Now that what are the natural factor or general factor? First it is wind and its friction. Second I said that density. Can you remember in your mind which are I said that? Wind and its friction, and the second I said density. First factor is, so which are the wind? And especially the wind, which especially the wind I said that is winds are primary winds. Northeast trade wind, southeast trade wind, Westerlies and Polar Easterlies. Understood? These are the wind which is helping in the formation, they are putting the friction and then formation of the ocean current. Another it is I said that density is there. After density we'll have to see P for atmospheric pressure, another P for precipitation. P for precipitation. So which are the four factors? Just tell me. Wind and its friction, D for density, रटा हुआ होना चाहिए. Wind and its friction, D for density, P for atmospheric pressure, P for precipitation. Understood? Thereafter I said Coriolis force. Which one I said that? Coriolis force. Understood? Which force I said that? Coriolis force, and in that one we'll understand Ekman spiral, and we'll also understand why streams are forming. Coriolis force, and after that we'll see melting of glacier. Melting of glacier. So which are the six factors till now we have seen? Which are the six factors? Wind and its friction, D for density, P for atmospheric pressure, P for precipitation, Coriolis force, melting of glacier. And melting of glacier का कुछ ही example है that is causing, and then you have seen East Greenland current. The famous, if we'll talk about East Greenland current, is a famous example of melting of glacier. Clear? Thereafter the next factor it is I said that temperature difference. Temperature difference. Modifying factor, if I talk about modifying factors. In the modifying factors I said that shape of the coast. And you know that modifying factors I said shape of the coast, and most of the ocean current in the world it is moving along the coast. I said that whatever the coast they will try to follow along the coast, shape of the coast. And I said that ocean bottom topography. Ocean bottom topography. In the middle of the ocean, what you see? आप लोग क्या देखते हैं? In the middle of the ocean, there is a mid-oceanic ridge. Yes. And also you will see some mounts, sea mounts, some plateaus are there, jo mid-oceanic ridge per plateau formation. And all, they used to, if the ocean current comes, they used to give their direction into the another way. So I said that helping in the changing the direction, then ocean bottom topography. Which one I said that? Ocean bottom topography. इरोजन तो करेंगे तभी तो जियोट है. Geot is existing because of what? The sea water, जहाँ तक sea surface is moving till the depth of 100 meter. Sea surface moves till the depth of 100 meter. Sea surface does not move below 100 meter. And by the reaching 100 meter, it becomes clear. So, कहाँ पे थे next? अभी केवल मैं समझा रहा हूँ, बाद में आपको डिस्कस करूँगा. I said ocean bottom topography. Second part I said that. Next part क्या था? Yes, seasonal change. Third one it is I said that factor is a seasonal change. And then seasonal change is only in the India case, and in the I said that the southwest monsoon current which is forming, and then northeast monsoon current which is forming, these are due to seasonal change. Clear? So seasonal change, this is a modifying factor, only it is effective in, I said that, India, and especially in the India, nearby India, you can say northern Indian Ocean, which is in the form of Arabian Sea and Bay of Bengal. Okay? So which are the modifying factors? I said the shape of the coast. Yes, ocean bottom topography. Another is seasonal change. Understood it? Thereafter we have been able to see what are the natural factor or general factors. I said wind and its friction, याद होना चाहिए. Wind and friction, D for density. Wind and friction, D for density. P for atmospheric pressure, P for precipitation. And then I said Coriolis force, melting of glacier. And the last one is temperature difference. Is it okay? So we are going to see the formation of ocean currents. You know that Coriolis force act upon which thing? Coriolis force किस पे काम करता है? It act on anything which is moving. And when the ocean current is moving, then there will be a Coriolis force will must act on it. Yes. So Coriolis force को कई जगह आप use करेंगे. I said that this is an equator, and I said listen me, northeast trade wind. Which wind is this? And you know that the northeast trade wind, if it is moving, so it is not moving like this. आपको ऐसे थोड़ा सा move करता है. So when the northeast trade wind is moving like this, so it will put the friction onto the sea surface, and when the sea surface is getting friction, so with respect to wind, ocean current will also deflect towards right. So when the wind it is moving, I said that there is an ocean current, it is moving like this. Ocean, the northeast trade wind, and then there is a southeast trade wind. So what will happen? Ocean current will deflect towards right, and the southern hemisphere deflect towards left. So it will become north equatorial current and south equatorial current. In the Pacific Ocean also north equatorial current, and then we'll see south equatorial current. So wind and its friction, the wind and its friction, which current has been developed? North equatorial current and south equatorial current. Thereafter, suppose westerlies are moving from here. Westerlies are moving from here. So they will keep on, if the wind it is when the ocean current is over there, and if it is moving, I said that then when it is moving, then there will be always, और यहाँ पे भी ocean current, When it is moving here, so he will try to what is going to deflect towards right. It will try to deflect it right. And due to right, यहाँ पर एक आपको क्या बन जाता है? Sargasso Sea का formation आप जानते हैं. That becomes what region of what? North Atlantic garbage. And some of the water is able to move further. So I said that under the influence of westerlies, there is this one is forming under the influence of westerlies. Further, this one it keeps on water deflecting. This will keep on deflecting like this, and also it coming to the subpolar low pressure belt. कहाँ पे आ जाता है? Subpolar low pressure belt. So it is in a westerlies. Similarly, I said that polar easterlies. Which one I said that? Sorry. Polar easterlies. When the polar easterlies are moving, then they will deflect the wind, the sea surface to be the eastward, and there will be a formation of which east wind drift circulating around Antarctica. एक west wind drift भी होता है, that we'll see later. East wind drift. So we have been able to see that wind and its friction determine the formation of what I said, that ocean current. Which are the ocean current it is determined? First it is a north equatorial current and south equatorial current in the ocean. Another it is determining the ocean current moving, touching to the eastern coast of the continent, where it is touching to the eastern coast of the continent and drag it towards subpolar low pressure zone. Drag it towards various, tell me, subpolar low pressure zone. Thereafter, again wind and its friction, the westerlies we have seen, wind and its friction again play an important role in the form of polar easterlies to what it is helping in the formation of which ocean current? East wind drift. So write down wind and its friction. Ocean surface under the influence of moving wind, under the influence of moving wind, feel thrust, pressure and friction, feel thrust, pressure and friction, and movement of sea surface starts in the rightward direction with respect to wind, in northern hemisphere, and leftward direction with respect to wind in southern hemisphere. In which hemisphere? Southern. Okay. Change the para. Under the influence of northeast trade wind, Coriolis force and friction in northern hemisphere help in the formation of north equatorial current and in southern hemisphere under the thrust, pressure and friction, under the thrust, pressure and friction of southeast trade wind, sea surface moves leftward, sea surface moves leftward and led to the formation of South Equatorial Current. Led to the formation of South Equatorial Current. किस चीज का फॉर्मेशन हो गया? साउथ इक्वेटोरियल करंट. सच ओशन करेंट्स are in Atlantic Ocean and in Pacific Ocean. But in Indian Ocean, due to presence of large land mass in northern Indian Ocean, there is only development of South Equatorial Current. Only development of South Equatorial Current. Change the para. Under the influence of Westerlies, there is a formation of wind, there is a formation of ocean current like Gulf Stream and Kuroshio current, Gulf Stream and Kuroshio current along the east coast of North America and Asia respectively. Further, this ocean current under the influence of Coriolis force also help in formation of geostrophic flow near eastern coast, geostrophic flow near eastern coast of North America and Asia. North America and Asia. Understood? This is in a kind of geostrophic flow takes place near to the, what is, and I said that nearby, you can say that the Gulf Stream current that you have seen and the nearby Kuroshio current in the Pacific. That is, and I said that a geostrophic flow is forming near to the eastern coast. Further, this westerlies help in movement of ocean current further eastward towards the subpolar low pressure zone, towards the subpolar low pressure zone. Change the para. Especially polar easterlies in southern hemisphere, especially polar easterlies in southern hemisphere surrounding Antarctic through friction help in the formation of east wind drift. East wind drift. East wind drift. So we have seen in the different regions under the wind and its friction. Second, if I say that who contributes, what are the things which are making ocean to be saline? Which are the ions which are making the ocean to be saline? Yes? Sodium ions. Yes? Which are the salt? वही मुझे बताओ. Which are the salts are there in the ocean? Huh? Huh? Only this one. इसके साथ क्या जुड़ा रहता है? कुछ तो जुड़ा रहता होगा. हाँ? और कुछ? Sulfates. Who gives chloride ions and sulfate ions, carbonate ions? River gives chloride ions and carbonate ions. River gives chloride ions and carbonate ions, and volcanic eruption gives sulfate ions. Volcanic eruption gives sulfate ions. Understood? So I said that there is some salt is there, and how do this salinity is coming? Suppose I said that suppose it is in a container, and in the container suppose I said there is a 70 grams salt in 2 kg water. It means there is an, I said, 35 gram in 1 kg. 35 gram in 1 kg means 35 parts per thousand. 35 parts. And I said that the answer. And another water is also there. There is an also 70 gram. I said that there is a 70 gram in 2 kg. What is the meaning of it? 70, it means 70 on 2, it will give 30 parts per thousand. Means in 1 kg there is a 35 gram salt is there. In this region, this is the region of dry zone, means rainfall is not taking place, and this is a zone of, I said that rainfall is taking place, and due to the, and when the rainfall doesn't have salt, rainfall में salt नहीं होता, it is in a completely distilled water. It is what? Suppose I said that यहाँ पे rainfall हुआ, just take imagine करें, and then rainfall has been taken place, and there is a point. I said that 1 kg water has been, sorry, यहाँ पे rainfall हुआ and 1 kg water has been added, and यहाँ से I said that 1 kg water evaporated. क्योंकि यहाँ rainfall हो नहीं रहा है, there is no rainfall, so only evaporation is there. So what will happen in this dry zone? Rainfall is not there. So when the rainfall is not there, so after that rainfall, जब water कितना हो गया? Now water become 1 kg. The 70 upon 1 kg, it means salt become how much? In 1 kg there is a 70 gram. So salinity of the ocean has been increased. और यहाँ पे 1 kg add होने से what happened? 70 upon salt उतना ही रहा, but the water become 3 kg, and you can be able to see it will become how much? Around 26 gram in 1 kg of water. The salinity has been reduced. The reason having, I said that rainfall the region having rainfall, that region will have what is a less salinity, and the region having no rainfall, that region will have what? More salinity. And what you are finding here, so this region become what? In this region salt becomes 70 gram. और पहले इसी बगल के रीजन में था नियर बाई व्हाट इज देयर in 1 kg. This is in a 70 grams salinity, 70 parts per thousand. Here it is in a 35 parts per thousand, and here it is 35 parts per thousand. The one reason is this. Another reason is I said that यहाँ पे rainfall हुआ, and due to this यहाँ पर 3 kg water जैसे हो गया था, and that become 27 parts per thousand, and here it is nearby region is 35 parts per thousand, 35 parts per thousand. So इसमें आप क्या देख रहे हैं? In this case, there what salinity has decreased, and when the salinity has decreased, to compare to this, इसकी density decrease हो गया, and the density decrease means level will what? Level of water will be high. Level of water will be high, and इसका क्या होगा? In comparison to this one, their density has increased. तो इसका लेवल ऑफ वाटर विल गो व्हाट? डाउन. सो ये पानी नीचे जाएगा, द डेंसर वाटर विल सबसाइड डाउन एंड लेस डेंसर वाटर विल मूव अप. अंडरस्टूड? इसका मतलब क्या हो गया? इन द मीनिंग ऑफ दिस, द डेंसर वाटर हैज गॉन डाउन एंड लेस डेंसर वाटर कम डाउन. द स्लोप ग्रेडियंट डेवलप्ड. एंड वेयर द रेनफॉल यूज्ड टू टेक प्लेस? रेनफॉल यूज्ड टू टेक प्लेस इन विच रीजन? In equatorial region every day, that we understand. So therefore the density in this salinity will be less, and the water level has got up, and this is a subtropical high pressure belt. In the subtropical high pressure belt, you know that the rainfall is very less, dry kind of it, and therefore due to evaporation, density of the oceanic water has increased. So here it is in a less, then we can be able to see the pressure, due to the more density, water has gone down, and yeah, less density, water has gone up. So what happened then? Due to, तो यहाँ पर क्या दिख रहा है? High pressure, and this is a low pressure zone. It is in a subtropical high pressure. It is in a equatorial low pressure. So in the equatorial low pressure, slope is high. In subtropical high pressure, slope is down. Understood? Understood? Is it okay? So what happened? Against the pressure gradient, slope gradient has been developed. Yes or no? Pressure gradient किधर से किधर है? High pressure to low pressure. यहाँ पे low pressure, वहाँ पे rainfall. So यहाँ पे slope ऊपर उड़ गया. So there is a pressure gradient is from this side, but the slope gradient is this side. Water level is of this side equator. So therefore, water started moving from up level, less saline region to the what? High saline. It means more dense, less denser region to what? More denser region. So it is this movement is known as what? Moving against the pressure gradient along the slope gradient. Understood it? Is it okay? So it is in a moving according to the what is the density differences. Similarly, now I said that in this region subpolar low pressure. What is happening? Temperate cyclone rainfall. Subpolar low pressure में which rainfall is taking place? So again there will be what? Density will be less, salinity will be less. So which are the two regions having rainfall? More rainfall. Equatorial low pressure and subpolar low pressure. And due to the rainfall in this region, density will be what? Less. Getting my point? So they will lead to the formation of one ocean current. Yes or not? तो पहला फर्स्ट हम लोग देखेंगे, one we are saying that it is moving from equatorial low pressure belt to subtropical high pressure belt. After that, this ocean current has got the momentum. Yes or no? And when it is able to reach over there, they under the influence of Coriolis force, they started moving. They have got the momentum to move here, and after that they have got the moving from equatorial low pressure belt to subtropical high pressure belt, and after that this is started moving towards which one? Yes, tell me. Under the influence of Westerlies. So Westerlies started dragging it. Now after coming here, what happened? Yes, tell me. What is happening? Subpolar low pressure zone. And subpolar low pressure zone mein what is happening? Tell me. In subpolar low pressure zone mein rainfall. एंड रेनफॉल से क्या हो गया, डेंसिटी डिक्रीज. सो यहां पर भी लेवल ऑफ वाटर इज हाई. इन दिस रीजन लेवल ऑफ वाटर विल बी हाई. इज इट क्लियर? नाउ कमिंग ऑन टू द वन, प्रेशर की भी बात साथ साथ में हम लोग करेंगे, थोड़ा सा अंडरस्टैंडिंग होनी चाहिए. As you have seen that subtropical high pressure belt जहां पे होता है, the wind used to descend down. When the wind used to descend down earlier, इसको बोला जाता है subtropical high pressure belt is also known as horse latitude. It is also known as, because in this zone earlier what we have seen, the traders used to carry the horses. And when they come into this region, due to the sinking of air, क्योंकि subtropical high pressure belt में क्या होता है, wind used to descend, air used to descend, and therefore ships started what, sinking. To reduce the weight, they used to throw their horses. So similarly, subtropical high pressure zone में क्या होगा, sea level will be again down. What are the two regions subtropical high pressure belt will be sea level down? Yes, descending air of subtropical high pressure. Understood? Now, polar high pressure air will be down or not? Sea surface will be down or not? In the polar high pressure, sea level is also what? Down. Pressure, the wind is descending. Now, next point I am coming. In the Arctic region, I said that what is the salt and what is the freezing point? Tell me, what is the freezing point? Yes? Yes? 0 degree Celsius. क्या? हाँ? हाँ, तो कितना बता रहे थे? कितना होगा? हाँ? 0 degree Celsius. It is happening at 1.872 degrees Celsius. When there is a salt is there, then I said that there is a what? They started what? Freezing little early. But what happened? वो छोड़ो. I said what is the salt? NaCl. What is the water? H2O. And what is there in the H2O? Hydrogen bond is there. Yes or not? Hydrogen bond is there. Covalent bond you can be able to see. लेकिन जैसे ही water started, what it is now? You know that temperature started decreasing till 4 degrees Celsius. Till 4 degrees Celsius, what happened? If the water volume is like this, तो water की volume क्या हो जाएगी? If the original volume, then it will keep on what? Reducing its volume. Colder water used to what? Contract. Colder water used to, anything colder it is contract. But after that there is a what? A hydrogen bond started forming. And all, and they, when there is a hydrogen covalent bond started forming, they started what? Stretching themselves. What they started? What they started? Stretching themselves in the form of crystal. And उसमें बीच में क्या है? NaCl, and it is an ionic bond. So along with this ionic bond is not able to make bond, then they started coming out. जितने भी salts होते हैं, they started what? Released during the formation of ice. And now original जो है, original volume आपका क्या था? This is the original. And after that till 4 degrees Celsius इसकी volume ये हो गई थी. But after 4 degrees Celsius they started increasing its volume. Ice की volume जो original से 9% ज़्यादा होता है. And they used to release the what? Salt. Means ice doesn't have what I said, that salt. They cannot. So in the Arctic region, what happened? They started during the ice formation. They started releasing salt, and when the salt goes, they started carrying the top water also downward. आप किसी चीज को पानी में आप डाल दिए, बहुत सारे लाखों करोड़ों, that millions of particles, when it started going down, they will also take the water down. When they will take the water down, what will happen? Then there is an upper level पे water level has been reduced, and उसको fill करने के लिए when the water level is going down in this region, then the water will come to fill up this region. Yes or not? So what are the two reasons the sea level is going down in the Arctic region? Just tell me, what are the two reasons? One, it is in a polar high pressure belts, therefore sea level is down. Another reason is I said that freezing. During the freezing, I said that they used to release salt, and when they are releasing the salt, the level is going down. These are the two reasons. Therefore, when the ocean currents, ध्यान से देखेंगे, therefore the ocean currents when come into the subpolar low pressure, the subpolar low pressure itself, it is in a low pressure, and at the same time rainfall की वजह से क्या हो गया, density reduced, the level of water is high. Level of water is high after the ocean current coming over there. लेकिन यहाँ पर level of water is low. What is the two reason? One, it is I said that polar high pressure belt which is descending, and another I said that freezing, releasing the what? Salt. So one, when the ocean current here, but at the same time when the ocean current came in this region, they found that there is an also subtropical high pressure belt, water is down. They found two regions as what? Water level down, one this side, one this side. Therefore यहाँ से ocean current developed, one here it is and one here it is. समझ में आ गया? Yes, this region is uplifted. Subpolar low pressure is uplifted by their what is in a temperate cyclonic rainfall. Understood it? And therefore, if it is uplifted and comparatively polar high pressure due to the two reasons, descending of air and releasing of salt during freezing, it is a what? Level is down. Another point if I am discussing, another point, subtropical high pressure belt is already due to two reasons. What are the two reasons? Evaporation, no rainfall, and another I said that subtropical high pressure. Evaporation से क्या हो गया? Salinity has been increased. समझ में आ गया? How do the North Atlantic gyre has been formed? How do the North Atlantic gyre? Then again it will become the northeast trade when it will complete the ocean. North Atlantic gyre, similarly South Atlantic gyre. Just tell me why subtropical high pressure is low. If I say 25 to 35 degree north latitude, south latitude, anyone, why their level of water is low? Evaporation से क्या हो रहा है? Density of the salt is increasing, therefore it is going downward. Another factor, subtropical high pressure belt. And what are the two causes for I said that polar high pressure to be surface to be down? Polar high pressure. समझ में आ गया? Why do the subpolar low pressure belt is, I said that its level is up? Because of what? Temperate cyclone. The rainfall is happening 150 to 200 centimeter, and this rainfall contributes reducing the salinity, and the level is found to be comparatively up in comparison to the surrounding. Understood it? So the second factor हमें क्या देखना है? Yes, what is the second factor we have to discuss? Density, and density based on salinity. Yes or not? And also, so write down the density. Density in the ocean is directly proportional to, density in the ocean is directly proportional to salinity. Directly proportional to, higher the salinity, more the density. यही है ना इसका मतलब? Density in the ocean is directly proportional to salinity. Yes. And salinity किस पे डिपेंड करता है? Yes, tell me. Salinity is directly proportional to या indirectly proportional to rainfall? Yes. Yes. Inverse relation is there. And सैलिनिटी किस पे डिपेंड करता है? सैलिनिटी इज इनडायरेक्टली प्रोपोर्शनल टू रेनफॉल. In equatorial low pressure belt, rainfall reduces salinity of the ocean around 33 to 34 parts per thousand. 34 better to write 34 parts per thousand. 33 to 34 parts per thousand. How much the salinity? 33 to 34 parts per thousand. Understood? Why? Everyday rainfall. And what is the total rainfall? I said that 200 to 400 centimeter rainfall. In comparison to equatorial low pressure belt, subtropical high pressure belt has very less rainfall or dry zone, therefore subtropical high pressure zone through continuous evaporation salinity increases. It means in subtropical zone, density of sea water become on an average 36.5 parts per thousand. So subtropical high pressure belt and equatorial low pressure belt. What is happening? यहाँ पे कितना हो गया? Around 33 to 34, better to say 34 parts per thousand, and यहाँ पे how much it is? 36.5 parts per thousand. Okay. So what will happen? This level of water is more. Density, if the density is less, then its level of water is more, and here density is what more than the level of water down. Understood? So the ocean current will move from equatorial low pressure belt to subtropical high pressure belt zone. Understood it? So write down. Denser water, sorry, I said that from low denser water to high denser water, a slope gradient develop. From low denser water to high denser water, a slope gradient develop against the pressure gradient, Therefore, ocean current movement start from equatorial low pressure belt to subtropical high pressure belt. In both the hemisphere. Understood? In both the hemisphere. Is it clear? So in this reason, it is playing in a very much important role for what is a density difference. Which I said that, which difference I said? Density difference. And यहाँ तक wind आते आते क्या हो गया? It has got the momentum. और momentum को आप easily नहीं रोक सकते. So density difference has played a very important role to start the ocean current. Density has played a very important role to start the ocean current. ये समझ में आ रहा है? So who is very much important? हमें किसके बारे में बात किया? Density that has started given the momentum to ocean current development. Next one I said that P for atmospheric pressure, another I said that P for precipitation, atmospheric pressure. What are the atmospheric pressures? Belts, equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt and polar high pressure. कहाँ पे, किस जगह पे level of water will see up? In the equatorial low pressure belt and subpolar low pressure belt will have what? Level of water will be up in comparison to subtropical high pressure belt and polar high pressure belt. Understood? So write down. In equatorial low pressure belt and subpolar low pressure belt will have comparatively level of water up in comparison to subtropical high pressure belt and polar high pressure belt. Clear? It means ocean currents are moving against the pressure gradient, against the pressure gradient. I said. So therefore we can be able to see subtropical high pressure से यहाँ पे the ocean current has been dragged. आपने देखा कि it is in westerlies are dragging it. अब ये wind कहाँ पे आ चुका है? Tell me. This wind has this ocean current has into the subpolar low pressure zone. And after that there is a polar high pressure. Polar high pressure has the what is in a wind? It is in a level is down and here it is. Therefore from the subpolar यहाँ पे क्या देखेंगे? From the subpolar low pressure, one ocean current developed towards polar high pressure and one ocean current developed towards subtropical high pressure belt. And similarly, यहाँ से तो equatorial low pressure belt से we have seen there is an also movement is there from the low pressure belt to the high pressure. Again the pressure gradient, slope gradient is there. And again, यहाँ से if after getting the momentum, यहाँ पे who is effective? Westerlies. यहाँ पे who is effective? Density and pressure gradient. Yes or no? जो अभी पिछले में बताया. And after that, Westerlies has made it to move like this. And then यहाँ पर आने के बाद again मुझे and then again Westerlies are making it to move. And thereafter, if we can be able to come over here, so this is in a subpolar low pressure. The level of water is up, or comparatively polar high pressure is what? This is polar high pressure. So यहाँ से one ocean current will move toward this, another ocean current will move toward this. Because it is in a polar high pressure belt, it will be level of water down and subtropical high pressure level of water down. So again the pressure gradient, there is a development of ocean current. तो हम लोग क्या बोलेंगे? From the subpolar low pressure belt, ocean current has been bifurcated. कैसे bifurcate? ध्यान से पहले सुने. One it is in a northeastward and one it is in a southeastward. One it is in a northeastward. I said that southeastward and one it is what? Northeastward. Understood? Clear? One it is moving toward the polar high pressure zone and one it is moving toward the subtropical high pressure zone. Understood? Who creates? Pressure belts. और भी चीजें मैंने बताई थी कि wind is descending and then density, evaporation and all. So write down. from the subpolar low pressure belt सब फॉर्म नहीं लिखेंगे around subpolar low pressure belt subtropical high pressure belt and polar high pressure belt exist around subpolar low pressure belt zone subtropical high pressure and which I said that polar high pressure zone exists. Therefore, in northern hemisphere, one ocean current develops northeastward as a Norwegian current towards polar high pressure belt. So here it is, which one is developing? From this subpolar low pressure, Norwegian current, and from subpolar low pressure to subtropical high pressure, Canary current developed. Which current? From subpolar low pressure belt to subtropical high pressure belt in southeastward Canary current, cold Canary current develop. क्लियर? समझ में आ गया? फिर यहां पर भी ऐसा ही होना चाहिए. In the southern hemisphere there should be also like this. This is a north-south equatorial current. It is coming Brazilian current, and then under the effect of the Westerlies, it comes over the subpolar low pressure belt. Westerlies कौन लाता है? ये पोर्शन को कौन लाता है? Who brings? Westerlies. So Westerlies is able to make it to move here. Westerlies make it to eastward direction, and after coming here, subtropical high pressure belt, and this is, then I said, polar high pressure. So what happened when it is coming into this region in the subpolar low pressure? Then the one wind moves. What is the northeastward? One ocean current, because इसका level कम है, इसका level कम है, and another started moving towards. I said that. Yes, tell me. Southeastward. Presence of, I said that, presence of Antarctic, and यहाँ पर मैंने आपको बताया था east wind drift. The ocean current is not able to completely move towards it, and it has been bordered and obstructed, and it is moving in the form of, I said that, west wind drift. So the west wind drift, it is a kind of current which has to move towards polar high pressure, but it has been obstructed by Antarctica and east wind drift. East wind drift को कौन बना रहा था? Polar Easterlies. And then thereafter, और ये ocean current and ये ocean current, they are moving along the border. They have reduced their speed. And when the speed has been reduced, what does it mean? Drift. What does it mean? So therefore we have an west wind develop, and that becomes, I said that, Benguela current. That currents become, I said that, West Australian cold current. यहाँ पे भी similarly, it is a Peruvian cold current. So many things that you can be able to see. So first हमने क्या बोला? Last line बोला ना? हाँ? In the southern hemisphere, similarly, from subpolar low pressure belt towards subtropical high pressure belt, cold Benguela current cold Peruvian current, cold West Australian current in northeastward direction develop. Further from subpolar low pressure towards polar high pressure in southern hemisphere, further from subpolar low pressure to polar high pressure in southern hemisphere, an ocean current develop but it has been obstructed by, who has obstructed? Antarctica and east wind drift, but it is obstructed by Antarctica and east wind drift. Under such obstruction, ocean current west wind drift with slow speed develop. An ocean current west wind drift with slow speed develop. और ये ध्यान में रखेंगे, ईस्ट विंड ड्रिफ्ट इज ऑल्सो सर्कुलेटिंग अराउंड अंटार्कटिका एंड आई हैव सेड लाइक व्हाट आई हैव सेड, मैंने क्या बोला था कि पोलार ईस्टर्लीज ऐसे मूव कर रहा है एंड देन सी सरफेस ने क्या किया, कोरिस्पोस लेफ्टवर्ड एंड देन देयर इज एन व्हाट ईस्ट विंड ड्रिफ्ट. So there is an Antarctica and there is an, which I said that, east wind drift. Further, when this current is coming from here, then Antarctica has a land mass and east wind drift as an what, acting as a border to not to go there, but they are obstructing it, and therefore its speed further decrease and it is moving in the form of. Similar thing happened in here, it is also west wind drift. So west wind drift, it is everywhere in the Pacific also, similar thing in the Pacific, but that become what? West wind drift. समझ में आ गया? Why do the west wind is in a drift? It should be fast. But why it is in a west wind drift is in a slope? The reason behind it has been obstructed by Antarctica and opposite direction movement of east wind drift, which has been developed by the polar easterlies. Understood it? नेक्स्ट पॉइंट हम लोगों ने देखा, विच वन वी हैव सीन, एटमॉस्फेरिक प्रेशर, प्रेशर बेल्ट्स, एंड हमने बोला कि इक्वेटोरियल लो प्रेशर बेल्ट एंड सब पोलर लो प्रेशर बेल्ट इज व्हाट इज द लेवल ऑफ वाटर इज अप यहां पर, एंड देन पोलर हाई प्रेशर बेल्ट एंड सब ट्रॉपिकल हाई प्रेशर बेल्ट द विंड इज डिसेंडिंग, देयर लेवल इज व्हाट, डाउन. इसके अलावा आई हैव सेड दैट एट सब ट्रॉपिकल हाई प्रेशर बेल्ट ड्यू टू लेस रेनफॉल व्हाट इज हैपनिंग, सैलिनिटी इज 36.5. And equatorial low pressure belt salinity is what, 33-34 parts per thousand. तो ये लेवल 34 जहां पे salinity कम होगी, level of water is more, and where the salinity is high, the denser is more, then it what is going downward. तो जब वो नीचे जाएगा तो उसको फिल करने के लिए इक्वेटोरियल रीजन से आएगा. That we have completed. So they are what is supplementing each other. One factor cannot be only responsible for this movement. Understood? An ocean surface, polar high pressure. What is the two reasons? What are the two reasons polar high pressure, what is in a water is down fast? Polar high pressure level water is down. Yes. Density increases. Salt is reducing and the salt is going downward. वहां पे ice बनने की वजह से क्या होता है? When the ice is under the formation, then the ice releases salt, and when the ice releases salt, then the ice used to take the water downward. और जैसे ही आर्कटिक रीजन में वाटर स्टार्टेड गोइंग डाउनवर्ड, द लेवल वाटर हैज गॉन डाउन, एंड व्हेन द लेवल ऑफ वाटर हैज गॉन डाउन, तो इसकी वजह से फ्रीजिंग से, क्योंकि आइस के अंदर salt cannot exist. And another is in a polar high pressure descending air. Understood it? The descending airs, what is it? Making the things to be what? Pressurized. Clear? So these are the regions we have seen. Another, I said that precipitation. P for precipitation. What is the fourth factor? I said that P for precipitation. और आपको पता होगा इसका. Which regions are getting precipitation? Equatorial low pressure belt and subpolar low pressure belt. Equatorial low pressure belt, how much? Yes, 200 to 400, and subpolar low pressure belt 150 to 200 through the temperate cyclone. और वो किसके थ्रू ले रहे हैं? Convectional rainfall. Equatorial low pressure belt, it is through the, so therefore the due to the mixing of fresh water, that reduces the salinity and the level of water is uplifted, and it creates a slope gradient, and then it leads to the movement of ocean currents. So write down equatorial low pressure belt every day and throughout the year receives rainfall and average annual rainfall is in the range of 200 to 400 centimeter. 200 to 400 centimeter. Yes, how much it is? 200 to 400 centimeter, and whereas in subpolar low pressure through temperate cyclone and westerlies, rainfall is in the range of 150 to 200 centimeter. 150 to, this freshwater precipitation reduces salinity in this region, so under less saline and less denser condition, level of water is up in comparison to surrounding, which creates slope gradient to provide inertia of motion, in the form of inertia of motion in the form of ocean current. क्लियर? तो इनको क्या मिल गया? एक मोमेंटम, दे हैव मोशन मिल गया, एक मोमेंटम आ गया. इज इट क्लियर? अब आप लोग थोड़ा सा समझते चलेंगे, फिर विल कम ऑन टू द व्हाट नेक्स्ट. इट इज कॉर्लिस इफेक्ट एंड टेम्परेचर डिफरेंस. आई सेड एंड देन यू कैन ड्रॉ. उसके बाद आपको अपने सो फर्स्ट ध्यान से देखेंगे. This is equator, and under the influence of this is northeast trade wind, and this is a southeast trade wind. Under the friction of what northeast trade wind and southeast trade wind, there is a development of north equatorial current, and there is a development of which south equatorial current. Understood it? And it is, I said that Cape Sao rock. Cape Sao rock. Which I said that? Cape Sao rock. And thereafter this region has got a good amount of water, level of water, accumulation of water is also there. Due to, so what happened, one part of the ocean current which is under the influence of, which I said that, under the influence of slope gradient towards subtropical high pressure, then ocean current started moving towards this, and when it is moving towards it, so one it is moving, यहाँ पे Antilles island है, one it is moving east of Antilles, it is known as Antilles current, another it is moving, I said that west of Antilles through the Caribbean Sea into Gulf of Mexico. Again I said, this is a north equatorial current which has been developed under the influence of northeast trade wind, and then south equatorial current developed under the influence of southeast trade wind. And now this is in a south equatorial current, but due to I said that Cape Sao rock, parts of south equatorial current also become and contributing momentum to what is, I said that, ocean current in the North Atlantic Ocean. Therefore, most of the part of one of the major chunk of south equatorial current is going onward, and this is Antilles current, and then in the Gulf of Mexico accumulation of water. In the Gulf of Mexico. So this is an Antilles current, and this is an, I said that you can be able to see this is an Antilles current, and from here you know that this is the Florida state of USA, and there is a Cuba, और यहाँ पे Florida Strait है, STRAIT, and thereafter the water comes out through this Florida Strait in the name of Florida current. Understood? And now Antilles current and Florida current get together, and they started moving in the form of, I said that, yes, tell me, Gulf Stream. Now they have got the momentum. They have got the momentum. Now under the influence of Westerlies, they started moving, I said that, eastward. Understood? And यहाँ से फिलहाल इतना ही समझेंगे. And from here, one cold Labrador current comes. It is coming from high latitude to low latitude, and they get together. And further, this Westerlies thrust him to move towards subpolar low pressure zone. So it has come toward this subpolar low pressure zone. And it is moving in the larger area. After meeting with them, they started moving in the open large area. Its speed reduces. And when the speed reduces, it becomes North Atlantic drift. What it becomes? North Atlantic drift. What it becomes? Thereafter, what happened, when after in the subpolar low pressure it comes, they found in the polar high pressure and subtropical high pressure, I said that the level of water is down. Two factors. यहाँ पे क्या है? Subtropical high pressure belt and the density evaporation. And यहाँ पर there is a polar high pressure belt zone, and there is a what? Freezing. So the level of water it is reduced in this region. So one wind started moving from what is towards northeast drift, and another become southeast drift. What are the two formations? Northeast drift and which are I said that? Northeast drift and under the influence of polar, the what is the level of what is down, but it is you know that यहाँ पर क्या है आपका? Some ridges and mountains are there. Some ridges, mountain ranges there. Some plateaus are there. It has been obstructed. तो ध्यान से देखेंगे. This is, I said that it has been obstructed. One, due to the ocean bottom topography, there is a divergence took place. So one become like this Norwegian. This is a northeast drift. Northeast. I said that the northeast drift is going like this, and further it has been bifurcated in the form of towards Iceland and one is towards Norway. And towards the Norway it becomes Norwegian warm current, and one towards Iceland in the name of Irmingar current. In the name of, understood it? What are the two division of north-east drift? First, North Atlantic drift has been divided into two under the what? Polar high pressure, subtropical high pressure. Which are the two drift? Northeast drift and southeast drift. Further, northeast drift has been divided into two, and southeast drift will also divide into two. So northeast drift divided into what? Irmingar current towards Iceland, and then one it is a Norwegian current towards Norway. And यहाँ पर मैं रुक जाता हूँ. This is clear. And यहाँ पर there is a southeast drift, and then southeast drift which is moving towards subtropical high pressure belt zone. Southeast drift which is moving towards subtropical high pressure zone, due to the bottom topography it has also divided. One went towards the Bay of Biscay, one moved towards west of Africa. Bay of Biscay se hote hue it is known as English Channel, another it is what? Canary cold current. Understood? Cold. And again this Canary cold current under the influence of northeast trade wind deflected towards right, and it becomes, yes, North Equatorial current, and it completes in a North Atlantic gyre. Further, this Norwegian, I said that Greenland, melting of glacier will provide fresh water, and when it is providing fresh water means density will decrease, salinity will decrease, and level of water. In this region, east of Greenland, there is a development of cold East Greenland current. Which current is developing? अभी वहाँ पे develop हो रहा है. Melting of what? Glacier, क्योंकि glacier, the Greenland tiltation is like this. Melting of, आप सोच सकते हो West Greenland में क्यों नहीं हो रहा है ऐसा? In melting it has created what I said, that making a fresh water accumulation, and fresh water reduces, the density reduces, and then it has uplifted. When it has been uplifted, then this Norwegian current is returned back. One it is another contributed more momentum to the what is an East Greenland current. And Irmingar current, after obstructing by the Iceland, it has turned towards, I said that, and again meet with East Greenland current. So which are the two currents are meeting with the East Greenland current? Norwegian, and वहाँ पे स्वासलबर्ग islands वगैरह है, सबसे घूमकर Norwegian again meet with the East Greenland current. And thereafter I say which current? Which current? Irmingar current. They again meet with the East Greenland current. It means volume of water for East Greenland current is more, and they accumulate near which? Cape Farewell. कहाँ पे accumulate होते हैं? यहाँ पर. Level of water is more. Yes or not? Level of water is more on the Cape Farewell. Cape is the southern point of Greenland, and thereafter they find that कि यहाँ पर completely पानी ज़्यादा है, तो इस region में पानी ये तो obstruct कर रहा है movement को. So they started moving in the form of West Greenland current. Clear? यहाँ पे when it is moving, then this is in a Davis Strait, and through the Davis Strait it moves into the Baffin Bay. Further group of island obstructed its movement. Therefore, it returned back in the name of Labrador current. So the West Greenland current, which has been obstructed, and therefore it is returning back in the form of what? Labrador current. So the Labrador current is formed by the East Greenland itself. And then one gyre you can also be able to see here. Understood? Is it okay? So this is an ocean current which has been developed. लेकिन क्या हमने देखा? What are the name I said that? Tell me. North Equatorial current and some parts of South Equatorial current. Which are the name I said that? North Equatorial current and some parts of South Equatorial current has been contributed into the North Atlantic. And this under the pressure gradient and slope gradient, against the pressure gradient, slope gradient, equatorial from the ocean current started moving toward the subtropical high pressure. And then one part when the inertia of motion they have got and they started moving, Antilles Island has, what is an obstructed it? The north, east of Antilles, it is an Antilles current. West of Antilles, there is an, which current I said that? Current which is, its name has not been Caribbean current, you can say. And then it moves into the, I said that through the Caribbean into the Gulf of Mexico. And in Gulf of Mexico, accumulation of water. And after the accumulation of water, what happened? After the accumulation of water, through the Florida state, it is coming out in the name of Florida current. So Antilles current and Florida current get together, and thereafter they started moving in the name of Gulf Stream. And who is putting thrust on it? Westerlies. Who is putting thrust on it? Westerlies. Further, by reaching Cape Hatteras, और यहाँ पे एक cold wall भी चलता है, it is not necessary. When it is moving west, it is eastward, it is able to meet with what is a cold Labrador current. And when it meet with the cold Labrador current, and thereafter started under the effect of westerlies moving further eastward, they started moving with the very slow speed in larger area. जैसे ही पानी smaller area का पानी larger area में जाने लग जाएगा, तो speed will reduce and it become North Atlantic drift. Further North Atlantic drift. यहाँ तक who is playing role? Westerlies. Further North Atlantic drift, which reached into the subpolar low pressure, there is a division of what? Two. One has to go down the level of polar high pressure, where the level of what is down, and subtropical high pressure. There is a development of which northeast drift and southeast drift. Understood? The northeast drift started moving towards polar high pressure, and southeast drift it is moving towards subtropical high pressure. But it has been obstructed by the ocean bottom topography in North Atlantic Ocean. And then northeast drift has been divided into two. One towards Norway, Norwegian warm current. One towards Iceland in the form of, yes, Irminger warm current. Thereafter I stopped and I said that east of Greenland, due to melting of glacier, there is a formation of East Greenland current. And it has been contributed by the momentum of water of Norwegian current returning from Arctic Ocean, and then Irminger current. By reaching south of Greenland, there is a Cape Farewell. After that Cape Farewell, accumulation of water causes this water to move towards west of Greenland, again towards in the form of slope gradient. But passing through, नाम यहाँ जरूर देंगे, passing through Davis Strait and to the Baffin Bay, further it is stopped by group of islands, and it is started returning back in the name of Labrador current, and it is also completing one line. Further, southeast drift has been divided by the ocean bottom topography in the form of English Channel. It entered into Bay of Biscay, and then through the between the France and Britain English Channel. And another it is cold Canary current. This cold Canary current is, again I said that it has become the part of cold, part become under the effect of northeast trade wind become north equatorial current. Now one part, due to accumulation of water under the Coriolis force, यहाँ पे, और Coriolis force due to the movement of earth, यहाँ पर क्या स्टार्ट होता है? डेवलपमेंट ऑफ काउंटर इक्वेटोरियल करंट. काउंटर under the Coriolis force and more accumulation of water, counter equatorial current develop, and यहाँ से कुछ water that is also there जो कि क्या बनाते हैं? गिनिया करंट. So ये बाद में कमजोर हो जाता है, and यहीं पर इसका नाम दिया जाता है गिनिया करंट, near to this. What I said that, और ये गिनिया करंट ऐसे मूव करके it become the part of also south equatorial current. यहाँ पे group of Guinea island is there. Understood? So Guinea current is not always developing, it is not an always phenomena. So clear हो चुका है? Now some parts of south equatorial current has been bifurcated by which? Cape Saurok. So can I say that? अब यहाँ पे दोबारा आ रहे हैं. Now our sixth factor is Ekman or Coriolis force. अभी तक आपको Coriolis force word I am using. I was using the Coriolis force. Yes. Now, Corliss force in the form of Ekman spiral, Ekman pumping. Okay, this is, I said that here you can be able to see north equatorial current. Which current is coming? North equatorial current. And you know that, dhyan se, when the ocean current moves, when the wind moves, it puts in a friction onto the top layer of water, and then top layer of water deflected rightward by 20 degree to 45 degree. The top layer has been what? Deflect to an angle of, I said that under the wind, top layer deflect by how much angle? 20 degree to, better to say 22 से लेकर 45, 22 to 45 degree top layer deflect. And under the friction of top layer, lower air angle further, lower layer water are further deflect rightward. And then below second layer, third layer of water further deflect. And below third layer, fourth layer, such deflection takes place till the depth of 100 meter. And till the depth of 100 meter and till the what? Deflection up to complete 90 degree with respect to the wind. So I said that complete 90 degree when it will be there, then it will be. So we can be able to see, like I said that, you can be able to see like that, wind is moving like this with respect to this lower layer further deflecting further in this direction. So with respect to this, there is a 90 degree deflection. And after that, the momentum जो उसको नीचे move करा रहा था keeps on reducing. नीचे में जाकर, after that, it has no more force to deflect the water. So at 100 meter it is stopped. तो ध्यान से देखिए, when the ocean current, it is in a north equatorial current is moving, the water is also here it is. Yes, more accumulation here. And when this current is moving, the नीचे के layer में क्या हो रहा है? Yes, tell me, accumulation. Upper it is moving, ocean current is moving like this, below layer it is moving here. And when it is moving over the upper layer, Gulf Stream and all, so I said that there is a moving over there. And then when it is moving, then below, in this region, what is happening? Ekman spiral has accumulated the water, and then level of water has been uplifted near to the what? Eastern coast of the continent. Here, this kind of development has been taken place. अब वहां से ocean ऐसे जा रहा है, ऊपर में तो ऐसे जा रहा है, it is going like, but below में आपको क्या हो रहा है? It is about one layer after another it is causing, and then accumulation of water in the center here. And this Ekman spiral pump the water level up. Therefore, now it is Ekman pumping. It is known as what? Ekman spiral has pumped the water level up, and it is known as Ekman pumping. और ये कब तक होगा? And that is known as a, what is the, इसी को क्या बोलते हैं? Corliss force में क्या देता है? जो Corliss force gives us geostrophic wind. Yes or no? Fast movement gives us, and this is known as, I said that, a geostrophic flow. This is known as what? Geostrophic flow. If you are able to see that here, the what it is in a moving under the Corliss force. और आपने देखा था कि geostrophic subtropical, when I said that geostrophic wind बताया था parallel to isobar, ये और उस समय क्या हो जाता है? Pressure gradient force become equal to Corliss force. अब यहाँ पर भी level of water has become up. When the level of water has become up, who is making this? Corliss force was to go toward this, rightward. And यहाँ पर who is there? Gravity. So this Ekman pumping will be till when the what? Corliss force is equal to gravity, क्योंकि ये नीचे भी खींचना चाहता है. and when the gravity become more than Coriolis force, this water will break and it will come down and it put the pressure onto the moving ocean current on the eastern coast. And जैसे ये pressure करेगा, Gulf Stream speed started increasing faster. Therefore, eastern coast has stream. Accumulation of water is there, combination of two water that you have seen Antilles current and you have seen Florida current. But at the same time, पानी तो जा रहा है, लेकिन who has? जब आप पानी एक पाइप में जा रहा है, and when you have what? Narrow the pipe, speed will increase. Therefore, Gulf Stream and Kuroshio, that is known as a black stream, their speed is very high. So write down. What is Ekman spiral? What is Ekman spiral? Under the friction of what? Wind, top surface layer deflect by 22 degree to, and with respect to top layer, lower layer deflect towards right and further lower layer, and it is happening till 100 meter depth or 90 degree complete deflection. Understood? Due to this deflection, which I said that due to this deflection, north equatorial current or northeast trade wind and westerly is able to create geostrophic flow, and that is known as Ekman spiral. Created what? Geostrophic flow, that is known as, through the Ekman spiral water get एक ही जगह आ रहा है यहाँ से through the Ekman spiral water get pumped up, and it is known as what? Ekman pumping. This pumping and geostrophic flow is going on till Coriolis force is equal to gravity, and after that gravity become what? Significant, and then pumping of geostrophic flow become broken and it is coming, and यही पर बनता है Sargasso Sea, and it helps in the North Atlantic garbage. यहाँ पर हर कचड़ा क्या होगा? All the plastic garbage comes and accumulate, and similarly toward the North Pacific. So write down. Under the Coriolis force, northeast trade wind and westerlies put friction on the oceanic water to develop ocean current with the rightward deflection by 22 to 45 degree. to 45 degree on the top layer. Further, this top layer under Coriolis force put friction to the lower second layer and deflect rightward. Further, this second layer in deeper water put friction to the lower layer and deflect rightward. And it happens till 100 meter depth or complete deflection 90 degree with respect to wind. And top layer, with respect to wind and top layer. This kind of deflection of layer of water rightward in northern hemisphere known as Ekman spiral. And Ekman spiral accumulated water at the center and accumulated water pump up the level of water, and accumulated water pumped up the level of water at the center near eastern coast. At the center pumped up the level of water at the center near eastern coast. This complete phenomena is known, this pumping of water is known as Ekman pumping. And complete phenomena is known as geostrophic flow. This geostrophic flow continued till Coriolis force and gravity is in balance. Is in balance. The case when gravity become more than Coriolis force, pumped up water started moving downhill. Pumped up water started moving downhill and pressurized ocean current moving along the eastern coast. And that ocean current becomes Gulf Stream or Gulf Stream and Kuroshio current. This center of geostrophic flow, change the para, the center of geostrophic flow is like a Sargasso Sea in North Atlantic Ocean. Sargasso Sea in North Atlantic Ocean, and in this region accumulation of plastic garbage also take place, and it becomes North Atlantic garbage, and North Pacific garbage. अब ये मुझे बताओ, just tell me that now यहाँ पे तो one suppose करो 1 lakh liter of water is going, and here it is also 1 lakh liter of water is coming, but in this one suppose 30 lakh liter of water has gone this side, so it become 1 lakh 30. Now here it is what, 70 lakh. So this current will be strong or it will be comparatively less. Less, water is less. So can I say that it is in a weak Brazilian current? Yes or no? And if it is weak, तो यहां पर भी बनाएंगे, लेकिन यहां पर उतना ज्यादा प्लास्टिक गार्बेज और यहां पे जियोस्ट्रॉफिक फ्लो नहीं होगा जितना कि कहां पे होगा, जहां पे ओशियानिक वाटर, पैसिफिक में क्यों होता ज्यादा, लार्ज मोमेंटम ऑफ वाटर इज कमिंग. Therefore, this region has an what? North Pacific garbage. Understood? This region has what? North Atlantic garbage. यहाँ पर भी एक गायर बन रहा है. गायर का मतलब सर्कल. यहाँ पे भी सर्कल, यहाँ पे भी सर्कल. There is a circle. This is the circle. Formation is there. एक आपने समझ लिया. All you have understood. हाँ? Cold क्यों है? Because it is coming from high latitude to the low latitude. Any current coming from high latitude to the comparatively low latitude, it will be always a cold ocean current. कहीं आपके पास, यदि मेरे पास एशिया की तरफ से हवा आए तिब्बत से, it will be cold or warm. So I'll say that it is coming into the warmer region and I'll say that it is in a cold. So cold and warm is a comparative study. ये किस region से आ रहा है? वही यहां से चला गया, वही यहां से यहां गया, तो ये कंपैरेटिवली इफ इट इज इन 14 डिग्री और जा रहा है 0 डिग्री के रीजन में, तो ये लोग बोलेंगे ये कैसा वाटर आ रहा है, वार्म. ये 14 डिग्री का जा रहा है 22 डिग्री के रीजन में जहां पे टेम्परेचर है, तो लोग बोलेंगे क्या है, ठंडा आ रहा है. अंडरस्टूड? सो एनी करंट मूविंग फ्रॉम हाई लैटिट्यूड टू द लो लैटिट्यूड, इट इज इन अ कोल्ड, एंड लो लैटिट्यूड टू द हाई लैटिट्यूड. ये क्लास जब स्टार्ट किया था उसी समय दैट टाइम आई टॉक. सो क्या पूछ रहा था, नॉर्वेजियन. तो गायर सभी जगह बन रहा है, बट गार्बेज विल नॉट बी इफेक्टिव. इफेक्टिव गार्बेज इन द पैसिफिक एंड इफेक्टिव गार्बेज इन द, यहां पर भी आप देखोगे सम ऑफ द वाटर कम्स इनटू व्हाट, फ्रॉम द साउथ इक्वेटोरियल करंट इट एंटर इनटू द नॉर्थ पैसिफिक. इसका मतलब ईस्ट ऑफ ऑस्ट्रेलिया विल हैव व्हाट, वीक करंट एंड ही कैन नॉट बी एबल टू डेवलप geostrophic flow. So geostrophic flow is not able to develop in better form in any of the ocean except North Atlantic and North Pacific. Understood? क्योंकि वहां पर accumulation of water भी तो होना चाहिए. जब तक स्पीड नहीं होगा, आप मुझे बताओ, if the speed is more, water is more, the layer will be also getting deflecting, then the more pumping will be there. And if there is a mass of water is less comparatively and speed is less, then the यहाँ से ऐसे यहीं पे finish हो गया. He cannot be able to develop geostrophic flow. So geostrophic flow in ocean will exist in the northern side, northern hemisphere, or in the southern hemisphere. समझ में आ रहा है? So this is an Ekman spiral and Ekman pumping whole phenomena. It is a geostrophic flow, and it will be existing till the Coriolis force and gravity is in the balance, and after that it will start falling down and it will pressurize this what, ocean current, and that the ocean current become narrow and started moving in the faster speed. तो ये मैं पहले नहीं बता सकता था, पहले तो आपको ओशन करंट समझाना था. अब आप लोग केवल नाम देखेंगे और चलते चलेंगे. Yes, keep on saying North Equatorial current, South Equatorial current. Able to locate? North Equatorial current, South Equatorial current. Parts of North Equatorial current become, South Equatorial become also the part of North Atlantic. Then we have seen Antilles current and Caribbean, Gulf of Mexico. They came out through the Florida, become Florida current. Antilles current and Florida current get together, become Gulf stream. They have got momentum. They started moving fast. momentum, but it has been at the same time, it has been also pressurized by whom? What? Downhill movement of geostrophic flow. Downhill movement of geostrophic flow, and it become faster. Gulf Stream. Faster means stream. And then Gulf Stream from the Cape Hatteras, by reaching Cape Hatteras, and they started moving and nearby Cape Hatteras, and then further Florida, Labrador cold current meets. And under the Westerlies, they keep on moving eastward. Understood? And when it is moving after meeting in the Labrador, go eastward in the open ocean, in large open ocean, what will happen? Speed has been reduced, and that become North Atlantic drift. But they are finding subtropical high pressure and polar high pressure zone has what? Level of water is down. The one become northeast drift, another become. But this northeast drift and southeast drift has been obstructed by ocean bottom topography, and northeast drift divided into one Irminger current and one Norwegian current. Irminger warm current and Norwegian warm current. Irminger current moved towards Iceland, and another it is a Norwegian warm current moved towards Norway. Understood? यहाँ पर मैंने रोक दिया. And I said that east of Greenland, due to melting of glacier, formation of East Greenland current, which has been supported by the momentum given by returning Norwegian current, and then Irminger current, which has been obstructed by Iceland, again turn towards left and meet with the East Greenland current. So mass and volume of ocean current of East Greenland are very high near southern tip of Greenland. And what is the southern tip name? Cape Farewell. What is the name? Cape Farewell. When the water accumulated large in amount, the comparatively in the Baffin Bay, water is down. So then they started moving towards west of Greenland. West of, and that name become West Greenland current passing through Davis Strait and Baffin Bay. But further it is obstructed by large number of islands, and it returned back in the name of Labrador current. And when the Labrador cold current comes, they come with the cold water and iceberg. Remember, where they are meeting near Newfoundland, there is coming with the iceberg which hinders. आप लोग को when I was teaching you climate, I said that advection fog. ये बताया था. Cold ocean current and warm ocean current, temperature inversion, advection fog. But this cold Labrador current come with the icebergs. So उस समय बताया था advection fog is creating for the navigation, but coming off with the iceberg, again it put hindrance into the what? Navigation. Understood it? So which are the two phenomena? Advection fog and iceberg, cold ocean current, which come with this, that hinder the what? Navigation in this region. This is completing. And now southeast drift wind, it has the southeast drift. It has been divided into two. One, it is an English Channel toward the Bay of Biscay, and another is, I said that, cold Canary current. And this cold Canary current further move, and then it becomes, yes, tell me, it becomes the part of northeast, but one part is moving like a Guinea current, which has been also supported by, counter. यहाँ से कैनरी करंट का एक पार्ट इधर चला जाता है, it becomes Guinea current, and that become the part of South Equatorial. Understood? Clear है? Caps और इसका मतलब one factor, मैंने modifying factor में क्या बोला था? One modifying factor is what? Shape of the coast. And एक और आपने देखा modifying factor. Which modifying factor? Ocean bottom topography. दोनों modifying factor we have seen. Yes, and one seasonal change is there that we have to see. अब हम लोग आते हैं साउथ, in the South Atlantic. In the South Atlantic, what is this? South Equatorial current. And then from the Cape Saw rope, it started moving. और यहाँ पर आपको पता है Equatorial low pressure belt, level of water is up. Subtropical high pressure belt, level of water is down. It comes toward the subtropical high pressure belt, and they have got the momentum. They have got the, and now it come under the influence of, yes, tell me, Westerlies, and then it started moving eastward. But further from there is one small cold current. It is coming from one small cold current. It is coming from, I said that, Falkland Island, and its name is Falkland cold current. They get together. It is in a warm Brazilian current, and Falkland high latitude to the low latitude जो भी आएगा गर्म ठंडी जगह से गर्म, it will be cold, and they get together and become under the effect of westerly. They started moving and reached subpolar low pressure belt. As it is subpolar low pressure belt, after that they found subtropical high pressure belt, and this region should be down, and therefore the ocean current started moving towards subtropical high pressure belt. And one it is on this side. When it is moving towards subtropical high pressure belt toward the west of Africa, its name is Benguela current, cold. Its name is cold Benguela current, and when it is moving towards it, yes, tell me, it becomes, and under the effect of southeast trade wind, it becomes south equatorial current. It become ना. अच्छा, मैंने यहाँ पे इसको साउथ अटलांटिक करंट नाम दिया. South Atlantic drift I did not say. After moving, getting together, it should move slowly in the large area. But why didn't I say South Atlantic drift? I am saying South Atlantic current. बताया था Westerlies यहाँ पे क्या है? In the northern there is a large land mass obstructed its speed. Therefore the Westerlies speed are low. But in the southern hemisphere speed is what? High. And these are, I said that, मैंने क्या बोला? Roaring 40s, furious 50s, shrieking 60s, and therefore their speed is remaining high, and that is known as North Atlantic current. इस current का क्या नाम हो गया? Brazilian, warm Brazilian, and this is, I said, that Falkland cold current, and thereafter from the subtropical high pressure they come into subpolar low pressure, and there it's named in the name of North Atlantic current. And one part move toward this subtropical high pressure in the name of Benguela cold current, and further, and thereafter it moves toward under the southeast trade wind. Further it has got the momentum, and under the effect of what southeast trade wind becomes south equatorial current. It is South Atlantic gyre. The one which is moving towards, I said that polar high pressure, it has been obstructed by the land mass of what? Land mass of Antarctica and East Greenland current. Sorry, East wind drift. East wind drift कैसे developed हुआ? Who has developed east wind drift? Correct? And they have obstructed. Due to that, the current which is moving this one, obstruction found, and speed reduces, and they move in the name of west wind drift. Understood? So east wind drift is circulating like this, and west wind drift it is circulating along Antarctica like this. Understood? So these are the things. Clear? Same thing I'll teach you. तो ये समझ में आ गया आपको? Clear है? Code is force. Next one is melting of glacier. Example आपको दे चुका हूँ. Yes, melting of glacier. You know that what is the melting of glacier? Which are the one example? Tell me first. East Greenland. Correct. Let's go to the Baltic Sea. वहाँ पे कौन है? Norway, Sweden, Finland. Norway, Sweden, Finland. तो मेल्टिंग ऑफ ग्लेशियर से हमने एक एग्जांपल कौन सा दे दिया इस टेल में? मेल्टिंग ऑफ ग्लेशियर. इट विल प्रोवाइड व्हाट? लिख लेंगे मेल्टिंग ऑफ ग्लेशियर प्रोवाइड फ्रेश वाटर. मेल्टिंग ऑफ ग्लेशियर 6 point प्रोवाइड फ्रेश वाटर. It provides fresh water, therefore it reduces salinity and density. Therefore it reduces salinity and density of oceanic water which causes level of water to be up and creating level of water to be up and creating level of water to be up and creating slope gradient to start the inertia of motion for ocean current. Clear? Inertia of motion to whom? Ocean current. For example, East Greenland current, for example, East Greenland current and ocean current from Baltic Sea to North Sea, and ocean current from Baltic Sea to North Sea. So you will see that यहाँ पर भी क्या देख रहे हैं आप? Yes, this region is what full of accumulation of glacier, and when they are penetrating water into this, and thereafter ocean current comes into यहाँ पर when that will mixing of fresh water, इसकी salinity बताएं कितनी बाल्टिक सी की? 20 से 22, better to say 22 to 22. तो इसलिए मैंने हिंदी में बोला 20 से 22. समझ में आ गया? 2020 to 22. This is salinity due to the mixing of fresh water from the melting of glacier, and there the salinity in the North Sea is 30 parts per thousand. So where the level of water will be up? In the Baltic Sea, and therefore the ocean current is coming from यहाँ पे level of water in the Baltic Sea is more, and this is North Sea in nearby Greenland. So यहाँ से ocean current will move from Baltic Sea to Greenland. Understood it? Next one, I said that temperature difference, the last factor for the what is in the development of ocean current is, yes, क्या नाम है उसका? Temperature difference. You know that already we have done in the climate that in the region of, I said that equatorial region should have very high heat. Yes or no? And with increasing latitude, temperature keeps on what? Reducing. Therefore, I said that. Therefore, what happened? Temperature differences with increasing latitude. Temperature differences with equatorial current, south equatorial current in the northern little bit get together, and thereafter it become Antilles current, Caribbean, and then Gulf of Mexico, coming out in the name of Florida current. Get together, become Gulf Stream. But this Gulf Stream has been further accentuated by whom? Accentuated by whom? I said that downhill movement of geostrophic flow. Downhill movement of geostrophic flow, and therefore Gulf Stream is moving with the fast speed till Cape Hatteras. Further it meet with the, I said that, Labrador current, and then Labrador current after that under the effect of Westerlies it is moving, and momentum is there, and then eastward flow, North Atlantic drift, तो नाम ले रहा हूँ मैं, northeast drift, southeast drift, because of the pressure system they have developed. And then we have been able to see northeast drift has been divided into Norwegian current and Irminga current, and then East Greenland current I talked about, and then again it meet with the Norwegian and all, it become very large in amount, and Irminga with the East Greenland current, Cape Farewell become large amount, West Greenland through the Davis Strait into the Baffin Bay, it has been obstructed by the island and returned back in the name of Cold Labrador current. South-east drift, it has been divided into English Channel and Canary current, and then Canary current further meet with the northeast trade wind and become North Equatorial current, but parts of it touching to the Guinea coast in the form of Guinea current, and that is meeting with the, I said, counter equatorial current, and that return back they are becoming the part of what? South Equatorial current. Understood it? And then South Equatorial current is clear. Weak Brazilian current. Brazilian current is in a weak, warm, and then it is coming to the subtropical high pressure belt. Further, it started moving under the influence of Westerlies eastward, and it has met with the cold Falkland current, and they have been able, it is known as I said that North Atlantic current. By reaching subpolar low pressure zone, the level of water is already up. Therefore, one has to move towards subtropical high pressure and one has to move towards polar high pressure. The one which is trying to move towards the subtropical high pressure, it is known as the cold Bangula current. Understood? From the high latitude to the low latitude. and then thereafter we have been able to see, I said, further under the southeast drift momentum they have got, under the southeast drift it becomes south equatorial current. Further, one which is moving toward the polar high pressure, it has been obstructed by the Antarctic at east wind drift, and therefore it is under the obstruction, it is started moving west wind drift with a slow speed. Understood? So नाम याद हो गए सारे. So then we have seen North Atlantic gyre and South Atlantic gyre. Which gyre is very strong? Where there will be garbage? Killer? Garbage के थोड़े बहुत बनने के chances रहेंगे South में, but there is a more, it is in what? Pacific में more, because वहाँ पे mass movement is more. Yes? And आपको केवल ये and temperature difference बता दिया था मैंने. बता रहा था मैं. Due to the temperature difference, I have said that temperature difference में what I said, with increasing latitude from the low latitude to the high latitude, temperature is decreasing. But what is happening? यहाँ से ध्यान से देखेंगे. Due to high temperature at latitude, what happened? Humidity also cover after certain period of time every day. Yes or not? What happens? The high temperature lead to evaporation. High temperature lead to evaporation, and evaporation has been completely saturated in the atmosphere every day. So the rate of evaporation reduces. Rate of evaporation reduces in this reason, and then due to temperature difference, यहाँ पर क्या हो गया? Evaporation happen, rate of evaporation reduces every day, and then level of water increases, and that has given us momentum. Level of water, this side is level of water is less. Understood? It has created level of water. Saturation created level of water, na? कैसे? Rainfall after saturation. And therefore temperature difference is one of the important factors. Understood? जहाँ पे temperature ज़्यादा होगा, there will be more evaporation, and after that evaporation, rate of evaporation will reduce because saturation condition. क्योंकि evaporation तब तक हो रहा है ना, यहाँ से गया और इस atmosphere को fill कर दिया. At every equatorial region पे every day water vapor is coming since morning. Since morning started evaporation, by 12 o'clock they have filled up this layer, और यहाँ पे कोई wind movement होता नहीं है. So it has been filled up and completely saturated by 12, and thereafter it become heavy enough, and then after 2 o'clock they started giving rainfall. So every day between 2 p.m. to 4 p.m. this region is rainfall. So the temperature differences lead to the level of water, and first initial evaporation, then rate of evaporation reduces, and then rainfall causes, and then increasing the level of pressure, and then it is there. Understood it? Clear? So आपको इसका एक नोट्स भी दे दिया जाएगा, जो ओशन करेंट्स वगैरह का जो होगा नोट्स, उसमें आप लोग देखेंगे, केवल आप उसको एक जगह कर लेंगे. नॉर्थ अटलांटिक इज ओवर. Now we are going towards South Pacific. Where I am going? Sorry, North Pacific and South Pacific. और यदि आप समझ चुके हैं अच्छे से, then you can understand it. और if you are understanding Pacific, you are understanding El Nino and La Nina as well. ये है 10 डिग्री साउथ लैटिट्यूड टू 40 डिग्री साउथ लैटिट्यूड. Which are the factors causing ocean current formation? Wind and its friction, d4 density, wind and its friction, d4 density, is it okay? Wind and its friction, d4 density, next you can. Atmospheric pressure, P for atmospheric pressure, P for precipitation. Then I said Coriolis force, melting of glacier. Coriolis force, melting of glacier. Then I said temperature difference. Understood? Modifying factor, shape of the coast, ocean bottom topography, shape of the coast, ocean bottom topography, and seasonal change. And seasonal change you will find in India, in case of India. Understood it? So, we are going to see under the influence of northeast trade wind and southeast trade wind, what is the formation? North equatorial current. Yes. What is the formation? North Okay. So which are the ocean current which has been formed? Just tell me. North equatorial current, under the influence of northeast trade wind, and there is a south equatorial current under the influence of southeast trade wind, northeast trade wind and southeast trade wind, and there is a south equatorial current, north equatorial current come over there is an obstruction of what is the oceanic water, okay, and there is a level of water is there, thereafter one part started moving like this, toward this is Philippine Sea, and thereafter it comes toward the East China Sea, Philippine Sea and East China Sea, okay, and this is in a south equatorial current, और ये कौन सा water body है? Coral Sea, which one I said that? And this is an Arafura Sea, and there is a Timor Sea. Which water body is this? This one is Arafura Sea, and it is Timor Sea. And then from the Coral Sea, parts of it comes towards it, and there is an island groups are there, and then due to island groups, some of the part has started moving toward the South China Sea. They started moving towards South China Sea, and some parts in the Indian Ocean, some parts in the Indian Ocean, and then others यहाँ पे आ गए. इसका मतलब similar way it has been happening in the North Atlantic. Yes or no? So इसका मतलब it means we can be able to see this has been what is there is one, it is passing through the Philippines and coming to East China Sea. Near Taiwan they are able to come. And then one water of South Equatorial current passing through Coral Sea, which I said that Coral Sea, Arafura Sea, and there is I said one it is moving towards Timor Sea and Indian Ocean, and then one part due to the island obstruction moved toward the South China Sea. So यहाँ पे कहाँ पे आ गया? South China Sea, and they get together in the East China Sea, and its name become Kuroshio current. Its name become, yes, in the East China Sea near Taiwan and near Philippines, they started moving in the name of Philippines and Taiwan. They started moving in the name of Kuroshio current. And what is the meaning of Kuroshio? Black streak. और आपको ये पता है why it is a streak? यहाँ पर क्या बना? Geostrophic flow, and this geostrophic flow has been what? this geostrophic flow downhill after breaking, they pressurized it. So I said that there is which current has been formed? Kuroshio current. Understood? By reaching this Japan, southern part of Japan, this Kuroshio current has been divided. आपको पता है यहाँ पे एक स्ट्रेट है between South Korea and Japan. Which state is there? Yes, Tsugaru. Tsugaru तो ऊपर है between Hokkaido and Honshu. Tsushima. Which one I said that? There is a Korea state and Tsushima state. Two states are there. जो आप जब मैं वर्ल्ड ज्योग्राफी का भी बताता हूँ, in that time I used to say, वहाँ पे दिखाऊंगा. वैसे भी आप देख लें, ये क्या है? साउथ कोरिया और यहाँ पर क्या है? जापान. तो यहाँ पे एक आइलैंड है, इट्स नेम इज सुषमा आइलैंड. तो ये वाटर चैनल को बोला जाता है कोरिया स्टेट बिटवीन साउथ कोरिया एंड सुषमा. बिटवीन जापान एंड सुषमा इट इज नोन एज सुषमा स्टेट. अंडरस्टूड? So यहाँ से there is in the Japan Sea, one part it has been bifurcated. Kuroshio current has been bifurcated and become what? Tsushima current. Which one I said that? TSU SHIMA. What I said that? TSU SHIMA Tsushima current. Understood it? Thereafter it is moving in the form of Kuroshio extension. Now it is moving east of Japan. East of Japan, it is moving in the name of Kuroshio extension. Understood? And this Tsushima current, further it moves through Tsugaru state से आके it meet with the Kuroshio extension. Understood? Further it meets with the Kuroshio extension. And here, this Kuroshio extension meet with, I say, Kuroshio extension meet with Oyashio. Which ocean current? Oyashio, cold ocean current. Kuroshio extension meet with Oyashio. Understood it? Now it started moving under, and it is a Kuroshio current and Kuroshio extension moving under the influence of Westerlies. After coming here, they started moving under the influence of what? Westerlies. And further, it is moving in the large area. Its name should be what? Tell me. North Pacific Drift, but it is not North Pacific Drift. This is your Pacific. Wind will move with obstruction. Westerlies will move with obstruction, and Westerlies will move in the Pacific here faster. Faster. So they will give the speed or not. So they will give the speed. So there is no drift. There is a what? और यहाँ पे drift था. Understood it? In this reason, there is an obstruction is there more. And here it is in a North Pacific current. What is there? North Pacific current. और आपको पता हो यहाँ पे क्या बन रहा है? Yes, tell me what is forming? Geostrophic flow. This is in a North Pacific current. तो इसकी स्पीड है? Yes or not? It has some speed. लेकिन यहाँ पर आप देखोगे there is no any kind of ridge are there. In this portion of the middle of the Pacific, there is no ridge. Understood? So यहाँ पे दो division होगा. One division toward the subtropical high pressure belt and one division towards trying to go toward the polar. Understood? So one started moving towards this in the name of what? In the name of what? Cold California current. Cold California current. जब high latitude से low latitude की तरफ when the ocean current will come, when the ocean current is coming from high latitude to the low latitude, it will be colder, and its name become, yes, tell me, Cold California current. Understood it? And thereafter this cold California current under the northeast trade wind, they become the part of what? Again they deflected towards right and become north equatorial current. Understood? North equatorial current. One part of it started moving and then it become what? Alaskan current. What it is? It is moving towards, I said that southeastward, one is southeastward, one is northeastward, and it become Alaskan current. Warm. It is going from low latitude to high latitude. Alaskan current. And under the shape of the coast, they started moving like along the coast of Alaska. Okay? And here, I said here it is an open ocean. Here it is, but here it is in a closed strait. Is there Bering Strait? यहाँ पे Polar Easterlies has what is in a pressurized air and one cold ocean current is coming from Bering Strait and towards the Bering Sea. One cold ocean current is, I said that, so Bering current, you can say the small Bering current, cold current, and there is also one Alaskan current is coming from here. They accumulated in this region and they become a level of water is become more compared to this, and they come over there and one current from here that is in a cold itself, Bering, a small Bering current, and here it is, and they become yes itself. Now they get together, one Bering current and Alaskan current get together and they started moving in the name of, I said that now, yes, cold, high latitude to the low latitude in the form of what? Cold Oyashio current, and one current is also moving comparatively, यहाँ पे इनको थोड़ा सा pressure मिलता है, passing through Aleutian Island. Which island is this? And its name is Aleutian cold current. Oyashio, and I said that Aleutian cold current. Is it clear? Alaska. Alaskan current came over here, and thereafter some Bering current comes through the Bering Sea. They become part of it. Oyashio, थोड़ा सा यहाँ से भी melting of glacier से थोड़ा सा Okhotsk sea से भी water इसको cold मिलता है. If you see, this is an Okhotsk sea, Kamchatka Peninsula. From here it is also getting some water. So it is not necessary to mention in your answer and all. So I said that, समझ में आ गया, South North Pacific guy, and then there is another guy is also completing like this. So we can be able to see which are the current we have seen. समझ में आ गया? एक समझ, once you anyone you have understood Atlantic, you can understand everyone. North equatorial current, South equatorial current, and under the influence of northeast trade wind, and then there is a coming towards, and there is a development of यहाँ पे development किसका हो जाएगा? Counter equatorial current, correct? And यही counter equatorial current is an El Nino, जिसको बोला जाता है Kelvin wave. That is known as, ये जो Pacific में counter equatorial current is itself an help in the formation of El Nino current. I said this is an accumulation of water. Able to understand? And one north equatorial current, because of the pressure, it is a low pressure, and then what level of water is rainfall and all, and one part started moving towards Pacific Sea, towards what? East China Sea. And then another, I said that towards the Philippines and Taiwan, and here it is South equatorial current, due to the geographical structure, passing through the Coral Sea towards the what? Arafura Sea, and then further towards the Indian Ocean, but more parts which started moving towards, due to the obstruction of island, toward the South China Sea. And further they meet near Pacific, near Philippines, and it becomes a Kuroshio current. It becomes near Philippines and Taiwan. Become Kuroshio current. Speed increased, and thereafter they started moving northward under the influence of Westerlies. They started moving northward under the influence of, and south of Japan, in the south of Japan, they have been bifurcated into two, one Tsushima current and one Kuroshio extension. Tsushima current further it is again meet with the Kuroshio extension, and Kuroshio extension under the influence of westerlies keep on moving eastward, and therefore in between there is a cold current OSU meet and their Pacific current. They reach to the subpolar low pressure zone. In the subpolar low pressure zone he found that there is a what very high pressure and then subtropical high pressure level of water. Under the slope gradient they started moving toward the subtropical high pressure in the name of southeast movement, southeast, and then another is a northeast movement, and its name become what? California cold current, and its name become what? Warm northeast side, warm Alaskan current. And this warm Alaskan current is able to reach into the Bering Sea. This region is Bering Sea. Able to reach into Bering Sea, meet with the Bering current, and then after accumulation of water they started moving towards, I said that Kamchatka Peninsula in the name of OSU cold current, and one in the form of Aleutian cold current. Understood it? And there is a development of counter equatorial current, and southeast trade wind led to the south equatorial current, and it is known as what? ये कैसा current होगा? East Australian what? Warm current. East Australian warm current. East Australian current, and it is in a warm. Understood? Always on the eastern coast of the continent has warm. East Australian warm current. इसी की वजह से यहाँ पे China type of climate you can be able to see. There is China type, and then coming of it. Now there is a Tasmania. Which Tasman sea is there? Which sea? अब ये मुझे बताओ, this cold water and this warm water, they are not mixing. जैसे दूसरे जगह mix हो रहे थे, यहाँ पर it is what I said that under the Coriolis force it keeps on deflecting like this. Yes or no? And there is a Tasman sea. यहाँ पर एक front formation हो जाता है. Which kind of formation? And that is known as a Tasman front. What is known as Tasman front? Understood? What is the name I said that? In the Tasmania say it is moving in the name of Tasman front, and under the effect of westerlies it keeps on moving. And thereafter passing through the northern island of New Zealand. And its name become here Auckland current. Which current? Which current? Auckland पता है ना? New Zealand का? In the name of Auckland current. Its name become what? Auckland current. So it keeps on moving under the effect of influence of westerlies, and it is able to reach, I said that, subpolar low pressure zone. Understood? Understood? What are the name I said this? East Australian current. Thereafter I said, बोला करेंगे East Australian current, Tasman front, East Australian current, Tasman front, Auckland current. And Tasman front यहाँ से after the East Australia, here it is in what subtropical high pressure, but thereafter the westerlies it is becoming ineffective. Tasman front, Auckland current, and it is able to reach to the what? Subpolar low pressure zone, and thereafter the level of water is up. One current started moving in the name of, I said that, toward the subtropical high pressure belt, and that is known as, I said that, cold Peruvian current or Humboldt current. What is the name? Cold Peruvian current or Humboldt current. Cold Peruvian current and Humboldt current. And now this one is started under the southeast trade wind. Southeast trade wind is there, and they make it again what? South equatorial current. So we have been able to see that which are North Pacific guy and South Pacific guy. From here, one current started moving from here like this, and its name may be, it is not able to go towards Antarctica. One towards the polar high pressure from the subpolar, and then Antarctica, then obstruction by the Antarctica and east wind drift. east wind drift, it is not able to move toward this, and they started moving in the name of, yes, tell me, it is moving in the name of west wind drift. In between, due to the island, presence of island, what I said that there is a presence of island, one part of the current become Falkland current. This west wind drift जो आपने देखा था Falkland current ब्राजीलियन करंट के साथ मिला था. फिगर के लिए मूव करते रहते हो, ये देखो बंद करो. Said that Falkland current and here it is in a west wind drift. Understood it? Clear? So we have been able to see this section. Clear? So I am going to take the name North Equatorial current, South Equatorial current. बार बार बोलो North east trade wind, South east trade wind, समझ में आ चुका है? Then there is an I said that Kuroshio current, parts of it from the Coral Sea, Arafura Sea, then coming towards and thereafter it is what? Pacific, Philippines Sea and East China Sea. Understood? They become get together and under the geostrophic flow it becomes Kuroshio current, and by south of Japan it becomes two divisions, Tsushima current and Kuroshio extension. Further it meet and under the effect of the westerlies keep on moving eastward, and thereafter it meet with किसके साथ मिला? Yes, Toyashio current, and further moving under the westerlies North Pacific current, and it has been divided into two. Yes, and what are the name? Cold California current and warm Alaskan current. Warm Alaskan current further become, yes, Oyashio and Aleutian by meeting with the Bering current and all, and the loss of water accumulation. And then we have been able to see South Equatorial current, East Australian current will be weak or strong. East Australian current will be weak or strong. Huh? Because the water has gone and it has given the water in this region. And thereafter I said that Tasman front by breaching under the westerlies started moving just near to the Tasmania Sea, in the form of westerlies, it started moving eastward, and then what is happening? It is known as some kind of front formation. It looks like front formation. It is known as Tasman front, and then east of New Zealand, its name become Auckland current, and further under the influence, it is able to reach subpolar low pressure in the form of South Pacific current. And South Pacific current, subpolar low pressure reached, and then there it is. Then we have been able to see it is moving in the name of, I said that, cold Caribbean and समझ में आ चुका. Next it is Indian Ocean. In the Indian Ocean, you can see, like I said that, और ये जानिएगा, these ocean currents also little bit shift with the pressure belts, little bit shifts, not too high, little bit shifting is there. So which ocean current south of which? I said that its name is, under the southeast trade wind, it is in a South Equatorial current. And there will be, it has been bifurcated further under the subtropical high pressure belt and the equatorial low pressure belt, declination of water. Further, it is moving toward the 15 degrees south latitude. It is bifurcated by Madagascar. One it is in the east of Madagascar, one is in the west of Madagascar, and its name become, it is in a Madagascar current and it is Mozambique channel. Understood it? A small, what is in a, not very finer, there is a, यदि ये बहुत छोटा होता तो इसको मैं बोल देता क्या, straight, but it is not under that kind of very finer, a small channel of water connecting two large water body, it is known as what? Strait, S-T-R-A-I-T. लेकिन यहाँ पे थोड़ा सा small channel से wider channel, it is known as a channel. So the ocean current which is moving between Madagascar and Mozambique, its name become Mozambique Channel. Understood? South of Madagascar they meet. What is the southern tip of this South Africa? What is the south latitude? आपको मैंने इसका बताया था 40 and ये कितना है 38. So it is in the subtropical high pressure belt. अभी भी ये कहाँ पे है? So this ocean current south of Madagascar, the Madagascar warm current and Mozambique warm current get together and इसके नीचे में आएंगे तो यहाँ पर एक क्या है? There is an I said that Agulhas Plateau. Below there is a name is I said that Agulhas Plateau. And on the basis of that, its name become Agulhas current. What is the name I said that? Agulhas current. And after that, they come under the influence of, I said that, Westerlies, and they started moving in the name of South Indian current. Understood? South Indian current and able to reach to the what? Subpolar low pressure. And subpolar low pressure. अच्छा, what is 90 degree east? कभी what नाम सुना है? 90 degree east ridge? नहीं. अंडमान निकोबार से यहाँ से एक रीज जा रहा है 90 डिग्री लैटिट्यूड है, लॉन्गिट्यूड. इंडिया का क्या है 68 डिग्री 7 मिनट टू 97 डिग्री 25 मिनट. इट इज एन ईस्ट वेस्ट एक्सटेंशन. सो यहाँ पर ही है क्लियर. एंड देयर आफ्टर थोड़ा सा बाइक दे हैव पुट इन सम ऑब्स्ट्रक्शन बट इज नॉट पुटिंग एनी मोर. एंड देन one it is in a subtropical high pressure and it is in a what polar high pressure. So one it is moving in the name of what I said that West Australian cold current and it is in a what it is getting obstruction by the what is Antarctica and east wind drift. It become, just tell me, west wind drift. South equatorial current, Madagascar current warm, Mozambique channel, Agulhas and North Indian current, and this is coming over there. And after that it is in a cold. ये कैसा होगा? Cold West Australian current, and again the South equatorial current. The south east trade wind, it becomes South equatorial current. Understood? Do you know that during summer, and yes, this kind of situation will be in the summer as well as in the winter. This situation will be in the summer as well as in the winter. समझने की कोशिश करना आप लोग. Is there any counter equatorial current? Yes, tell me. Accumulation of water can lead to what? Counter equatorial current, but there is no counter equatorial current. During the summer, there is no counter equatorial current. Means accumulation of water is not there. और जो भी accumulated है वो कहीं न कहीं और ट्रांसफर हो गया. So let us see. Summer में यहाँ पर summer हो या winter, there is a northeast trade wind, southeast trade wind. Yes or not? But in the case of India, here it is in the summer is there. Then in that case there is a what? No northeast trade wind. What is there? Southwest monsoon. Getting my point? What is there? What is there? So कैसे बन सकता है? North equatorial current तो बन ही नहीं सकता है. Yes or not? Only there will be development of South equatorial current. There will be no development of North equatorial current. Understood it? Now let us see the answer. Southwest monsoon क्या करेगा? They will drag this. This is in a wind itself. Monsoon तो नाम इसलिए दिया गया because there is a regular reversal of wind. Now suppose करो it is putting in a pressure और ocean हमेशा किधर move करता है? Ocean current along the coast. And यहाँ का accumulated water that has been put and pushed here it is. तो यहां का वाटर कहां चला गया है? देयर, यस टेल मी, हियर, यहां पे एक्युमुलेशन हुआ था. Now there will be no counter equatorial current. This water has moved from here, and another, because of the southwest trade wind, better to say, this region water will also move from here to here. Okay? So accumulation of water in this region. In this region, yahan this region has been fed by whom? South equatorial current. But this region will be fed by whom? The accumulated water will start moving toward this. So that current is moving like this, and after accumulation under the slope they will move toward this, and then again they started supporting what? South equatorial current. Understood? So which ocean current developed? Which ocean current developed? Southwest monsoon current. It is known as what? Southwest, इसका नाम ही है Southwest monsoon current, and it has been developed under the influence of Southwest monsoon. So there is no northeast trade wind in the northern hemisphere. यहाँ पर summer के समय में what happens? There is no northeast trade wind. Southwest, because it is crossing and the land has become highly heated. So it is not like I said that in Pacific and Atlantic. It is not an open sea. So there is a throughout the year northeast trade wind, southeast trade wind. Only India is the region where the northeast trade wind is not in a permanent wind. Yes or not? There is a regular reversal, and that regular reversal is considered as a what? Monsoon. And thereafter, when it started moving like this, they drag the water here, they drag the water here, and then it started moving from, and there is a lack of water from here. इसको fill करने के लिए it is coming. So there is a development of what? Southwest monsoon current during the summer. Next one कौन सा आएगा? Northeast monsoon current, and during the winter. So in the winter period, this thing will remain the same. थोड़ा सा केवल इधर शिफ्ट करेगा belts. And I said that, ध्यान से, the northeast trade wind is moving. And the northeast trade wind यहाँ से water को क्या करेगा? There is a what? Land mass is there. And due to the land mass, what happened? The water came over here. And from here, water came here. And then water came here in this region. And then there is a lack of water in this region. यहाँ से water यहाँ गया इसको fill करने के लिए, that is coming over there. Yes. And यहाँ पे कम हो गया इसका slope, then it is filling here. So there is a development of northeast monsoon current, and there is an accumulation of water, and this has also accumulated, and there is a development of counter equatorial current. What will be there? During the winter there will be winter में क्या होगा? Yes, tell me. Again there will be, I said that summer या winter, south will have the same structure, yes or not? But in the summer there is a what? Southwest monsoon current, and in winter there will be, I said that, northeast monsoon current. Understood it? Under the effect of what? Northeast trade wind. Again, I said that in the summer this is coming what? Southwest monsoon current. And कल मैंने बताया that during the summer थोड़ा सा यहाँ पे develop होता है due to what I said that? Upwelling, Somali current. Yesterday I have discussed. There is a development of what? जब भी western coast पे when the wind is moving away, there is a development of upwelling will be taking place, and that upwelling causes Somali cold current. So in the summer in Indian Ocean में क्या देखेंगे? Summer southwest monsoon current, and another I said that Somali current. But in winter there is a northeast monsoon current, and there will be, yes, counter equatorial current. So there will be two things will be there during the summer and in winter. Okay? So it is in a modifying factor. The third modifying factor is which one? Seasonal change. And that we have seen in the what? Indian case. Understood? India के केस में हमें नजर आ गया. But south will remain the same. Southern. So therefore there is only one gyre in Indian Ocean. Which gyre? South Indian gyre. Understood? Only one gyre in the Indian Ocean, South Indian gyre. Ocean current. Only the name. Wind and its friction, density. P4 दो प्री है ना बोला, एक एटमॉस्फेरिक प्रेशर, प्रेसिपिटेशन, कॉलिस फोर्स जिसमें हमने एकमैन स्पाइरल, एंड देन melting of glacier, third, seventh, temperature difference, and then modifying factors and seasonal change. Completely okay in your mind? Tell me the name of North Atlantic Ocean current, every. Eastward. North is divided into Norwegian current. Divided in the form of North Atlantic current. It is in the name of South Atlantic current. West wind drift. In the name of west wind drift. Subtropical high pressure. No, Benguela current. और वहाँ पे गिनिया करंट भी है, काउंटर इक्वेटोरियल करंट भी क्लियर है. जस्ट यू शुड हैव द पिक्चर. जाकर तुरंत आप जो भी समझें उसको लिख लेना. देन वन नोट्स विल बी प्रोवाइडेड फॉर द करंट्स, अलग से भी आपको दिया जाएगा. इज इट क्लियर? And the same way North Equatorial Current, South Equatorial Current, the Pacific, Kuroshio Current, just I am saying in the short, Kuroshio Extension, Tsushima Current, meeting with Oyasio, North Pacific Current, Cold California Current, Warm Alaskan Current, Oyasio, Aleutian Cold Current. Thereafter South Equatorial Current, East Australian Current, and then it is in a Tasman Front, Auckland Current, and then it is in a coming subpolar low pressure, Benguel, Peruvian Current, and the West Wind Drift. And parts of West Wind Drift become Falkland Current, that you know. And then in the South Indian Ocean, South Equatorial Current, Madagascar Current, and west of Madagascar, Mozambique Channel, and then get together Agulhas Current, South Indian Current, and then we have been able to see again West Australian Cold Current and West Wind Drift. Understood? But in the summer time, there is a southwest monsoon, S for southwest monsoon, S for Somali Current. In the winter time, there is a northeast monsoon current and counter equatorial current. So the counter equatorial current, especially question can come, discuss the ocean current pattern in the northern Indian Ocean or near Indian subcontinent. तो पूरा explain करना होगा. Southwest monsoon and northeast monsoon, Somali current, and why there is a north equatorial current only during, yes, only during winter, only during winter, counter equatorial current. Understood it? So we have finished with this. Now we are going to see El Nino, La Nina, and I said क्या है? Indian Ocean dipole. And then we have to make the map of the world, 3 maps. Especially Africa. This Africa region should be there. Africa, India, Australia, and this Indian Ocean and Pacific Ocean should be visible. और साथ में हम लोग एक और देखेंगे MJO, Madden-Julian Oscillation. the same kind of map you have to draw three. This is I'll show you normal condition, then I'll show you La Nina condition, then I'll say El Nino condition. And you can draw in on the three different pages. ये चीज बाद में draw करना. That should be there. ये this picture should be, it will be same for normal and La Nina. लेकिन El Nino के लिए this picture will get changed. पिक्चर बन गया, तुरंत आपको समझ में आ जाएगा. So अभी यहाँ नहीं ध्यान दे. When I'll come for the La Nina, at that time we have to give consideration toward this. This is sunspot. So let us see. In general terms, what happens? And जहाँ जहाँ पे example important लगे, that you have to write down the figure, those important words. In general terms, we know that there is an, I said that there is a south equatorial current. What is there? South equatorial current and north equatorial current. Understood? And this water used to accumulate. This water used to accumulate in this region, and thereafter, you know that आपको मैंने बताया था कि this water is also coming into this region. So this region may, over the some period of time, in this region accumulation of water become very high, and that reached around 50 to 70 centimeter. The height of the level of water in this region, and थोड़ा सा आप ध्यान भी देंगे कि Pacific Ocean कितना बड़ा है. It is half of the, around half of the, yes, circumference of the equator. It is very big. It is very big, half. And you can say that 40,000 kilometer is, I said, that circumference of the equator. So it is around 17 or 18,000 kilometer. So I said, लेकिन यहाँ पे comparatively आपको छोटा दिख रहा है, correct? So I said that there is an accumulation of large accumulation of water, and the level of water we are doing first normal condition. Normal condition. So India is having a normal kind of rainfall. Understood? So how do the India is behaving when this kind of things are there? Then south equatorial current and north equatorial current. और आपको पहले भी मैं बता चुका हूँ in the climate also, when it is getting up, it creates a high pressure. नीचे में क्या होता है? Low pressure. And this side, if it is high pressure, then automatically more air can come into this region. This will become what? More air come into this region, they become high pressure, or इसके comparison में they will become, and then after that it is descending over there, and there is a high pressure, and then this circulation, and this circulation is known as Walker circulation in the Pacific and all. This is a WALKER, Walker circulation. I said that North Equatorial current and South Equatorial current keeps on coming and accumulating the water over some period of time. This region has water 2, 3 years or 4 years, that becomes, I said that accumulation of water in the range of 50 to 70 centimeter high. Understood? And when they are started, it becomes high, and the warm water is this, and that is also going in the form of what is in a corrosive, and आपको पता है कि corrosive current is in a corrosive black stream. Yes, so this accumulation of water become very high, and then the warm water keep on evaporating. Yes, and keep on evaporating, and warm air rises and evaporating and coming here. It is in a formation of cloud, and then when it is coming above, it become in a high pressure in the upper atmosphere on the western part of Pacific. On the western part of Pacific, it is able to create what? High pressure in the upper atmosphere, low pressure on the ground, on the sea surface and all. And when it is able to, and then good amount of rainfall started happening, and high pressure. And when it is a high pressure, they found there is a low pressure toward the eastern part of Pacific. Toward the eastern part of Pacific in the upper atmosphere, low pressure, and toward the eastern part of Indian Ocean, western part of Indian Ocean, there is a low pressure in the upper atmosphere. Clear? Again, I said that over the some period of time, North Equatorial current and South Equatorial current in the Pacific is able to increase the level of water till the height of, I said that 50 to 70 centimeter. That is, I said that 1, 2, 3 years it is happening like this. And level of water is normally 50 to 70 centimeter, and then they started giving large amount of warm water vapor into the atmosphere, and the upper atmosphere it causes good rainfall in the region of Australia, and then there is some Southeast Asian countries and nearby region they started getting good rainfall. So there is also rainfall is happening in this region. But after moving in the upward direction, it created a high pressure in the upper atmosphere near Western Pacific and Eastern Indian Ocean. High pressure in which region? Western Pacific and comparatively towards the Eastern Pacific and towards the Western Indian Ocean, in the upper atmosphere is low pressure. The wind started moving toward this, and after becoming heavy enough, they started descending down. After becoming heavy enough, they started what? Jab low pressure, then it is coming it become heavy enough to descend down. And when it is descending down, so this region has, I said that this region has cold Peruvian current. Understood? So when it is descending down, under the adiabatic compression, it increases the temperature. Extra heat. But in this region, the extra formed heat has been absorbed by the cold Peruvian current. It has been absorbed by the cold Peruvian current. But in the region of Western Indian Ocean, that descending air has created what? Adiabatic compression heat, and then good amount of moisture. Good amount of what? And this moisture has been carried by southwest monsoon, and India receives good rainfall. समझ में आ गया? India receives good rainfall. And this circulation, this kind of circulation is known as what? Walker circulation in the normal condition. Again, I said that South Equatorial current and North Equatorial current is moving. They are able to accumulate good amount of warm water till the height of 50 to 70 centimeter in the region of Western Pacific. In the region of what I said that? In the region of what? Western Pacific. And this started, warm water started evaporating above in the upper atmosphere, created good amount of cloud and rainfall, and upper atmosphere become, when the Western Pacific and Eastern Indian Ocean, high pressure. Comparatively, Eastern Pacific and Western Indian Ocean compared to this in the upper atmosphere is low pressure. The wind started moving toward this low pressure zone, and then after becoming heavy enough, they started what? Descending down. In the Eastern Pacific near South America, at the Peruvian coast, descending air has created through the adiabatic compression heat, but this extra heat is absorbed by cold Peruvian current. But on the western Indian Ocean, when it is descending down, it is not able to create, yes, वहाँ पे कोई absorb करने वाला है नहीं, so the adiabatic compression increases the heat, and that has caused, yes, tell me, more moisture, and this more moisture has been carried by southwest monsoon, and then India receives good rainfall. Understood? Next one we are coming for La Nina. Where did I say that? La Nina. I said, जो हम दिखाने जा रहे हैं sun spot. Generally, if we see that as it is in the Indian Ocean, as it is in the mantle, warm hot magma moves up, and after becoming heavy enough, they started what? Descending down. So there is also nuclear fusion is taking place, hydrogen is converting into helium, heat is generating and becoming lighter, they started moving up in large amount, and then they started heavy enough, and helium becomes heavy under the pull of gravity, they started moving down. So these things are happening in the sun also. What is the temperature of the photosphere? 6000 degrees Celsius. Sun ka outer layer ka temperature kya hai? 6000 degrees Celsius. Understood it? And when it is going down, the reason where it is going down, it become colder, heavier enough. Energy is less. Yes or not? So when it will go down, the two place will become what? No kind of energy. What is releasing? By the nuclear fusion, then what will happen? It will become black. So the black spot, sun spot, is always forming in pairs. Sun spot always forming in pairs. Getting my point? And that kind of, वहां पर क्या बन जाते हैं? They become two poles, magnetic poles. They become two. One, it is in a positive north and south. And from these two sun spots, remember that these two sun spots become one. I said that magnetic poles. And you know that from the north to south, what happened? Magnetic lines of force. And these magnetic lines of force, if I say that is coming like this, these magnetic lines of force, you can be able to see this is solar flares. और ध्यान से पढ़ेंगे इस लाइन को. After that you will become क्यों sun spot में climate change can be also one of the responsible for it. I said that solar flares are tremendously explosion on the surface of the sun. What is the temperature of photosphere? यहाँ पे आप देखने जा रहे हैं 1 million degrees Celsius. I said that explosion on the surface of the sun in the matter of just a few minutes. TNT समझते हैं TNT? Trinitrotoluene. It's an explosive one. सुना होगा. I said that in a matter of just a few minutes, the heat material to many million tons of degree temperature comes, release as much energy as a billion megaton of TNT. Sun spots से कितना energy निकल रहा है? Magnetic lines of force के form में? Billion, not million. Billion समझते हैं ना? 1000 million means 1 billion. Billion, it is not ton, megaton of TNT. This much of energy is releasing, and they occur near sunspots. Understood it? And what is the temperature becomes? Just tell me in just a minute of time, what is the temperature? Million of degrees Celsius. So during the sun spot, sun rays heat will come more toward the sun, earth, or less it will come more. And it has been said that sometimes, as the number of sun spot, it has been said that it takes an 11-year cycles. It takes an what? One cycle takes number of sun spot becomes more. If the more sun spots become, more hitting toward the Earth's surface, and when the number of sun spot decreases, less hitting toward the Earth's surface. It has been also correlated, some scientists, with the ice age in India. If the ice age in the world, I said that when the sun spot number reduces, the less it is coming, and that has, for a period, it has lead to the somewhere climate change also. But अभी हम लोग देखने जा रहे हैं sun spot. अच्छा, now tell me, आपको मैंने बताया था कि one earth is like this, suppose, and then magnetic lines of force यहाँ से निकलता है. Perhaps you remember that north and south, and south and north, and it is coming like this. इस रीजन में क्या देखोगे? वीक मैग्नेटिक लाइंस ऑफ फोर्स. वेयर इज द वीक मैग्नेटिक लाइंस ऑफ फोर्स? एट इक्वेटर मैग्नेटिक लाइन. सो you can see, like I said, that only few minutes of time there is a 1,000,000 degrees Celsius temperature, and you can say these are in the form of solar flares. When it is coming to the Earth's surface, they will be obstructed by this reason more. They will be obstructed by this reason more. And at equator, magnetic lines of force, magnetic fields are very less. So the heating intensity will be more near to the equator. The sunspot heating intensity will be more near. Yes, tell me, more near? Yes. So if I am saying that if the heating spot is more near to the equator, yes, then you can be able to see if there is a solar flares during the sun spot is increasing, then it is coming more near to the equator. And when it is coming more near to the equator, equatorial low pressure will intensify. Equatorial low pressure belt, especially the Pacific, is the largest water body. And when it has been intensified, then amount of air which is rising from here, it will be more. Yes or no? And when more rising, then it will go more downward. Then it will move more towards the North Pole and move more towards the South Pole. And when it is moving more towards the North Pole, then it is descending more at subtropical high pressure belt and more at subtropical high pressure belt. It means when the subtropical high pressure belt, when the wind is descending more, then the northeast trade wind and southeast trade wind become more effective in comparison to normal. Yes or not? What happened? During sunspot, what happened? Northeast trade wind and southeast trade wind become more effective in Pacific Ocean. I said that northeast trade wind and southeast trade wind become what? More effective in which region? Yes, tell me. Pacific Ocean. Is it clear? Who causes? Simple money bolunga, due to the what is an increase in sunspot. Yes, it happens in 11-year cycles. Yes, and due to that the more heating is coming near to the equator, and when it is coming more near to the equator, then the equatorial region become highly intensified low pressure. When it become highly intensified low pressure, the more air is going, and therefore equatorial low pressure become highly intensified low pressure, and then subtropical high pressure become also more descending of it. Northeast trade wind and southeast trade wind become very strong. Understood? And when they become very strong, they will carry more north equatorial current and more south equatorial current. Yes. And when they carry more north equatorial current and south equatorial current, it reaches to the 80 to 100 centimeter raise the level of water. पानी बहुत ज्यादा लेकर आएगा नॉर्थ इक्वेटोरियल करंट. If the northeast trade wind is more, southeast trade wind is more, the north equatorial current speed will be more. Yes or not? Northeast trade wind and southeast trade wind is more, the north equatorial current is south, and then what is the level of water? What is the level of water? 80 to 100 centimeter. So they will evaporate more warm water. So this low pressure will become more low pressure. Yes or not? And more evaporating of water, this high pressure will become more high pressure. Comparison to, if the more moisture is coming up, then this region will become more rainfall and more rain. I said more high pressure. So what happened? More high pressure, the wind will move faster toward this Eastern Pacific. Same चीज मैं बोल रहा हूँ normal condition की तरह. And there it is moving toward the Western Indian Ocean. And their descending is what? Will. अच्छा ये मुझे बताओ, southeast trade wind is very fast. है ना, southeast trade wind is. So when the southeast trade wind is very fast, it will upwell more colder water. Yes or not? यहाँ से cold water, offshore wind, it is acting as, it will upwell more cold water. So नीचे का thermocline layer will come up. So this region colder water will become very high. Is it okay now? And when the winds are descending compared to the normal condition very high, so there this adiabatic compression heat generated is absorbed by thermocline layer, cold water. Yes. पहले कम था, but this time when the southeast trade wind become effective, there will be now what I said. and when it will become, the colder water will be more. Colder water will come much more in comparison to the normal condition. And in the normal condition, I said that, suppose I said that normal condition is there, but I said here it is more cold water will prevail in this season. Western Pacific, in the Eastern Pacific near Peruvian coast. So the Peruvian cold current become very strong current, and then descending air has been absorbed, but here adiabatic descending air will what? Create more moisture. More, and then southwest monsoon will carry more moisture, and India will receive more than normal rainfall. And that is known as La Nina. That is known as what? Understood it? That is known as La Nina. Again I said that. What I said? Which are the factors I said? First, it is in a just accentuate form. You see, किस form को accentuate कर दिया मैंने? Normal condition has been accentuated. By whom? Sunspot. And sunspot increases the more low pressure, equatorial low pressure, intensified. And further it has moved up. And then it started moving towards, I said that what? Polar region, and then heavy started descending by the subtropical jet stream, subtropical jet stream, and they started heavy descending, and subtropical high pressure belt, subtropical high pressure become very strong, and then therefore strong trade wind started moving. And a strong trade wind has created a more and more amount of what? North equatorial current and south equatorial current, and this reason level of warm water is creating very high, and where it is in a very high, the more and more moisture will come, and more moisture, that is 80 to 100, and then it will become more high pressure, low pressure, and more high pressure in the upper atmosphere on the Western Pacific and in the Eastern Indian Ocean. So upper atmosphere high pressure, and then wind started moving towards East Pacific and the West Indian Ocean, comparatively low pressure, and then started descending down. And then, but more cold water of thermocline layer of Eastern Pacific has been absorbed the adiabatic compression heat generated. But on the Western Indian Ocean there is no cold ocean current. So adiabatic compression created what is more heat, and that heated region created. आपको समझ में आ रहा है? यदि wind इतना तेजी से उतर रहा है large, then it will generate how much heat, and because of this there will be more moisture. And then southwest monsoon जब यहाँ से जाएगा, they will carry more moisture, and that is causing rainfall in, what is a flood in India. Rainfall in India more than normal, and there will be flood in India at several parts. So normal condition, and thereafter which condition we have been able to see? Yes, La Nina. समझ में आ चुका है? Normal condition and La Nina. Is it okay? उसके बाद क्या होता है? There is a sudden change in, I said that sunspot decreases, and therefore sudden change in sunspot decreases, that reduces. Suppose I said that low pressure, यहाँ पे suppose low pressure मैंने बोला, one low pressure is there. इस low pressure से sunspot ने क्या किया? In normal condition, I said that there is a low pressure is like suppose 990. But in normal condition, but I said that low pressure in La Nina condition it become 980. पहले कितना था? 990. Normal condition. Suppose and there now low pressure become 980. Suppose I said. लेकिन after the La Nina condition, थोड़ी देर के बाद ही sunspot highly decreased. Sunspot highly decreased, तो it should be again 990. लेकिन ये 990 ना होकर क्या हो गया? 1000. Low pressure is hitting towards the equator more decreased than the normal. Hitting towards the equator decreased than the normal. So the intensification of low pressure at equator, is less than the normal. And then when the less intensification, then the less air is rising, and the less air is rising, the less intensified subtropical high pressure belt. Then what will happen? Northeast trade wind and southeast trade wind will become weak. It will become weak, and then you can see that यहाँ पर क्या हो गया, weak trade winds. What happened? What happened? Weak trade winds now, and when the weak trade winds happen, तो ये the trade winds, then the north equatorial current and south equatorial current also become very weak. और ये weak, he cannot sustain this water. Understood? इतना बड़ा, that is 1 meter तक उठा हुआ पानी that cannot be sustained. और यहाँ पे कौन सा चलता है current? Which current goes? Counter equatorial current. Now this accumulated water, they started moving toward the South America in the form of, along with counter equatorial current, and that is known as, I said that, Kelvin wave. This counter equatorial is in the form of what? अब El Nino third picture के लिए आपको I said that Kelvin wave. This counter equatorial current is coming back with a large warm water, and in the name of, is it okay? It is in the name of Kelvin wave. And यहाँ से this cold water has been replaced by the what? Warm water along the Peruvian coast. Warm water along the, and that is known as, this ocean current name is El Nino current. The warm ocean current, Kelvin wave, reaching to the Peruvian coast and remove the colder Peruvian water, it is known as El Nino current. Understood? Now what happened? यहाँ का सारा water, all the water from this region has what? Moved away. Now it become warm, low pressure. Comparatively, ये क्या हो गया? This region become comparatively what? High pressure. So this region become high pressure, and this is, I said that, लो प्रेशर. पहले ईस्ट अफ्रीका में रेनफॉल हो रहा था, यहाँ पे एयर डिसेंड होगा तो रेनफॉल होगा? नो, क्योंकि यहाँ के सारा मॉइस्चर तो इधर जा रहा है. ईस्ट अफ्रीका इज इन ड्राउट कंडीशन, पेरिवियन कोस्ट इज इन द ड्राउट कंडीशन, they are in the drought condition. And which are the rainfall? This portion is getting rainfall, Indian subcontinent is getting rainfall. But now this time it has been changed. And what happened? This become low pressure, it become what? And then यहाँ पर क्या होने लग जाएगा? Warmness की वजह से it will be started, and comparatively this region become high pressure, and then high pressure, and it become low pressure, and then what will happen? Wind will start coming here. So it is known as what? Reverse Walker circulation. What will you say that? Which circulation starts? Reverse Walker circulation. Which circulation I said that? Reverse. Understood? Now Western Indian Ocean कैसा बन गया? Tell me. Low pressure. Eastern Indian Ocean become what? अब now wind will come towards East Africa. Wind will come towards, यहाँ से जो लेकर भी जा रहा था पहले तो मॉइस्चर कम हो गया. Moisture is reduced, which the adiabatic compression is giving, and the low pressure is making the what? East Africa to what? Rainfall. And यहाँ पर I said that Peruvian coast to be rainfall. Coastal region become low pressure. इसका मतलब क्या है? Onshore wind. And then यहाँ से जो साउथ वेस्ट मानसून जा रहा है, they can carry very less moisture जो कि available उसको जो मिल रहा है. Yes or no? And this way, I said that East Africa, Peruvian coast started getting rainfall, but Australian and this region started getting very less rainfall, high pressure condition, and when the southwest monsoon goes, they carry very less moisture and then causes what? Rainfall less than normal. Causes rainfall less than normal, and it is known as El Nino. It is known as El Nino. No means no. इसका मतलब can I say that यहाँ पर क्या हो रहा है? पहले ये low pressure, this one is high pressure, this one is it has been changed. तो क्या मैं बोलूँगा इसको oscillation? It is oscillating. Yes. So El Nino and La Nina, both the condition are known as ENSO. El Nino Southern Oscillation. So it is happening in the Southern Pacific, and here it is. So it is considered, and I said that El Nino Southern Oscillation. Understood? So normal condition, I said that, is it clear? What is the level of water? 50 to 70. And La Nina condition, what is the level of water? 80 to 100 around. And after that sudden decrease in the what is the sun spot and all, the heating intensity reduces, strong trade wind become very weak. North equatorial current and south equatorial current become weak and cannot be able to what? Hold this water, Kelvin wave. And it is able to reach East Pacific and make the Period cold current to remove. Understood? And it is making war. Clear? ये समझ में आ चुका है? ये El Nino समझ में आ गया? Now I am going to talk about another impact that El Nino is going to give. Is it okay? Now can I say that slowly and slowly this warm water come and here become the part of west wind drift. They become the part of what? West wind drift. And when it become the part of west wind drift, यहाँ से ये वेस्ट विंड आ रहा है, इसी में से आपका ऐसे कुछ वाटर इसमें भी जा रहा है, and here it is coming, some of the west wind water also become the West Australian cold current. This El Nino has reduced the coldness of West Australian cold current. This El Nino reduced the coldness of, yes, और cold current जितना cold होता है, if it is more cold, suppose if it is more cold, then there will be what? High pressure more, and it has reduced the coldness and high pressure region Indian Ocean, Southern Indian Ocean. So कुछ समय के बाद ये भी impact, ये थोड़ी देर में कुछ दिनों के बाद this impact looks. Suddenly इतने large level पर water cannot move. Water takes time to move, yes or not? And thereafter that it comes in an interval of 3 to 7 years. I said, and some books said 4-5 years, 3 to 6 years doesn't mean आज के डेट में global warming and they have changed the system. So I said that further it has reduced the subtropical high pressure zone intensity in southern Indian Ocean, and therefore monsoon further become weak. And then it reduced the, क्या समझ में आ गया? Which are the things we have seen? First, normal condition, thereafter La Nina, and then we have seen El Nino. दिमाग में revision करते रहेंगे. Things are very easy. समझ में आ गया what is happening actually? And now we are going to see Indian Ocean dipole. What we are going to see? Indian Ocean dipole. Indian Ocean dipole in 1997 it has been declared, in 1997 it has been declared that there will be an El Nino year. 1997 is a which year? El Nino year. And it has been declared by the scientists of the world and all. And everybody is expecting that India will receive and all these countries will receive what? Less rainfall. So 1997 has been said that it is in a what? El Nino year. Especially Japan has said this one, वहाँ पर बताएं. And but India received more than normal rainfall. Then they started finding out what is if the El Nino year they should receive less than normal rainfall. They should receive the less than. And what happened? तब यहां पे खोज किया गया, देयर इज एन इंडियन ओशियन डाइपोल. व्हाट इज देयर? इंडियन ओशियन डाइपोल, IOD, Indian Ocean Dipole, and one is positive phase IOD. अभी भी इस पे सर्च चल रहा है, केवल इंडियन ओशन डाइपोल का कंसेप्ट दे दिया इन्होंने कि दिस इज दिस, एंड नेगेटिव फेज Indian Ocean Dipole. The two things are there. One, it is in a positive phase Indian Ocean Dipole. Another is, I said that in the positive phase Indian Ocean Dipole, it has been found that this region of water compared to this region, this become warm and it is comparatively colder. The West Indian Ocean, especially Arabian के पास, Indian Ocean is warm and East Indian Ocean is cold. So warmness gives moisture, warmness gives, and then when the southwest monsoon is going, they have been able to get moisture from this region, and India receives little more than normal rainfall. And negative phase में क्या हो जाता है? That becomes cold, and this region will become, अभी they are finding out what is happening in the negative phase. West Indian Ocean cold and East Indian Ocean warm. Dipole, the two negative different phase poles. कभी कहा गया, one the reason has been said that India is El Nino, so it will get less rainfall than the normal, but at the same time it is negative phase of Indian Ocean Dipole. ये cold हो गया. एक तो क्या हो गया? El Nino and negative phase rainfall will be very less and India will have face severe drought. अब सोचो जिस साल ला नीना हो and then positive phase हो, that year will be what? And in the 100-200 years such condition comes. अभी भी लोग search कर रहे हैं what is happening actually. Understood it? So we have seen Indian Ocean Dipole. I said in Indian Ocean that it is in a Western Indian Ocean is what? Warm, and Eastern Indian Ocean is cold. It is considered in a positive phase. And then when the Western Indian Ocean is cold and Eastern Indian Ocean is warm, it is known as negative phase. जो हमें support करेगा, that is positive. Those will not support monsoon, it is what? Negative. So we have seen, like I said, that this one. Is it okay? Madden-Julian oscillation, MJO, Madden-Julian oscillation. दोबारा ये पिक्चर आपके पास होना चाहिए. This picture you should have. MJO. I said that यहाँ पे क्या हो रहा है? What is happening? Convection. और यहाँ पे क्या हो रहा है? Air is descending, suppression. This kind of convection, one small circulation of wind develops from the West Indian Ocean to East Pacific Ocean. And I said that one small circulation with the convection and two-side separation. With convection and two-side separation. And it keeps on moving. How it moves? West to east. How it moves? West to east. Clear? And after certain period, this will be here, this will be here, and then again it can be here. And जहाँ पे आप convection upward देख रहे हैं, there will be, I said that cloud formation, and there will be rainfall. This region is what? Rainfall. And this cycle keeps on moving, and then it is able to come Eastern Pacific region in the interval of 30 to 60 days. Start from West Indian Ocean and finishing at East Pacific. उसके बाद जैसे ही वो Atlantic में जाता है, he is not able to form this kind of it. Again it comes from the Atlantic, again in the Western Indian Ocean, you can be able to see their formation. Understood? So after every 30 to 60 days, there is it start moving from West Indian Ocean to what? East Pacific Ocean. Or a small circulation, you will say, the small circulation, atmospheric circulation. It keeps on moving from West Indian Ocean to what? East Pacific Ocean. So jahan par it is going like this, and there will be rainfall. And it keeps on moving. It keeps on west to east, and thereafter again it will come back west to east. So in this cycle, in this region, it is west to east, it is happening. Okay, near to the equator. And what is the period? Yes, 30 to 60 days. So therefore, Madden-Julian oscillation, again it will be oscillate and come back. It is happening in the 30 to 60 days period. Okay, and you can see that it starts from the Indian Ocean, and then it is going, and then it will come here, and then the Indonesia side, then it comes into the Pacific side. Understood? So the rainfall from the Indian Ocean starts, and then it keeps on continuing, and then it is day 10, day 20, day 30, maybe 60 tak bhi ja sakta hai. So it is able to come till 30 to 60 days. So here it is known as 30 to 60 day period oscillation, or it is also known as Madden-Julian oscillation. Completely likh sakte hain. So we have seen MJO. So we have finished with the very much important topics today. What we have seen, first हम लोगों ने देखा what is ocean current, and I said that on the basis of speed, stream, current and drift, और कहाँ बनता है stream, where the current, where the drift, that we have seen. On the basis of temperature, warm ocean current and cold ocean current, low latitude to high latitude, warm ocean current, high latitude to low latitude, cold ocean current. Thereafter we have seen factors responsible for ocean currents and all. And then these are, I said, the natural and general factors are, which are wind and its friction, D4 density. याद रखना, again मैंने बोला एग्जाम में जाकर वो पॉइंट्स याद करोगे तो आप लिखोगे भी उतने अच्छे से नहीं. Wind and its friction, D4 density, and then P4 atmospheric pressure, P4 precipitation, and then Coriolis force, the Ekman spiral that we have to explain, and then melting of glacier, temperature difference. And then we have been able to see modifying factors are shape of the coast, ocean bottom topography, and another we have seen, seasonal change. That is only in India, not India. and then we have seen North Atlantic current, Pacific currents, and Indian Ocean. And then we come for normal condition, La Nina condition, and then El Nino, and thereafter MJO.